Day 2 at JPrime. So, are you tired? Or are you like full of energy? Yeah. Okay, so we're full of energy and I'm really happy. And I really like this type of sessions that you are gonna enjoy in the next 50 minutes. It's puzzler sessions, you know. I believe it's gonna be interactive and all that stuff. And I believe that on stage are two of them, I would say, the best people to do this. So please welcome Morris and Dmitry, or Dmitro, what's the right? Dmitro. Yes, yeah. At the stage at JPrime, and enjoy. It's gonna be really awesome.
Thanks. Thank you very much. And thank you, everybody, for coming this morning so early. And thanks especially to the organizers of this amazing conference for inviting us. They actually saw a version of this talk, and even then they still wanted to see it again. So that's really quite strange. So, yeah, we're displaying. Good. So, yes, this is a puzzler session. Many years ago, there used to be Java puzzlers, and there was a kind of a fantastic double act between two real experts, foundational experts in Java, and this was a really good show. I'm afraid you've got us instead today. So, just some brief introductions. Obviously, I'm Morris Naftalin. Well, not obviously, but I am Morris Naftalin. And when I get the hang of this, oh, where's my keynote gone? Where's it gone? Ah, right. So I'm on this, sorry. Right. So yeah, so this is me. I've written a book about Java 5. I wrote a book about Java 8. I'm in the various community programs. And what I really want to tell you about is that the Java 5 book, which was Generics and Collections, is about to come out in a new edition. And quite a lot of what is in here has come from thinking about the new edition, because more things have changed in collections than you might think. Oh, thank you. Oh, that's a nuisance, isn't it? I said no notifications. That'll be back. OK, we'll live with it. So the answers to many of the puzzles you'll see here are in the new edition of Java Generics and Collections, which used to be Generics and Collections, and now it's going to be Generics and Collections. OK, so that's me, and let's go. Oh, wait. Next. Why am I not getting the next slide? Ah, because I don't have the focus on it, that's why.
Yep.
There we go.
And that's me. Good morning, JPrime. Great to see everybody. We got very nice welcome dinner yesterday, so the night was a bit rough, but you know we're still here, so I also see people, which is good. Me, I'm an independent consultant working on Aaron and performance, and I also what they call disorganizer-in-chief for two awesome conferences. One is JCrete in Greece, and another one is JAlba in Edinburgh. Both amazing, so if you haven't been to one of these, please sign up, and I believe Morris.
Yeah, we've got an advert for them. If you want to know about unconferences, if you haven't come across them before, I should tell you something about them, just very, very briefly, bit of an advertisement. So unconferences are not conferences, obviously. They are very informal. You don't have a program of speakers. They're self-organizing. So a bunch of people get together with things that they've got in their head that they'd like to talk about. You don't need to have prepared talks. You just come along and there's a kind of organization happens, but it's not at all formal. And you talk together, you eat together, you socialize together. It's like hallway sessions, only for the whole time. Go to the J Unconference Alliance if you want to find out which unconferences there are, because there's quite a lot of them in the world nowadays, and you can apply for one or many of them there. And the one I want to talk about is JAlba, because I'm the local disorganizer for that. And that one is in Edinburgh, and as Dmitry rightly says, it's awesome. And we even have next year's date already fixed. So please go and look at jalba.scot for details. OK, so I think that's us, isn't it? That's the adverts over. And what we're going to try to do now is we're going to try and puzzle you. And we want your participation. You'll find out how in a second. Here we are. Here's the first one.
All right, so what do we have here? It looks like Java, because the public static void main, right? It's not Java whatever 50. Then we're going to get it all cramped together, Kotlin-like. Anyways, so quite obvious, right? The string array of 1, 2, 3. We create a list, I believe. Is that thing? Yeah, a list. And then an int array, we create a list. And then we print the content. Okay. if the first list contains 1, add a comma, and if the second list contains 1. It's quite obvious, right? I mean, 2 lists with 3 elements each.
Okay.
Contains 1, contains 1.
Okay.
So,
I believe you. I think that's what it's going to print. So you've got a chance now to decide. I mean, it seems to me that's pretty straightforward, but I wish this thing would go away.
Yeah, so what happens next is that this is the code, and you have to guess what it does. If Maurice can remove the thing
Yeah,
from the screen.
absolutely. Let's see what I can do. Oh, that's right, I do this, don't I? So the question is, what does it print? And if you go to menti.com, it's at the top of the slide there, and you enter the number that there is there, then you get to vote. And your choices are, you'll see it on your phone. We need a lot of participation for this.
Yes, so basically the choices are true, false, true, true, false, true, and none of the above. None of the above. I think I saw some of the pulseless talks before, and
yeah,
95% of the time it's none of the above.
None of the above is it's kind of very deceptive.
But,
I mean, it throws an exception or.
But in this case, it's quite obvious. It's true, true, right? I mean, it's like what else? And trust me, I'm certified Java programmer. Right? I've done my certification on Java 6, therefore I know everything. So it must be true.
Okay, so the votes are building up. Now it's really quite clear what the winner is. Every time we give this talk, I think, really, it's a shame that Java's not a democracy. Right? I mean, it's like if only the votes really influenced the outcome, life would be so much easier. Your programs would just do what you want them to do.
Absolutely. So how many votes do we have in total?
Well, at the moment, we've got about 60,
65.
and I'm sure we've got more people than that. Come on. I know this is the first one, so it takes a minute or two to get on there.
Yeah, so if you haven't voted, please cast your vote. It's going to be fun. Oh, none of the above stats, you see?
Yeah, and none of the above is doing pretty well.
Yeah. People expecting null pointer exception somewhere because it's Java, right? It has to be about null pointers.
Okay, I think we should go on because we've got quite a few of these. If you haven't had a chance to vote for this one, don't worry, there'll be more coming up. So at the moment, we've clearly got true, true, followed by none of the above of the votes. Well, let's see what happens when we actually run it. I think this is the right one, isn't it?
Yeah, that's the
cool. Okay, let's go. Arrays.asList.
That's this guy.
And let's see what happens. We're running just the code that you saw there.
True, false.
True, false.
All right.
Go on.
Oh, all right. So this one is quite obvious. You see, when you use IntelliJ, it shows it in yellow, thanks to Tagir and the team. What it means is it tells you that there is a slight problem in your program. Note that int array is a primitive array. And the signature for asList is the var args of t, so t and 3 dots. T is an object, and int array is an object. So what happens is the entire int array is basically boxed. Well, it's not boxed, it's just treated as an object. So you have a single element, and so you, instead of list of integer or list of int, you get list of int array. And so you have a single element, int array inside, and if you ask it contains 1, of course it does not. You would have to ask it contain essentially int array, and then it will be true. But
wouldn't it be lovely if the boxing worked? So you got this array of int got boxed into an array of integer because it can see that that's what you want.
Hey, not the case.
Unfortunately, the democracy doesn't work.
But of course, we're using whatever Java 5 syntax. If we use list of, it's going to solve all of our problems, right?
If we'd use list of, then you would have got it right. So we weren't.
Well, actually,
going to use list of.
Actually, it won't. That was just a joke.
Right. Okay.
Not really. So all the APIs that expect the object var args will not work with primitive.
Okay. List. Right. Onwards. Let's try another one. This one is, this is a sublist one. So, I'll explain here what's going on. We've got this time we are using list.of, and we've got an array list of integer, and then we're going to take a sublist of that. Now, a sublist is a semi-closed interval, or semi-open interval, I'm not sure which. It's inclusive of the first index, 0, so it's pointing at the first index 0, but it's exclusive of the second one. So this is pointing at a kind of, well, you can see what it is, right? And now what we're going to do is we're going to print the sublist, and it doesn't look like it ought to contain anything. And then we're going to add some things to the sublist. We're going to add we're going to make a list of 10, 11, and 12, and we're going to add that to the sublist. And then we're going to print out the original list. Okay? Right. What do you think is going to happen?
Well, the sublist is quite obviously empty, so we're going to print empty. And then we add something to it. It has elements, but we don't touch it anymore. And we're going to print the original list.
The original
it's
list.
Quite obvious.
Well,
right?
it looks like to me. I would say so. So your choices are what Dimitri said, 1, 2, 3, 4, 5. Unsupported operation exception, entirely possible, because we get those a lot in the collections framework. And something else. Which do you think?
Well, come on, it's obvious. So here's my vote, yes. Well,
Yeah.
why it's not
neither of these. They're onto us already.
There are only 4 people that think like me. Okay, it's weird. Unsupported operation exception. Quite plausible, but neither of these.
No, I think, well, unsupported operation is entirely possible, isn't it?
Yeah, I mean, it has to be unsupported operation exception. No, it has to be actually the obvious thing. 2 different lists. Come on. We created a list, it's empty. We added to it, we ignore it, we print the original one. So, I mean, quite obvious. Right?
Okay. Sounds obvious to me.
Okay, we have even more people vote this time. This is good.
Okay, we're up to more than
Shy of
100. But get those phones out. Okay, give it a moment longer. Okay, people are thinking about it.
Yes, people are thinking it.
17, 19.
Democracy is broken.
Yeah, all right. We're doing our best to bring democracy to the Java world. Okay, let's see what actually happens, shall we? Okay, so let's find
2 sublists.
2 sublists. Thank you. Okay, and we'll make it happen.
The moment of truth. Compile and run.
2, right. Okay.
By the way, this has all been run on JDK 19 with default settings.
Yeah, right. Okay, but now look what we got. 10, 11, 12, 1, 2, 3, 4, 5. What? What happened there? You know, the first time I saw this, I did not get it at all. So this is, but what is happening is that sublist is a view onto the original list. It's a way of looking at the original list. We have a lot of these views in the collection framework, and they have different properties, but all of them have the same. One important property that's the same is they don't create anything new. So always you've got some way of getting at the original backing data structure. And in the case of sublist, interestingly, it's really transparent. So like whatever changes you make to the sublist, actually write back to the original list. And in this case, the sublist was pointing to right at the very beginning of that list, and to an empty interval right at the very beginning of it. And so when we wrote 10, 11, 12 into that, that got put at the front of the original list.
It's quite an interesting hack. If you want to prepend something to the existing array list, you can just do sublist of 0, add stuff to it, it appears at the beginning.
So I thought this was really weird when I first saw it, but actually it's completely consistent. So it just shows like...
It's still weird.
Yeah, it's still weird, right. Okay, let's have another shot. You're doing very well, by the way.
Yes. I mean,
What's this one?
I guessed that one.
Whose turn is it?
I can do. Okay, so obviously we have an array of ints. As it says ints, so there must be ints A, B, and C. Those are ints in some dimension. We have a null, also very known int. And then what we do, we just grab a stream of them, convert to a list, print the size, and do a list of and print the size. It doesn't matter how we slice the cow basically here, but it's size of what, 1, 2, 3, 4, and then size of 4. So I would vote it's 4, 4. Coming together without space, right? That's tricky.
Okay, right.
I mean, what else could it be?
But what else could it be? Well, here's your choices. It could print 4, 3, it could print 4, 4, it could print 3, 4, or it could do none of those. Okay, let's see the votes.
Let's
Okay, 3, 4, 3, 4, 3, 4. Yeah.
Okay, 3, 4. People think
no,
it's going to do 3, 4. Because of the stream.
No, well, yeah, because
stream
obviously what they're figuring is that the null gets filtered out.
Get filtered out by what?
From the stream.
By stream. filtered out by steward marks.
It
He
could be
sits
by
behind
stream.
and filters
Could be-
them out.
Yeah, I don't think streams do that, but it could be to-list. Nobody knows what to-list does because it's relatively new.
That's not the collector's to list. Yeah, you're right. This
yeah.
is a new thing. That might be tricky.
It's pretty new, yeah.
Okay, so 3, 4.
Yeah.
Can I change my vote? Is it possible?
I don't know.
It's not possible.
No,
to
you
change the
can't
vote.
change. You can't change your vote. Too late. Too late. You got it wrong. Get off.
Well, what do you mean wrong? I mean, I was minority. It's democracy, you know. It's everything goes, and I'm there on the board. So,
Right.
okay, none of the above. 1, 3, 4. So we clearly have 3, 4 winning. So
3, 4 is definitely winning. Okay.
let's have it a second then. Okay, 116 people.
Okay.
Deep
Right.
vote.
That's what we're getting these days. Yep. Okay. Right. Let's have a look.
Let's run this thing.
All right. So what do I do? What is it? Which one are we?
Handling nulls. It's going to be
Yeah.
3A.
You just have to tell me. each
3A.
time. Right.
3A.
Okay. Right.
Okay, 3B. No, it's you're on the
I've
wrong
done
one.
3B.
You're on the wrong thing.
I've done the wrong one.
I told you 3A.
Oh.
Oh, wow. Maurice, it's okay. Breathe in.
Oh, what a shame. Right, let's go. Right, so
3A.
let's try again. 3A. Right.
You don't listen to me, I'm saying. It's 3A.
No, of course I don't listen to you. That would be. Where would I be if I listened to you?
So nulls.
Okay, right. Okay. Oh, that's what's happened here. We have got an exception. We've got a null pointer exception, and the place where we've got it is list.of. The unmodifiable collections that were introduced in Java 9 are really intolerant of nulls. And one of the themes of this talk is going to be that the treatment of nulls in the collections framework is not very consistent. And the reason for that is because the view of what you can do with nulls has evolved as time has gone by. At the start, in prehistory, in JDK 1.2, in Java 2, nulls were just regarded as another value, basically. But once they started dealing with, once they brought concurrent collections in Java 5, and then progressively since then, null is seen as something which should be a special value. It indicates that, like, if you're trying to get something off a queue and you get a null back, then it should be a sign that there isn't anything available if you've got a non-blocking method. Now, the point is that and with maps, this often happens, that if you get a null back, you don't know whether that means that there was no value there for the key that you're testing on, or that there really was a value there, and it was the value null. So you have to be very careful about this. And one of the ways in which you have to be careful is to remember that the unmodifiable collections, like unmodifiable lists and maps and sets that were introduced in Java 9, won't accept nulls. So we get a null pointer exception for that.
Okay, let's go to the
right,
next one.
onwards. Let's see what we have next.
Obviously, 3B.
This is 3B, which you've already seen the answer to if you were quick to look.
Okay,
because I don't know what I'm doing. So what are we doing here? So we've got a cleverly named array of string called ints. Believe me, altering these slides is not as easy as you might think. So it's an array of strings, and it's got A, B, C, and null in it. So this is another null problem, isn't it? So we're getting arrays. So we turn that into or we get a view of that as a list of strings instead of an array of string, and then we're going to call remove if on this supplying a method handle to objects is null. The objects utility class is really useful with a lot of very, very handy methods like that in it. And you should know it you should get to know it if you don't. And now we're going to print out what the size of the resulting list is. So obviously we're going to, well, I don't know, what do you think? It looks to me like what we're going to do is we're going to test every element of that list in turn to find out if it's null. And if it is null, we're going to remove it. Does that seem straightforward?
Yeah, and we're going to print 3.
Okay, so
is that an option?
I imagine it is an option. 4 is an option. Maybe the remove if doesn't work for some reason. 3 is an option. Nobody's taking 3 so far. This is a bit of a shame. Neither of the above is also an option. Come on, guys.
Okay, there was a spoiler.
What is the matter with these people? It's like they don't believe us.
They believe their eyes, and then they saw it.
They saw it.
Anyways, let's run the code
well,
and just explain
we'd probably better move on, yeah. Well, let's just check it, shall we?
But maybe it's just...
This is 3B this time.
Yes,
isn't
3B
it?
this time around.
So we'll just have a look. I don't understand how I did that before.
You have two of
3B,
them.
right? Okay, so
Maybe it's gonna run this time
you
around.
did indeed see it. So what's the problem with this one? Are you going to explain it? It's not.
Oh, yes.
Won't take you long.
The problem is the views. As Maurice pointed out, we have lots of them, but not all views created equal. In this case, it's not actually a view per se. Well, it's kind of a view to an array. So what arrays list is done is returning a collection that is essentially immutable. You can't add or remove elements to it, but you can change the content of the array. So if you use a set method, for example, you can change the value through iterator. But in this case, we are trying to change the size. So we're trying to remove something from the array. Array is fixed size. You can't shrink the array without reallocation and copies and stuff. So that's why it says, I believe, unsupported operation exception, because the view is read-only. This is one of the things you see in your classical Java projects a lot. So what usually happens if you have an array coming in, you call as list, and you immediately wrap it into a new array list because you want immutability of sorts because you're adding or removing. And that's usually a pattern, unless you use streams and stuff.
So the big lesson from this is that views are really useful, but whether they are writable or not, or how much they're writable, depends on the individual view. Some you can write to completely, like sublist. Some you can't make structural modifications, which is what we were trying to say, where you try to structural modifications where you try to add an element to it or remove an element from it. You can set elements because you can change the values in an array, but you just can't change its length. So with each view, you have to think a little bit, unfortunately. When you're thinking of writing to it, you have to think a little bit about, well, what's exactly going on here? Right, so next one is
hash maps.
Hash map. Right, so what's happening here is we're making a new hash map. We're putting against the value 4, we're putting against the key 4, we're putting the value null. Then we're calling get or default, which will, if the thing is, if the key that it's looking for is already in the map, it will return the value corresponding to that key. If the key isn't in the map, then it will return the default that you've supplied, in this case, 4. And you're going to get the result of that will be printed. Then we're going to do put if absent. And put if absent, again, does what it says on the tin. If the key 4 isn't there, then it's going to write the string 4 into the map. And if the key 4 is there, then
it's going to return the existing value.
It will return the old value. It returns the old value in either case, I think, right? Okay, so we're going to get those.
So this one is quite obvious, huh?
So your choices are: maybe it'll print 4 and then it'll print null because it's the old value. Maybe it'll print null and then it'll print 4. Maybe it'll print null and it'll print null, and maybe it'll throw an unsupported operation exception. You never know.
None of the above. No, I mean it's quite obvious. It returns null. It returns null, right? It's null. I mean.
You think it's null and null?
What else could it be? I mean, put if absent, as you explained, looks for if the key is in the map, and it only put a value if the key is not in the map. So the key is in the map, obviously.
Okay,
so
right.
It's not going to alter the map. Therefore, it's going to be null, because the null is the citizen, right, of the world. It's democracy.
They're not quite as quick at answering this as they were 3B.
Yeah.
They were very quick. They were very quick at answering that one. I was very impressed. People were sharp about that.
Maybe it has to do that you didn't run 4A yet. I don't know. Let's see. But look, this time is very tight, the race.
Oh, yeah.
None of the above, and null.
It's a tight race.
And the 4 null is getting traction as well.
It's a tight race, yeah.
So how would 4 null work? 4 null would assume null is not.
I think we're about there.
Yeah, 115 people. Let's run it.
I'm so sweaty. I'm going to move this. There we go. Right.
4A.
4A. That's 4A. And it's 2. Okay, let's see what happens. Null and then 4. Okay, over to you, Dimitri.
All right. Null and 4.
You've got like 2 minutes.
Yeah.
Please, no longer.
So-
He could go on forever about this.
No, not really. But, I mean, quite obvious, get or default is doing what it's supposed to do. It finds a key in the map and returns a value. It doesn't check for the value. I mean, basically, it's like if contains key, then do get, basically. You can think of equivalent of it. So it finds a key and then gets a value of it. No questions there. But what happens with put if absent? And actually, put if absent, for reasons, decide to treat null as an absent value. So even though the key is in the map, it maps to a null, it treats null as if it didn't exist, and therefore overwrites it. And so what you see there later, when we do a get, we get actually a value that the put if absent put into it. This is surprising, and it's very inconsistent. Do we have a compute example as well?
No, we don't have a computing. Well, no, we do.
Okay.
We do later on, yeah.
Therefore, I'm not gonna. I'm gonna stop right here. So
I think if I've got this right, no, maybe you'll tell me I'm wrong about this, but quite a lot of these methods, these atomic methods on maps, like put if absent and the compute methods, compute if present, compute if absent, those originally came into concurrent map in Java 5, and they couldn't be on the map interface until default methods were introduced in Java 8, and then they were promoted into the map interface. And the result of that was that many of these interfaces, and it's even more the case now with sequenced collections, these interfaces contain methods that come from different places and have all been collected together in the one interface. And the result of that is they're often quite inconsistent in their naming and in the way they treat nulls. It can be a bit of a pain. But this is a result of having a 25-year-old framework that has evolved. If you wanted to get it right from the very start, you would just never have had it at all. Okay, let's have a look. What's next? 4b, what does it print? This
okay, so what do we have here? Obviously, this time we call things what they are. So it's numbers this time around. A list of -1, 0, 1. Nice, okay, 3 ints in list. And then we're creating a map. The story here is that Java doesn't have a native multi-map. So how would you go about multi-mapping? You usually use map of maps or map of lists and so on. So this here is one example of that. We create a map of integer to list of integer, and then we do an for each on the original collection, so it's 3 elements to go through the for loop. And then for every number, we do a put if absent with the number, given a default value of array list, and then add at the end of it to the list. So, and then we print the content of the map at the value 0, so the key 0. So I guess it's going to be a map with 3 elements, -1, 0, 1, each pointing to an array list of a single element.
Same number, yeah, that's right.
So when we call to 0, it would print.
It's a list
of 0.
A list containing 0.
Square bracket 0.
Are we good? Right.
Is that an option?
Let's see what happens. I hope so. Yeah, it is. It's the second option. So
okay, second
maybe
option.
it works. You know, sometimes, you know, like by the law of averages, some of these things are bound to work, aren't they?
Well, democracy thinks as well. And nobody assumes a null. It's interesting.
Oh, no, there you are. Somebody wanted to prove you wrong.
Yeah, but
what did you vote for?
Of course, for an empty thing, you know, with 0.
For the list containing 0.
Yeah, like a second option.
Quite right.
What else? We add into the map. Right, we saw in the previous slide that put if absent does put stuff into the map. So obviously,
absolutely. So
there must be stuff, and then we add to the list, right?
I think.
I think
they've been listening to me. Do you think they've been listening to me? No,
probably.
No, that couldn't have happened. Because I actually gave this one away on the last slide.
Yeah, people pay attention, I guess. That's good.
No, that never happens.
Well,
nobody ever pays attention to me.
Maybe not. Let's run the code. I mean, I'm pretty sure it's going to be like unsupported operation because we're using nested for each put if absent thing, right? Must be something there. Okay,
well, we're just about there, and it's very clear that you don't believe us. I think you've lost faith in us. I don't know. I can't imagine why. 4b. 4b. I wish there was some way of jumping to them easily. Right. So, 4b multi-maps.
Clever intelligence.
Okay. So you guys are right. And I did indeed give it away, but you probably knew it anyway. Put if absent returns the old value. So the problem is that it was null before, so it returns a value from before, and now what we're trying to do is we're trying to call add on a null value.
Can I check
What's
something?
What's the matter? What have I done wrong?
Yes, IntelliJ got it right.
IntelliJ is your friend. I should really, when I'm setting IntelliJ up for this demo, I should actually make sure it doesn't give any of those notifications. Very good. Okay, so let's try and fix this problem. So the next one fixes it. I believe the next one actually gets it right. What we have here now is compute if absent. Now, compute if absent is different, and compute if absent really does return the new value. So this should definitely work, I believe. So what we ought to get out, it's the same in every other respect. Also, we've replaced the new array list that we called in the last one with a method handle. So basically, we're going to make a new array list. When we get a number, we're going to make a new, when we compute if absent, we'll find that the number isn't there in the map, and then it will make a new array list, and then it will add that number to the array list. So -1 should map to a list containing -1, 0 should map to a list containing 0, and 1 should map to a list containing. Right. So we're going to get, so this time it's going to work, okay? Let's do it. You might get null, you might get a list containing 0, and I really think you will this time. For some reason, everybody's voting neither. Why?
Not a single time people believe us.
No, I really need to. We need to put some in here that really do return what we say.
No puzzler. But what's wrong with this pull request? You know, I try to help you open source project. I open pull request and you don't like it. I give up on open source. Let's see. I mean, people don't like it.
Yeah, people don't like it, but I think they've just got to the point where they don't like anything.
Because
you don't like anything, you people.
We mentioned compute if absent came from concurrent map. It has something to do with nulls, and we have empty map. It doesn't have nulls, but maybe some things will go around there. I don't know. People get confused. But we get
okay, so neither of the above definitely has it. Let's have a look and see what happens.
Okay, so it's 4C.
4C, right, 4C. Maybe I should let you do this, because I just get it wrong all the time. Here we are. Right, let's run this. And it fails again. What is the problem? What is
you have it on the screen.
Will array list tell us? I have it on the screen?
You have it on the screen. You have it unfolded. If you do it like this, you see what the problem is.
Right. It unfolded for us.
The problem is the compute if absent signature. It does not accept a value as a second parameter. It accepts a lambda, a factory function, if you will, that creates a value. And that factory function needs a key as a parameter. So what we have, we're iterating through the numbers, and obviously the first number is -1. We pass it to a lambda function, which calls array list constructor with new, and that constructor expects capacity, and capacity is -1, and array list blows up. So essentially, this example just blows up with invalid capacity.
So the lesson here is method handles are really nice. What we showed you was what's on the screen now. If you allow IntelliJ to unwrap the method handle and turn it into a lambda, then you see immediately what's going on. And the problem about this is when you choose a method handle, when you use a method handle, you don't get to choose which overload you're going to have. So it'll choose the one. It'll choose the one that fits the context.
Method reference, not method.
Sorry, method reference. Sorry, method reference. Thank you. When you use a method reference like this, you don't get to choose which overload. It will choose the one that fits the context, and in this case, that's what you got. But it may not be again exactly what you wanted. Okay.
Do we make more attempts to fix it?
No, we're done with that. We clearly don't know how to make a multi-map in Java, so I mean, we're just going to give up on that. Okay. This one, now this is quite a nice one. So what we've got here is we're creating a hash set, and we're putting A, B, and C in it, and then we're making a tree set, and the comparator for this tree set is case-insensitive order. So it's going to order all of the strings in the tree set. It's going to order them according to their alphabetic order, but it's not going to care about the case. So then we're going to add A, B, and C, capital A, B, and C to the tree set. And then we're going to look and see whether the tree set equals the hash set. And then obviously, the hash set's going to equal the tree set because equals is commutative. So the question is really, is it going to be true or isn't it going to be true? Now,
looking at that,
it looks
set equals set, true.
Yeah, set equals set.
So you flip the equals as commutative, right? As they say.
Yeah, I said
and
that.
Then
I said
true
that.
and true.
Yeah. Do you think true and true?
Is that an option?
Well, I'm pretty sure it is an option. It should be. Yeah, true and true is an option. True and false. False and false isn't an option for some reason. And none of these is an option. Okay.
Maybe that's false and false.
Okay, so we've got none of these is doing very well today. But true and false is coming in behind. We could do a racing commentary. You know what they're like at the races. So get really excited as it comes up to the finishing line. None of these is coming ahead, and it's none of these by a length.
None of these is leading away.
None of these is. I think none of these is breaking through. It's breaking free of the pack.
Team Red is doing quite good as well, but. Yeah, none of these. Seems to be a popular choice. Okay, none of these. So we wait for a couple more seconds and see.
A couple more seconds, yeah.
If that's none of these. I wonder if IntelliJ gonna show order again.
Let's see.
Next time we'll do it in Notepad.
Do it in Notepad, yeah.
No syntax highlight, no nothing.
So it doesn't give the answers away. Okay, well, it's looking like none of these followed by true, false. Okay, let's have a look.
Let's look. It's going to be 5, I believe.
It's going to be 5. I'm forgetting what.
Set equality, exactly.
5, set equality, right. Okay. Okay, let's have a look. And it's true, false. What is going on here? What is going on here?
They didn't get it right this time. First one.
So what is going on here is that you're asking what basically you're asking if you say hash set or tree set equals hash set is you're saying to the tree set, is every member of hash set a member of you? So it's doing a containment test, and the question is like. You explain this.
All right.
It's gone out my head.
So essentially, yeah, I mean, we talk about equals being commutative, so you can place them out. But we have essentially quite 2 distinct collections. So hash set is a unique set whose
it's containment, right?
Whose elements basically there is no unordered unique set. Tree set has a total order on it, and the total order is defined by external function. In this case, a comparator of string case insensitive order. What that means is that when you call equals on a set, what it actually does, it takes the incoming collection and checks for every method with contains on a collection. So contains in a tree set, of course, gonna answer true to each of the elements of a hash set because case insensitive order. But then when you flipped it around, and a hash set is doing the same, it's asking for every element of the incoming collection on a containment on itself, and it's false because capital A and lowercase a are not the same. So 2 different values.
Right. So equals in this case doesn't commute. I mean, that's the weird thing about this. How can 2 things be equal in one direction but not in the other direction? That's supposed to be a fundamental property of equals. And when I talked about this the last time, I was saying that this is a big problem, and it's like an inconsistency, and they are figuring out what possibly might be done about it, although there's already millions of lines of code that depend on this property of ordered sets. The cases that they use the comparator for testing equality. They don't use the equals method for testing equality of their members, and that's the problem here. But I've come to a different view in writing the book. Basically, the specification for sets is what's at fault here. The specification for sets says that the equivalence relation on sets, in other words, those things which are like a single member of a set, is always equals. So a set, according to the spec for sets, for the set interface, it's saying that you will never get 2 members of the same set that satisfy the equals relation, because they would be counted as duplicates. But actually, different set implementations in the collections framework have different equivalence relations. So it's certainly true that hash set has an equals, uses equals for the equivalence. Siri is going to answer this question first. It's certainly true that the hash set does use the equals for the equivalence relation, but
the AI is wanting something from
it says it didn't catch that. But identity hash set, for example, uses a different relation. It uses actually identity, and a tree set, an orders set uses the comparator that it's been given. So they actually have different relations, different equivalence relations.
So what can you do about it? So if you want to make sets comparable, you essentially have to find a common denominator. In this case, we have hash set and tree set. So what you can do, you can turn a tree set into a hash set and compare, and they will be equal. Well, they won't in this case because obviously values are different. But you can do the other way around. You can say, okay, if I take a hash set and supply a comparator, can I turn it into a tree set? And in this way, the tree sets will be equal. The only problem with this is, as Maurice pointed out, if you, let's say, you start with a hash set of 6 elements, ABC and ABC, lowercase and uppercase, you have 6 elements. By turning it into a tree set, you're going to discard elements, which is basically you are foregoing the underlying property of the set. So it's actually a bit messy of a problem to make it really compute both ways. But essentially, you have to turn it into a common collection and then compare on that.
I don't think I've seen this explained the way I understand it anywhere until now. So you have to get the new edition of Java Generics and Collections, where I make a real attempt to try to explain it properly.
Let's see what we have
properly.
next.
Okay, so we are on to, this is identity hash map, right? So here what we're doing is that we are, an identity hash map, as I just said, uses the identity relation. In other words, it doesn't matter how many, you have to put in, it doesn't matter if 2 objects are equal, they will be different in an identity hash map unless they are actually the same object. So we're putting the value 1 in as a key, and the string 1, and 10, and string 10, and so on. And then we're doing it again. So, like, the question is, are these values, are these the same value? Is the one that we put in the second time around, is it the same, or is it one that's just only equal to the first one? So your choices are, and this one, your choices are, when we want to print the size of the map that results from putting these 4 elements in twice over, you might get the answer 4, you might get the answer 5, you might get the answer 8, you might get unsupported operation exception. You never know. You never know with this talk.
Maybe it's 7. I just don't have it on the slide, therefore it's none of the above.
Sorry?
So it's 4, right? Well, people think it's 4.
No,
I mean, you have a hash map, you replace in the, so you put in the same keys once again, second time around, okay, size 4. Okay, sensible.
Yeah, okay. How did you vote?
I voted for 4.
Yeah, quite right too. Quite right too.
I mean, what else? I mean, I'm with the majority, right? This is obviously what's going to happen. Don't tell me it's going to be the yellow thing. Again.
It's always the yellow thing. Right, we're running short of time, so we'd better get on.
It's, I believe, 6.
What time am I?
6 identity hash map.
6 identity hash map. Okay, and we run it. And
it's all yellow in IntelliJ. IntelliJ.
Right.
IntelliJ.
And the answer is 5. 5? What? How is it 5?
How on earth it's 5? I mean, we give up. Like, Java is broken here, obviously. Well, the reason is the Java spec, and what they've done was caching. So when the boxing was introduced, boxing every primitive number to an object, to an integer, is quite expensive. Therefore, a spec added a little cache. So from, believe
minus 128 to 127. And those values, according to the spec, those values are cached.
So what happens here? We have 110 and 100 are cached. We add them to the map, so it's a map of 3. Then we add 1,000, which is not cached, so it's a map of 4. Then we're going to replace 3 existing ones with a cached value. Therefore, the integer boxed one going to be exactly the same. And then we come to 1,000 again. But this time, it's going to be a different 1,000. So if you would, probably in IntelliJ click, and it will unpack the boxing, if you replace it with value offs and stuff, you could kind of reason that if you put like on line 4 and line 8, if you put or like 11 and 15, whatever it is here, 16, a new integer, it will become quite obvious. The funny thing about it is that there is no way, the way the code is written, to actually get to any of the values of 1,000. You can still get 1, 10, and 100 out of the map because of the boxing rules, but there is no way to get those thousands out.
Because
They're in the map.
Because you can't ever get this, you can't create the same object again. Every time you put 1,000 into the map, it'll be boxed into a new integer.
Yeah. Well,
okay,
let's put it this way. There is no way to construct a key to ask the map. You can always get an iterator or something, key set, and then grab those values.
But you can't look it up. So an interesting thing, we'll have to press on after this, but an interesting thing about this is actually you don't know what the answer was going to be to this one, because the spec says that it's always minus 128 to 127 at least. But actually, a JVM can cache as many integer values as it wants.
There is a JVM
to start
switch,
off
and
with.
you can say cache for 1 million, and therefore this code will print 4.
Yeah.
That's why I said we run with default settings. So why not?
Okay, so we're at 7. And here we've got a linked hash map, and this is going to be a linked hash map on insertion order, because that's the default. And we're putting A in it, and we're putting B in it, we're putting C in it, and then we're putting B in it again. Right? Now because the order of the kind of linkage is that is the order in which things are inserted, that we should get what we should get here is A, B, C, but then B has come in a second time. So actually B should be at the head of the list.
Well, first of all, we're going to print 1, because that's the value. And then we're going to print
the map.
A, C, and B.
Yeah, A,
because
C,
there is last insertion of the B, right?
Because B's been put in.
Because it's link hash map in the insertion order.
Okay, let's see.
Is that the case?
So there you've got. It could actually say, I don't understand any of this. It could be C.
So
it
answer
could be
3,
C, B,
A, C, and B.
A, B, C, A, C, B, and none of these.
A, C.
All right. So, wow. These people are very skeptical, aren't they? None of these.
I think that's the first time when one of the answers is not voted at all. So C, B, and A is out of question.
All right.
But wait. But there was the get. This get might have messed things up. Was it? We added the B last, and then it called A.
It might have done, but I think it's a linked hash map is either done by insertion order or access order. And I think when you create it, you make a decision about which of those two it's going to be. By the way, linked hash map is much easier to deal with under the new regime of sequenced collections in Java 21. And now the sequence that forms the linked hash map can now be accessed in all kinds of different ways, basically like any other ordered, like a deck or a navigable set or something like that. It's properly ordered. You can get at the front elements, you can get the back elements, and so on and so on, in a way that you can't do before Java 21. Okay, so we've got none of these followed by A, B, C. Let's have a look. Okay, so what am I doing? Right, and it's which one is it? 7.
It has to be linked hash map. Yes.
Okay, right, we're nearly there. Okay, and we run this, and
IntelliJ.
Linked hash map. A, B, C. You guys got it right. So what's happened here, Dimitri? Why didn't that last one do anything?
Well, as we said, the order is defined by an insertion order, and we did insert B already. So when you update a key, it does not alter the insertion order. The order stays the same.
It's not modification order, it's insertion order.
It's insertion order. So update doesn't count. It's A, B, and C at the end.
Okay, right. So well done.
So kudos to you.
Everyone who got those.
37 people.
Yeah, that was kind of quite a strong contender there. Okay, last one with 2 minutes to go. What does it print? So we're making a list that contains 1, 2, and 3. Which we've, of course, called ints. And we are making an unmodifiable collection from it, and we're making an unmodifiable list from it. So we've got those 3 things: the original list, an unmodifiable collection wrapped around it, and an unmodifiable list wrapped around it. And now we're going to test each one of those 3 pairs for equality. Does the original list equal the unmodifiable one? Because it is an unmodifiable list. Does A equal L? Sorry, that's the second one. And the third one. And now does the unmodifiable collection equal the unmodifiable list? What do we think? So it's going to be true, true,
That's
true,
quite
true,
obvious.
false, true, false,
right?
true, false, false, or unsupported operation exception. You choose.
Null
they
pointer.
were completely equal for a moment there.
That was just a glimpse.
Unsupported operation exception is always going to be a strong contender from now on, isn't it?
Well, it's Java, right? People know.
Yeah.
There are null pointers, unsupported operations. Illegal argument exception might be another thing.
Yeah, we should have. Well, I think, did we have illegal argument exception for the method reference problem? I think we did.
Yes,
I think we did, because you can't supply -1 as the length of an array list. Okay, so.
So true, true, true is kind of leading, but false, true, false, true, false. That's an interesting one. So a list of 3 is not equal to a collection of 3.
Does the list
collection
equal
of
the
3
unmodifiable list? False, true, false is in the lead. Okay, well, we're out of time, so let's have a look. And it's
Collections. That's the number 8.
Number 8. Collections equality, and we run that, and we get...
And nothing yellow from IntelliJ.
No, IntelliJ...
No giveaway.
No,
IntelliJ doesn't help.
IntelliJ is not telling us. False, true, false. So this one's actually really quite simple. A list can only ever equal a list. So if you make it an unmodifiable collection, it's never going to be equal to a list. It's just as simple as that, I think. Okay, right.
And why collection is not equal list? Why the last line doesn't equal list?
Sorry, say again?
Why C doesn't equal L on the last line? Okay, I understand about list.
Because it's not a list anymore. It's just a collection.
No. Collection C.
Yes.
When you flip it around and you ask collection, do you equal list?
No,
you would expect the collection to be equal list, no? Anyways.
No.
It's not.
It's not. No, a list can only equal another list. Right, so we're finished. We're out of time, and we're finished, so thank you. Some lessons. I mean, there aren't really. Well, there are some lessons from this, I think. One of them is you've got to look out for nulls. Collections are losing their tolerance of null values, and the withdrawal symptoms are that you get inconsistencies in the APIs.
So collections are becoming null vegan.
Yeah, right. Absolutely, absolutely. Well, originally I had this as addiction to null values, but I kind of took that out. Views are really useful, but you've got to bear in mind that how writable they are depends on the view. Some of them are completely writable, not many. Some of them are partially writable. You've seen some today. Some of them are not writable at all. Double check the type of your method references, or you'll get caught with that. And have fun. And most important of all, buy this book. Thank you very much.
Thanks.
Yeah. Okay. Did we do all right?
I think we've done all right.
take your seats. Yes, I highly encourage you to be on time. So we are a few minutes late, so next time please be on time because we have so much awesome sessions today. And I'm really happy to welcome on stage Fawaz, who will tell us about high-performance streaming microservices. Well, that sounds so much awesome to me. Yes, please welcome Fawaz.
Thank you. Thanks. Thank you very much. Just make sure it's on screen here. Morning, everyone. I'm Fawaz Ghali. I'm the head of the developer relations at Hazelcast. For this session, what I wanted is kind of give you an overview how you can take your normal or standalone microservice application and scale it. Essentially, what we want to focus on today is deployment for high-performance real-time microservices. So have you seen it on the screen here? There are a couple of keywords on the screen. So there is a real-time, there is the high-performance, obviously, and the stream processing as well. So I came from Liverpool, from the UK, and every time I mention stream processing, some people assume that's basically we're talking about music streaming or TV streaming, which is fine. It's part of what stream processing is. But essentially, it's a wide area. You've seen it everywhere, basically, even if you don't use it in real time. So what we wanted is to see how you can take normal application and then maybe transform it into microservice application if it's not already in microservice architecture, and then how you can scale it. Obviously, so many solutions exist for this type of challenges. And essentially, what we wanted is to move from the situation or challenge that you're trying to solve and into results. So also, this road is kind of like a roller coaster. So there are so many elements exist into this straightforward task. So from packaging your application, so how do you package your application, and then how you can deploy it, and essentially also how you can scale it up and down, obviously with like average number of transactions you have in your application. So say, for example, you have 1,000 transactions per second, and you want to scale this process, essentially you will end up with like average transactions per time frame. And essentially all applications have some kind of spikes, right? So spikes can happen for various reasons. For example, Black Friday events or Christmas events, or if you have an online store and you want to, have some kind of offers or promotions. So you would expect to have maybe 10 times the average of your transaction data. And you need some kind of load balancing, because even the same microservice application that you use for your average transaction application, you want to actually take it and make sure you balance it as well. Obviously, you need to monitor this type of applications in real time. So whatever happens in, for example, if you're using Java, for example, and using Java virtual machine, do you know how to monitor your application in real time? And if the answer is yes, how do you make sense out of this monitoring? So for example, if you want to measure the heap size and you essentially want to scale your infrastructure, so how can you do it in real time? Obviously, redeployment is very critical because it might affect your end users. And what we're trying to do is kind of like redeploy the application, whether it's the same code or different code, in real time without stopping this microservice application. So we want to switch between microservices based on whatever factors you have. So for example, if you're using some kind of machine learning models, if you want to switch between models and you want to do it without taking this application down, you want to have some kind of redeployment in real time. So I mentioned real time, and real time means different things for different architecture, right? So for some architectures, it might affect like, I don't know, maybe yesterday's event or few hours. For some applications, maybe a few weeks or a few months. So you look at your database and you see what type of transactions exist in database, and then you do the analytics. For this talk, specifically what we mean by real time, we're talking about sub-milliseconds events. So for example, give you some ideas here. So for an eye to blink, it takes about 1/3 of a second. And if I ask you now to go after this talk and write an application, even to measure this eye of blink, and even if you have the hardware in place, you might be able to do it for small groups or maybe like a few hundred of people. But then if you want to scale it, if you want to take it to million transaction or million events or million blinks, it becomes really challenging to scale it, because the scaling means you want to see what is the application is doing in terms of performance, as well as how much data you use. Now, you might not need it for your work, obviously. It depends on type of use cases. So I always say, even if you don't use this type of application, you still use it as end user. So for example, on your mobile or on your laptop, 90% of all applications you see, they use some kind of real-time stream processing capabilities. And obviously, we see it in banks, for example, fraud detections or online payments. We see it with IoT devices, so smart devices, smart cars, they use some kind of real-time stream processing. Medical devices, hospitals, sports, for example, as well as machine learning. So for machine learning specifically, I will show you some examples today, but obviously if you're not machine learning or data scientist, you probably don't know how to figure out the model. So you need someone to build up this model for you. And this is where the job between data scientist and essentially your job is. So how you can take this model and deploy it in real time. So let's just take a simple example here, and let's just go through what we mean by this type of stream processing. So what you see on the screen here is simple transaction. Whether it's your credit card or debit card, and you try to withdraw some money out of your bank account, you take this card, you swipe it, and then essentially, if it has some kind of PIN code or whatever mechanism, it validates this and the bank will decide whether to accept this transaction or not. So it looks like a straightforward process, so there is nothing wrong or challenging in this process. So you see, you ingest the data, you do some kind of enrichment, so you add more data into the transaction, you do some kind of data transformation, and then you do some kind of prediction. So this is where machine learning comes into place if you're using microservice machine learning in real time, and then that's the final act, right? So this is where your bank accepts or rejects your transaction. Now I explained it. It took me, I don't know, maybe 1 minute to explain it. But if you look at this type of time window or time frame, what we're talking here is like under 1 second. So we're talking about sub-milliseconds. So it depends on the bank, obviously, and locations, and so many factors involved. Usually we look at SLA around 40 to 50 milliseconds. So that's pretty fast. And essentially, it depends how far your bank is from where you're trying to do this transaction. There are some elements which are kind of connected to the hardware. And it is hard to actually overcome these hardware challenges. So for example, network hoops, when you send this request, or input-output, as I will show you for the enrichment part. So what we're trying to do for the software architecture here is to minimize latency. Now, if we want to look at the data here, so for data ingestion, so this is exactly where you see it in JSON format, but it could be in any format, it's not important. So just to give you a rough idea what we are talking about, so some details related to your credit card, for example, you see it. So for example, credit card number, so it appears on this where you can read it. It depends also on which mechanism you use to read or ingest your data. But this data alone is not enough, right? it doesn't give you the full picture what we're trying to do for, detect if there is a fraud in this transaction or not. We want to enrich it. And the enrichment part is connected to the actual credit card, but in this case, we don't take these details from the card itself. So we take it from maybe database or a file system where we store some information about the account holder. And the idea is to figure out if this transaction is valid or not. Now, for the data transformation, so here what we're trying to do is to apply some kind of embeddings, for example, or we're trying to do some kind of feature engineering where we need to decide which feature from the real-time data as well as which feature from the batch data or historical data we want to combine in order to decide what we want to feed into the machine learning model. After we do the transformation, here the prediction comes into place. So we want not only to use the machine learning model, but also to be able to switch between models, because models change over time. And if we look at a microservice architectures and we assume each microservice is responsible about a single machine learning model, what we want is to be able to switch between models. Why do we need to do this in this specific critical area? Because data changes over time. So even trends in data change over time. And what could be valid machine learning model might not be valid after a few hours or few days and so on. So we want to be able to do the deployment for machine learning microservice, and we need to do it in real time. So once we figure out everything up to this stage, then the bank will decide, obviously, to accept your transaction or not. So keep in mind, this will take roughly around 50 milliseconds. Depends on the bank, obviously, and how far, and depends on the SLA bank implements. So the takeaway message from what you've seen on the screen is if you want to do it at scale, you need to combine two different types of data. I would assume in this hall here, probably around 80 to 90% they use historical data. So we use some database. We try to store data or transactions into database, and then we read it back again in the application. And once we read it, we do some kind of analytics. So the idea is to take it a step further in order to minimize the latency and also provide some kind of real-time analytics before we store the data into database. So let me repeat this again. Most of us here use batch data, where we ingest the data, we store it into database, then we load it back into the application, and we do some kind of analytics on top of it. What we're saying today is if you want to do real-time stream processing, you have to change this architecture. So you want to combine the real-time data, so this is as soon as you swipe your card, with the historical data in order to do the same stream processing application for real-time microservices. So the difference between these two different types is we process the data before we store it into database. So we want to be able to process the data as soon as we ingest it into our database. Obviously, now the question becomes why it is important and what you can get out of it. It depends how much data. And for this type of applications, we're talking about millions transactions per second or even billion transactions per second. Some applications you've seen it online, for example, they use even 10 times more. And the way to actually predict or find some kind of trends or alerts, we want to do it in real time. But in order to do it, we have to actually enrich this data. And because we're talking about two different types of data, so I will just mention that in order to provide this type of solution, you want to combine two platforms or two packages into your Java application. So on one side, you need stream processing engine. So For example, this could be Kafka, or could be KeySQL, or could be Kinesis or Redpanda. And on the other side, you want fast data storage. So the fast data storage allows you to load the data into memory. So similar to the previous talk, so caching, you want to actually ingest it and put it into memory grid, and then you want to combine between these two different platforms. And if you are a developer and your manager or your boss says, like, I want to create this type of application, and essentially you have to come up with the solution. Obviously, using multiple tools will affect development time, maintenance time, and also the cost time. So what we're saying here is we want to be able to do this type of process and minimize latency. So this brings us to the solution for this talk today. And essentially, this is the Hazelcast platform, which is built on the Java virtual machine. So it's built on JVM, and it's open source. So you should be able to try out this demo today after we finish this talk. So on the left side, what you see is your sources. And in most cases, you need to combine multiple sources at the same time. So this could be Kafka topic, for example. It could be Apache Pulsar, or it could be IoT device, or it could be enterprise application, or even a database. And once you ingest your data, you have two different components. So the first component is the JIT, or stream processing. So this is what we do in order to process the data in real time. And then we have the memory grid, which allows you also to do or load your data from database into cache in order to actually minimize latency. We want to combine between two different types of data, obviously, and at the same time, you want your Java code to access both data types at the same time and hopefully at the same speed. Remember, the real-time data is faster, obviously, so you want to make sure whatever configuration you use for this is to match the speed between the historical data or batch data with the real-time data. And obviously, once you do the stream processing and data enrichment, you can proceed to send it to some kind of thing. So, for example, you can send it back to some kind of Apache Kafka topic or Apache Pulsar, or even you send it to end user. So it's pretty straightforward when it comes to producing results. And the key is to simplify this architecture. Now, if I ask you, if you forget everything I talked about today, and if I ask you now to take your application and scale it, so it doesn't have to be even real time. So for some of you, scaling means you need to scale compute, so the process or your Java code, and for some might be related to scaling your data. And the right answer is basically a combination between the two. It's not the data or the compute. What you need is to do this at the same time, so the combination between data as well as compute. And this is very important to make sure that whatever microservice architecture you use to store the relevant microservice as close as possible to your data centers. So for example, today we're here in Sofia, for example, and we have data center for microservice 1. And then back in the UK, we have different data center for microservice 2. And we have two different Kafka topics or two Kafka servers. And then we have two instances or two nodes in your, or two clusters. What you want is to make sure to have the data as close as possible to your microservice. So data relevant to microservice 1 should be as close as possible to the location of this data center, and same thing for the data center 2 and microservice 2. The idea of having computation aware or partition aware for compute as well as data is to make sure to minimize latency. Now, once we move to the microservice architecture, obviously we need to understand how you can build this type of application. So if you use Kafka, for example, the idea here is to use multiple microservices for multiple topics in Kafka. And essentially, if you're using machine learning, it doesn't have to be machine learning architecture. You use multiple models at the same time. You need to access some kind of Python code because that's where most machine learning models are written with. And obviously, you need also to integrate Python process into your application. Now, this is very important because like now we're moving away from the Java virtual machine. We're trying to use the Python virtual machine, and we want to actually run it inside the container. Now, why we need a microservice architecture for this type of application? These are like, some, introduction why you need to use microservice, obviously. So you need basically, it's easier to build microservice. So if you have multiple teams and then you have multiple different services or tasks, you can split it into smaller parts. It becomes easier to deploy, as I mentioned. So if you have multiple microservices, you can store the relevant microservice as close as possible to your data center. And then also easier to maintain, obviously, when it comes to redeployment. And of course, if you want to do some kind of scaling, as I will show you. The key, again, not only to minimize latency, but also to focus on how you can do it in very simple way. So these are two different types of architecture. You see it here. So one way is just like normal standalone monolithic application where you go task by task. So if it is Java code, for example, you have, 10 tasks and you go, task by task. So this is good, but if you want to be able to do it in distributed fashion at scale, probably it's not a good idea to use the monolithic approach. You want to use the microservice where you connect different types or different microservices to different microservices, depends on the use case. So we move to something called DAG format. And essentially, the DAG format will allow you to reuse this data or you reuse this compute. And this is very important to do it in real time. If you remember from ingesting your data, so for example, when you swipe your card, the application should read this data only once. So for example, I've never seen that, like for example, when you swipe your card and you are asked to do it multiple times, obviously, because this will add latency. So ingesting the data, for example, is once. Now, if you want to use it in different parts of your application, obviously, you can send this microservice or you connect it to relevant microservices. Same thing for analytics or processing, as well as output or visualization. Now, how it works, it allows you to connect a microservice one to topic one, for example. So if I have transactions history coming in topic 0 or topic 1, I can send it to microservice 1. If I have weather forecast in topic 2, I can send it to microservice 2. If I have GPS coordinates, so for example, if I'm swiping my card here in Sofia, I want to make sure my bank knows exactly where I'm going to say, just in case if someone is scanning this card back in the UK, they should decline this process. So GPS coordinates, for example, can be stored in different topic. And all these are working simultaneously, so they're working in parallel. On top of this, what is important is not the real-time data, but also the data objects. So, for example, some data relevant to my transactions history. So, what type of transaction I did last week or last month. And at the same time, how you combine between these different types of topics, for example, microservices and data objects. Now, the Python part is very important. So, is on the bottom left side is where you store your process. So, I just mentioned Python here, but it could be Java as well. So, the idea is to ingest once and do the processing at multiple times. This will allow you to actually not only save time and minimize latency, but also to become more efficient when it comes to deployment. Before I proceed demo, I just want to highlight why this is important. So most applications that you have written up to this point, they use one input or multiple inputs, and then you provide process one, and then you get outcome. What we're saying is you need to combine multiple processes at the same time in order to provide some kind of composite output, and this will allow you to have multiple microservices having multiple outputs, and then you do the combination. Now, if you want to scale, which is what we're talking about today, so this is kind of like architecture that you need to use. So imagine this is your cluster, and in your cluster you have your Kafka topic or your inputs. Then you have the platform, which is connected to real-time data, as well as your database. And then you load it into memory grid. So you load it. I will show you how you can do it. And then you connect the microservice or more, which is very important. So most applications you use on your mobile, they use multiple microservices. And when it comes to scale, you need just to determine how much data, obviously, in order to scale up or scale down. Now, when it comes to deployment, we have different ways. So for today's demo, I will deploy it on my machine. So you will see the code. You see how it runs on here on this machine. But obviously, it depends on how big your cluster is. So in this type of host, the demo is host, but you can use something called edge or sidecar, where you store your microservices application as close as possible to your node. Or most like online application, you see they use something called farm, which is like, hey, I have a data center dedicated for compute and multiple microservices, and then I can use different architecture to scale. Now, in order to understand, I mentioned one credit card, right? So if I scan my card here, and I scan it in Germany after 2 hours, it should be accepted. If I do it again, but next time I do it in New York, there is no 2-hour time frame, so obviously it should be rejected. And we need to multiply it. So now we are talking about the scaling part. So if you take the average, how many flights per week, so we're talking about 250K flights, and then you need to multiply it by number of passengers, and then on top of it, of course, you need to know exactly how many credit cards and so on. So in order to do this, I will show you the code. So we're using Kubernetes to do the scaling. And this type of applications, we managed to run like 1 billion transactions per second. And this is just around 25 millisecond latency on just 45 nodes. So the application you will see today, what you need, obviously, you need the infrastructure or the hardware. You can use AWS or Google Cloud, or whatever cloud platform you want to use. But very important to focus on linear scaling when it comes to scale, so which means you just need to add more nodes as much as you need for your data. Now, for this type of latency, obviously, we need to figure out how you can do it. So another example is if you're running an online auction and you want to know basically most bids for X and how you can do it in Java. I will show you the code before we proceed the demo. So this is the code split into 2 parts. So the first part, essentially, the benchmark, if you want to do benchmark. And then, obviously, because you're using Java, so we use a Java Lambda for this type of application where we split the code. We write the stream processing pipeline or JET pipeline, and then we need to define window. And this is very important. This is the difference between batch data and real-time data. Batch data, you know exactly how many transactions exist in your database, right? So you can do SQL query, and then you get the results. For real-time data, you don't know how much data, right? Because you know the start, for example, and most cases you don't even. And you don't know the end. So what you can do is to apply window on your data. So the window, essentially, exactly, I want a slice of my data. So I take the stream, I take slice of it, and then I move this slice based on whatever mechanism you want. So you can do it based on time, you can do it based on how many events, and so on. and then you can actually do the aggregation for your microservice. Now, I know that the question is, how can you set it up? So, because that's what we're here for, right? So the setup is straightforward. So what we're trying to do is run the Hazelcast instance on locally. So I'm running it on my machine. Obviously, I'm using one cluster, but it depends. That I showed you how you can use Kubernetes to scale it. For example, 45 nodes in order to do 1 billion transactions. So you can roughly estimate how much you need. So for example, if I want to run, I don't know, 4 billion transactions per second, you use exactly the same setup on maybe 45 times 4 is around 180. So that's how you do it. I need to ingest the data, so I'm using Kafka. And in Kafka, it's just to send these data. So I'm not going to talk about Kafka here. It's essentially just how you can read the data in real time into your application. So let's just move quickly to the actual code. So because it's Java application, so what you see here is the POM file. So what I'm saying is I just need to import this library or the jar file into my application. So this is exactly what you need to do. Essentially how much processing you need. Obviously, this is where the configuration comes into place. But I'm just specifying the library. I have two classes here. So one class is to publish the data, send it to the application. So I'm using Kafka producer. Obviously, I'm just creating events. And from here, I need to specify the server, so the IP address and port. As soon as I specify, I can proceed to the actual code. So in order to create the pipeline. So the pipeline will read from Kafka. So this is where you read your events. Obviously, as I mentioned, it's Java Lambda architecture. So hopefully, you know how it works. So in one part, I'm specifying the window. And then on the other part, I'm specifying the sliding pie. So how much I want to include in each window. I'm doing aggregation. So I want to know how many events I'm receiving per second. And simply how you want to output or produce the results. So let's run this application. So from here, I just need, obviously, I have Kafka running. So this part here is the zookeeper as well as the server. And from here, if I start publishing the data, you can see now this application starts to generate the data, right? So these events, you see it. Obviously, in order to see what's going on, I want to make sure that my main application, my publisher application has some kind of latency. Latency, I'm adding 20 milliseconds here just to reflect the real-life scenarios. So where you swipe your card, for example, exactly there is some kind of hardware delay. And if I run now the main class, what you see is the number of transactions. So if I just increase this size here, so these events, you see it here. So I'm receiving 4, 3, 10, and so on. So this is where you see the changes. So for every second, the application is calculating how many events I'm receiving. Obviously, this is the counting part. Now, the question is, what does it mean, right? Because you're actually processing the data, and then basically you just know how many transactions you're receiving per second. This is just half of the picture, right? What we wanted is to take this into advanced steps. So we want to be able to enrich these events. Now, in order to enrich these events, we need to change the architecture. So in order to do this, I'll keep it running, and then I move back to the actual code. So what we saw up to this point is we actually have some data coming in real time in Kafka. we ingest it to the application, and the Java virtual machine, of course, the Java application process these events, but I want to do it in real time to provide context. So I want to enrich the data here. So data enrichment should be coming from different source. So this is not the real-time data, it's basically the batch data. Once I have it into the actual application, I store it in map or IMAP structure. So it's basically a map structure, so key value pair. And once I have this data stored, I end up with having two different structures in my application. So I have the real-time data stored in one map, and then I have different map to store the batch data. And I want to do the enrichment. I want to do this combination in order to understand what's going on. So these events you've seen coming in real time, what we wanted is to say, I want to know, for example, when an activity or if event is a fraud or not. And I'm using a different coloring scheme. So for example, red, green, blue. And this is where the enrichment comes into place. So if I have red, I want to flag it. And then you can proceed to do the alerts. Obviously, if you want to actually do the enrichment, what you also want is to make sure to, when you do the combination between the batch data as well as the real-time data, is to figure out which is belong to which. And in here, you end up with a third map or third IMAP. So this is where you store not only the real-time data, but also the context. So if I move back again, here I have Hazelcast instance running. So let's just go. Obviously, it depends on how many clusters you want to define and how many nodes. And obviously, in my case, I'm using the local host, so I'm deploying it locally. And you see here from this screen, I have one cluster, and this one cluster has one node. As I mentioned, if you want to scale, what you just need is, for example, if you're using Kubernetes to do the scaling, is just to define how many nodes, and then you define hosts on top of it. So I will leave this running here, and now let's just do the enrichment. So the enrichment part, now we need just to move slightly to machine learning side, just to show how you can do it in real time. Because what I'm about to do is not the actual Java code. So in order, obviously, to run the Java code, you have to compile. You can do so. So everything I mentioned from this point, you can do it in Java. But if you're doing some kind of real-time stream processing microservice application, you probably want to run it in real time, which means you need to use some kind of SQL. So let's just do it in SQL. But as I mentioned, you can do it in Java, and then you have to switch between different cluster nodes. So here, I just need to create this map. So this SQL code, you see it on screen, will generate exactly the data, or first part of the data. So now I'm running the SQL as you see it here. So this is the SQL command or SQL screen, and this runs on top of your Java application. So let's just see what happens when we post this data here. So this should be a command to create this streaming or order to create this map and store it into memory. Now, if I want to select from orders, for example, I just want to specify one specific user, now suddenly you start to see events or orders coming in real time here. So it's very important to understand what you see on the screen is not coming from a database. So it's coming exactly from the real-time or streaming engine you're using. Now, this is obviously running into memory. Now, obviously, it's just half of the story, right? So what does it mean if it is just one single user with a specific amount doing this transaction with a specific number of orders based on how many items? So I'm just going to stop this. Now it's still running, by the way. So if I run it again, just show you again here. So this process is still running, but instead of using different screen to do different command, which I want to do, I'm just going to stop it here just to simplify my screen. Now I want to do this enrichment. Now, in order to do this enrichment, I want to create a different map. So the different map will have contextual data or batch data, and it's essentially key value pair. So from here, again, I'm just doing it in SQL because that's how it's supposed to be if you want to run it in real time. Again, you can write it in Java, exact same SQL command. And if I run it now I have two maps in memory. One map has the streaming data, and the second map up to this point is empty, which I wanted to use for the data enrichment. Let's just put some data into it. If you've seen this today or yesterday, you probably you probably saw the application running in IntelliJ and then the presenter or speaker running the application in order to actually have some data in the application. Now, what you currently see different is the application is already running. So I'm creating a new map structure. I'm adding data into it. So this data now is stored in the second map. Now, the red, blue, green, let me increase the font size a little bit. So the red, blue, green is just a mechanism to label my data. It could be anything, to be honest. It could be, for example, your credit score or GPS coordinates or weather data. The idea or the goal here is to provide some context to your application in order to decide why this is a fraud, why it is not. And not only it is important to decide which activity is not a fraud, so it should be valid, but also to avoid false positives. So those who from data science background or doing some machine learning, false positive is pretty straightforward in terms of you're trying to use your card, but your bank declines it. So essentially, it's a valid transaction, but for whatever reason, your bank decided to decline. So again, we're not only trying to detect a fraud, but also minimize false positives. So that's the goal here. So I'm using a coloring scheme, so I want to know if I have alerts, and in second extra, so second step is exactly the red, I want to do the alert. So the code here is to define extra 1, extra 2, extra 3 as contextual data. And from here, I just specify I want to check when there is a red in second place. Now, if I put it, now let's just recap. I have streaming data stored in map. So every time you generate the data, obviously you store it in the map and then you add context to it. So from this context, we're trying now to see what happens. So between the previous screen, maybe it's better just to go back again. So I just wanted to do this comment again just to tell you why context in real-time applications is important. So let's just quickly clear this here. So I'm going to run this first command, so which has only users and some amount. Okay, so let's just go back here. So this is just one user. So for example, it could be anything from the streaming data. And from here, you see the stream. So again, it's not enough. It's not only possible to do the fraud detection if I want to on this data. Now, after I created the second map and I inserted some data, now let's just run this command to see the difference. And suddenly, you start to see two different types at the same time in real time. And remember, these two data types are stored into memory, and even before you store it into database. So you have, for example, users, you have data coming into amounts, you have some kind of parameters you want to do or use for data enrichment. Obviously, in my case, I'm saying when it is only read in the second parameter, flag it, and from there, basically do the alerts. So with that being said, let's just go back quickly. Just to summarize the takeaway messages here. So if you want to create a real-time application, if you want to move from 4 nines to 5 nines, so from 99.9 to 5 nines to 99.999, you need to combine multiple data sources. Some data types come in real time. Other data types come from batch data or data stored into your database. And based on these two different types, you want to ingest it into one platform. Obviously, the solution would require to use one or more tools. In most cases, you require 2 or more. And if that's the case, you will end up with 2 times more development time as well as maintenance time. The simplified way to do it is to use one platform in order to have data ingestion from real-time data as well as batch data stored into memory grid. Once you have all the pieces in one place, you should be able to do this data enrichment, even be actually storing it into database with like sub-milliseconds latency. In order to scale it, in order to run it on, I don't know, 1 billion transaction with like maybe 20 milliseconds latency, you want to be able to scale it without changing the application, and the microservice should be stored as close as possible to your data centers where your data is. And then from there, once you have figured out all the pieces, you can proceed to have multiple microservices as output. So you can simply combine in order to get the composite output. If you find this content is useful and you want to try it out, there is a Slack community for this type of work. So feel free to scan this QR code, and from there you should be able to use cases. So I will stay around outside. If you have a dedicated use case for real-time stream processing or microservice, you want to have some discussion about it. And with that being said, thanks very much for attending this call. Thank you.
Okay, 2 more minutes for the people to come. Jonathan, we're also southern country. We're not on time.
Good afternoon in Bulgarian.
Dobar den. Dobar den.
Dobar den. Yes, dobar den.
We are also southern country. Don't get too much. Okay, 2 more minutes. Nice.
Wojtek.
Okay. Oh, they will keep on coming, so that's okay. Okay. So have you had your lunch? Was it bad enough? Yes, we have our famous lunch too. Although it's not that bad as Devok's famous sandwiches, which get worse every year. Okay, so before actually we start, there is a small change in the program. So if you take a look at your badge, the next session is going to be cracking the cold start. Unfortunately, Wojtek could not make it to this conference, so we are sorry for that. He's also very much sorry. So they're going to be, he will be replaced by Alvaro Sanchez. How do you say it?
Álvaro Sánchez.
Alvaro Sanchez. Sanchez. Yes.
Sánchez.
Yes, Sanchez. Yes, he will be replaced, and he's going to talk about Micronaut and GraalVM. Yes, it's also very nice, a little bit in competition with you. Yes, so we're sorry, there will be no cracking today, but there will be a lot of Micronaut. Yes, and now I'm really, really happy that today our guest is coming from Barcelona. His name is Jonathan, and I'm really blessed to call him my good friend. Yes, and he is the leader of actually Barcelona Juke, and his conference is amazing. So JBCN, or now DevBCN, you don't have to be a Java speaker actually to go there anymore. So if you speak JavaScript, you can also go there. Yes, so it's an amazing place. Barcelona is beautiful, and they're making beautiful conference. So I'm really, really happy that Jonathan is today with us, and please welcome him.
Dobar den, JPrime. Okay. So before starting my presentation, I will ask for your help. So when I make questions, I don't see your hands, so I will ask you to make noise. So if you want to raise your hand because your answer is a Boolean true, then please do some noise. Fine? Okay. Okay, let's start. So Java in 160 milliseconds looks like impressive. Is it looking impressive for someone? Okay. Okay, so now that we have this number on our brain, this presentation is going to be about migrating Spring Boot into Quarkus. Is there anybody here that doesn't know anything about Quarkus? Let's try again. Is there anybody here that doesn't know anything about Quarkus? Fine. Let's get the challenge. So, well, Who am I? This is the agenda. Now I will show you. And what can you expect from this presentation? So if it does not fill your expectations, rooms are on the back. Then I will explain why I decided to migrate. So I had several other things to do at home, so I decided to migrate one application. Seems weird. Then I will show you which are the different steps to migrate a Spring Boot application. Finally, that's the highlight of the presentation, is the performance comparative. Let's see which are the numbers. And in the end, I will give you some references if you want to just explore more this topic. So that's me. And you can get my contact if you scan that QR. So I'm Java champion because I've been involved in the Java community since 2012. I'm also community-driven because I'm one of the leaders of the Barcelona Java user group since 2012. And I'm also co-founder of JBCN Conf, last year with more than 1,000 attendees, and now it's rebranded to DevBCN. I've been speaking in several conferences, and now, hopefully for me, at JPrime. I've been developing more than 30 years with lots of different languages. Some I liked, some I dislike. And as a professional, I've been working for Red Hat, Tetrate, Okada Technology, NetCentric, and now I'm developer advocate at Sonar. Does anybody know Sonar Cube, SonarLint? Perfect. So for those of you that don't know anything about Sonar, Sonar is a company that provides static analysis tools, free. You can use them on your IDE, SonarLint. There are several IDEs that you can use. It will analyze different languages, not only Java. Sonar Cube is a tool, free also. You can download it, the community edition. And it will analyze your code, and it will show you which are the issues and the problems. And Sonar Cloud, that it is free for public repositories. So everything is SaaS, let's say. So what can you expect from this presentation? Well, basically, my experience, it's my migration. It's redundant, opinionated opinion, obviously. This is not a magistral lecture. I'm not here to teach you anything. I'm just showing my experience. Take what you want from my experience. Something that works, something that works, I tested it, ran it, fine. Some of you are following The Mandalorian. 1, 2, OK. The rest, you should follow it. This is not the way. So this is only one way of doing things. In my presentation, you will find screenshots from arcade games when I was a kid, time ago. If you want, you can just try to be the first one to tweet after the presentation with all the names of the games that you find here. So first, a brief introduction to Quarkus. It's a Kubernetes native Java, but also Scala and Kotlin framework that will allow you to compile your application for hotspot, so OpenJDK, or for native with GraalVM. We will see what it is, a native thing, afterwards. And also that uses tons of open source libraries. So it's not reinventing the wheel, just simply using Kafka, Hibernate, REST-easy, Vertex, but tons of them. So you don't need to think about any other special thing. And the point of Quarkus, so why they decided to create Quarkus? Because they want to have a framework that makes applications to go way faster, to be way smaller. Also, that they are not going to force you to learn new tricks. And it's open source, obviously. They also have fast-paced releases, so you will find versions of Quarkus every 2 weeks, lots of them. And again, there are tons of extensions. Regarding extensions, more than 600 extensions. I mean, you can use, I don't know, lots of libraries that you can use or that you were not using, but they are open to use, and you can select them from their extensions website: Kafka, Camel, Keycloak, Jagger, and even Spring. About the Quarkus evolution, well, they started late 2018, but they have released lots and lots and lots of releases. Now, there's the 304 released this month, but you have lots of them fixing bugs and introducing new features. And this is an image that you will find in a lot of places when you search for Quarkus, where you can see an application that is taking 136 megabytes in memory with a regular framework, green one. I'm not going to say which one. And then if you use Quarkus on the JVM, because I said before that you can use JVM and also native. If you use JVM, you are going to reduce it by half. But if you go to native, and let's see afterwards what does it involve to go to native, it will take only 12 megabytes. Regarding a startup, OK, doing the same 3 steps, we go from 9 seconds to less, so 42 milliseconds. So those are impressive numbers. So let's see if this really is what I found. Quarkus status, more than 800 contributors. As I said, tons of extensions. Even there is an open repo that you can provide your own repository, your own extension. And they solve and introduce new bugs constantly. So it's a very live, mature project. Oops. Oh, OK. So let's see the migration. I hope that some of you know which is this game. I hope. I invested a lot of money there. So Spring Boot, why I decided to migrate from Spring Boot? Because for me, Spring Boot was always, although it was super easy to develop things, it had super long startup times and eternal tests. So when you want to run all the tests, it takes ages. It's heavyweight because you create your application and it will consume a lot of memory. And this is also another thing that I didn't like. It's that there are too many things under the hood that you don't know that they are happening. But when you see the log, you will see several services that you don't know why they are running. Is it someone here, is it aligned with my feeling? Or nobody is aligned with this feeling? OK, perfect. OK, I'm not alone. So I read that Quarkus is easy to develop applications. It's fast, lightweight because it produces applications that do not consume a lot of memory. And also, it is GraalVM compatible. That's awesome. Why? Because then I can produce native artifacts that I will deploy into a serverless system. Then I can go to FAS, or function as a service, serverless, or even increase the cluster density, putting more applications in the same resources. Sounds amazing. So I decided to take one application from Spring Pet Clinic REST, and migrate it. And in the Spring Boot, we have several libraries that the project is using. So I needed to move to other libraries that are not from Spring. So which are the steps that I did in order to migrate? Very easy. I will tell you some of them. Regarding CDI, just only replacing auto-wired by inject. That's it. And everything was working. Also changing the bin and adding application scope instead of the component or bin or. So it was easy, just string replace, and no problems on it. It worked. Only that with Quarkus, we cannot have private members on the injection. But for the rest, it's easy. With JPA repositories, well, it was a matter of changing which is the class, in this case, Panache repository. I went to Panache repository base just because the default identity object is long and Spring was using integer. But it was very easy, just changing the class that repositories were implementing. So nothing complicated here. Then I needed to migrate from Spring REST to JAX-RS. That is a standard library. Well, we need to change several annotations, especially if you are using the request mapping, that in one annotation you have the 3 elements, but it's a matter of just replacing, string replacing. So at the moment, I've been only doing string replacing. With the Spring REST security, well, there was only one problem that for Quarkus, I was not allowed, well, I didn't know how to constrain the roles allowed. As you can see here, in the pre-authorized in Spring, you can have expressions. With Quarkus, you have to define a list of roles that are allowed. At that moment, at least, you couldn't have expressions in the roles. Also, the security, in this case, was persisted in a database, so the users, passwords. It was easy, just using Elytron, and it's a matter of adding a dependency, and in the properties file, just configuring which is the query to get the user and the password. The cross origin, it's a matter of simply adding a property in the properties file, and that's it. Oops. OK, nice. With metrics, well, in this case, the Spring project was using AOP. Anybody is using AOP here? OK. OK, it's very powerful, but also a bit complicated. But with AOP, you can have annotations that are covering several methods. And every time that one method is called, then your logic will be called also, before or after. Spring was using that in order to get metrics. So every time that you call a repository method, just simply, I will take the time, and then when you leave, I will do a subtract, and then that's the time that it took to do the query. We don't have that with Quarkus. There's no AOP in Quarkus. So we can just simply use small write metrics and then annotate the methods that are going to be measured. This is tough. There are lots of them. But we will see another way of doing this. Even you can use the micromethod annotation, and then it's transparent too. For validation, we need to move from controller advice to JAX-RS exception mapper. You can see the difference in the code here, that both methods are quite similar, but a bit different. So you need to code this part. Regarding Swagger, so you want to have your API documentation. In the case of Quarkus, you just simply add some properties to the properties file, or create a class that contains the information for your API. And then it will scan all the endpoints in your application and will create the documentation for the API. As I said before, there is no AOP for Quarkus. Therefore, we need to annotate all the methods just to get the metrics from them. That's tough. But what we can use is a property for Hibernate that will then put all the metrics of the access to the database into the log file. So you will get all the metrics, but with just only adding one line in the properties file. With local caching is exactly, well, it's too similar. So it's only just replacing one class for another. And it's the same way that the Spring does. So you will have a method with the annotation to be catched. And then in this case, you put a name to the catch. And you can configure even the properties for the catch in the properties file. With tests, that's a bad thing. We need to recreate the whole code. So with Spring, there's mock MVC, but with Quarkus, you need to go to rest assured. For me, it's more clear to use rest assured, but well, it's a matter of taste. With test resources, in this case, this application, when you test it, it is starting an H2 database. And with Quarkus, it's very easy. Just simply annotate the test with this Quarkus test resource, and then it will start an H2 database for you, and your tests will connect to that. And for testing with Mockito, it's a matter of adding the inject mock, that it is different from the Spring one. Is anybody sleepy already? OK. Nice. So forget everything that I said. It's not worth it. That's the point. So if you want to migrate your application from Spring Boot to Quarkus, just simply use the Spring extension. So with the Spring extension, you don't need to touch anything in your code. You just simply use the Spring extension for the Spring DI, for the web API, for data JPA, for security, for cloud, everything. It's a matter of just simply changing the dependency. And the interfaces are the same, but the implementations are from Quarkus. Then you don't have to touch your Spring Web application, because it's supported by Quarkus. You think you are using Spring, but you are not using Spring. This happens with several extensions, that you don't have to touch your Spring application, just simply change the dependency in the POM, and then you will have your code. Well, you need to check, because some of the extensions are not covering 100%. So you need to check if there are corner cases that the extension is not covering. We have also for the Spring data, and in this case, even we can use these methods that will be translated into a query. I don't like them because it can be super, super tricky when you start doing exists book by year of birth between and join with. That's complicated. I prefer to have real queries. But if you have them with this extension, you can even don't have to touch it. Security, the same. And in this case, even it is considering the roles on the security on the methods. So what I did was to take that project, migrate the project to Quarkus, and check. The thing is that building the project, well, I'm not concerned about building the project. It's something that will do CI, not me. So I'm not concerned. But yeah, there's a difference in time, especially if you go to Quarkus native using GraalVM. It will take a lot of time, and also it will consume a lot of memory during the process. But the thing is that when we have the different artifacts, so the Spring Boot one used with the Java virtual machine, and then we have the Quarkus one using the Java virtual machine, and finally, the Quarkus native. So just only for using Quarkus, we see that the time is half of it, and that the memory is also half of it. So just only moving to Quarkus without doing anything special and running on JVM, we are going to reduce. What does it mean? That we can increase the density of our cluster. So we can now have 100% more applications with the same resources. But if I create a native application that it only takes me adding -p native in the command line, I will go from 3 seconds to 160 milliseconds. And I will go from 242 megabytes to 80 megabytes. The only difference is using GraalVM to produce the native artifact. And it only involves adding -p native in the Maven command line. But recently, Spring Native has released Spring Boot 3, and they also have support for creating a Spring, so native artifacts from Spring. I've tried, and I didn't succeed. Probably I haven't tried enough. So I will try more and see if I can create a native artifact from the Spring Boot Pet Clinic REST. Just simply go and try it, and you can share your experience. So some of the references that can help you if you want to see more about Quarkus. Obviously, the GitHub repository for my migration, you can find it here, and the original one. And also, the Quarkus main page, where you can see, well, lots of documentation, references. And even, you can go to the Quarkus website, and you will find interactive tutorials. So you are using a platform called Katacoda, and you don't have to install anything. It's going to run all on cloud, free. And you can do some tests or tutorials with Quarkus in different topics. Also, there's a cheat sheet, a document that it is updated with every release of Quarkus, and then you will see different changes and the new features that are being added to Quarkus. And finally, if you want to start coding, the same as with Spring, you go to code.quarkus.io, you select which are the dependencies that you are going to use, and it will create a zip that can be just downloaded, and you can start coding from that. Good question. Don't know. Don't know. You can check also these real use cases. So different companies that migrated from Spring Boot to Quarkus in order to improve the productivity or reduce the money invested on their platforms. It's nice to check because they tell what they do and why. So this is it. As Michael Jackson said, if there are any questions, if not, thank you very much for being here.
There is a question. Yeah. For a microphone, should I just shout?
Tell me and I'll repeat.
So I have two questions actually. Have you tried Micronaut? Have you compared it to Quarkus? What do you think about that? And the second one, is there a... Sorry. So the second question is about Micronaut. Have you compared it to Quarkus, and what do you think about that? And the second one, is there an approach to migrate Spring Boot app to Quarkus continuously, not discrete? So I mean, I want to change it step by step, and once I just switch it, and that's it.
First question about if I've tried Micronaut and how it compares to Quarkus. No, I haven't used Micronaut. I have read about it. They had a different approach. They had their own libraries plus open source. I think there's a difference in the approach, but it's also an amazing framework if you pretend to go to native. So let's try it and see if their approach fits you. That's that thing. And the second one was about an incremental migration and not 100% migration, right?
So yeah, but I think that the extensions that you've shown actually does this approach. So I just replace the dependencies, and theoretically, my whole app is now a Quarkus app, not Spring Boot app.
But the thing is that for Quarkus to be so fast on, let's say, production or running, it's because a lot of time is consumed on the build process, ahead of time compilation. So what it does is it will analyze your code, it will check, and it will flatten several things. Therefore, either you have Spring or Quarkus, because only one can be in the build time.
About tests, do Quarkus provide similar extensions for tests? So you've shown an example with mock MVC, and you have to replace it with rest assured. Can I just add some dependencies so I make mock MVC work with my Quarkus app without rewriting it all from scratch?
Well, the thing is that when I showed the extensions for Quarkus, those are not exactly the regular extensions. Those are extensions optimized to work for Quarkus. So they reduce reflection and other things. So in this case, as far as I know, they haven't done anything on the mock-MVC library. So if the library is not prepared to work with Quarkus, you cannot use it.
OK, thank you.
Welcome.
Yeah, just a super fast question. If you are migrating, like what is missing? Like all the runtime checks, reflection stuff, AOP is missing, Spring expression language is missing. What else, like in general, like condition on missing beans and stuff like that are not working as well, right? Because they are runtime. What else is like missing that usually you have in a Spring Boot project? So basically, yeah.
Yeah. Well, they are constant.
Is there like a list somewhere, or do you have in your mind like the top 5 things that are missing that you struggled with?
Apart from testing?
Yeah, apart from testing. The testing is you can rewrite them.
Okay.
It's not a big deal.
Well,
it's more or less reading one, and you can hire a junior. You read the mock MVC. This is how it's done in rest assured. Just do it.
Yeah.
So
you need to check because, well, in your website there are several extensions covering Spring. So that's not the full list of extensions from Spring. I can't remember which are not there.
Yeah, but which of the features more of Spring are missing? Like you don't know. Okay,
I'm not aware, but it could be that there are corner cases. Yes, but it all depends. The regular ones, I didn't find anything missing.
And the BOM, so the Quarkus has a BOM similar to Spring Boot BOM, basically, which is, I saw it's 2,000 dependencies. Is this updated every 2 weeks? Like, is there a new BOM every 2 weeks?
For every release, yes.
For every, and the Spring extensions for Quarkus are part of the BOM, right? I saw one of them, the Spring DI, but I guess all of them are. So
I
basically
think so.
check.
I haven't checked, but yes, I think so. Yes.
Okay.
But
thanks. Yeah.
It's a matter of checking which are the needs of your real project, and then check with Quarkus if it's covered or not. It could be that you need to do a workaround, you need to do another approach.
Yeah, just a question. Let's say you have a platform where you have a lot of beans or whatever components, and you want to give the ability for customers to replace any of them. So right now in Spring, you will do it like with condition on missing bean or whatever, like auto configuration where if there is no bean that is defined by the customer that hides my bean, then use the default one. How, if you do this with Quarkus, let's say you have one big jar with a lot of beans, sorry, and you want to give the possibility to the customer to replace any of them, is this gonna even work?
But if you are using, so what you cannot do is use the dependency injection from Spring context in your Quarkus.
No, ignore the Spring. So let's say you have currently a Spring Boot project with, I don't know, you built something that has a basic store, let's say, a basic functionality. and you give the possibility to a customer to replace any of your beans with his bean.
But the core still is Spring
No,
context.
no. Let's say you migrate the core to Quarkus.
Okay.
But now you have, for each bean, you have an interface. You have a bean defined in your jar, and then you have a bean defined in the other project. Is Quarkus going to work?
Yeah, that's the regular.
But you don't extend the middleman. You just implement the interface. You don't know the.
Yeah, that's
Okay.
what dependency injection is. So I mean, yeah, you can use the default.
Yeah, but the thing is, I was
for
thinking
the
because
bean.
it's compile time, it needs to know the order. In Spring, kind of, you can have an order.
Okay, I see you.
And you can make an order to say, like what is the latest bean that I want to use? While in Quarkus, everything is more like flat. So
yeah, it's a good question.
also in Spring, there is the order, but it doesn't actually work like order. Is there something similar in Quarkus? Like, can I put an order 900, and then I know this is the...
No, but because the artifact produced
is
needs
common.
to know. Yeah, I don't.
Yeah, I will
know.
check. I will check. Okay, thank
Yeah,
you.
no, I don't know. I haven't checked that option, but good question.
Just maybe a joke, but the most important two words that I've heard of all the Tyriat of Nyland was ignore Spring.
Any more questions?
But the JPrime website still runs on Spring. But we can migrate it, by the way.
Are there any tools which help you to migrate from Spring to Quarkus? Just not like extension, it's about migration. You mentioned that it simply replaces the annotations or add something. I think because yesterday one of the speakers talked about open rewrite tool. It's allowed to maybe in one, or not in one, in 2 clicks migrate from Spring.
I'm not aware. I think there is still no recipe for migrating from Spring Boot to Quarkus. But when I was working for Red Hat, I was part of a team with a tool, open source tool that you can download, that it has a recipe to migrate from Spring Boot to Quarkus. This project is called WindUp, or Migration Toolkit for Application. What it will do is to analyze your source code, and it will show you which are the changes that you need to do in order to migrate from Spring Boot to Quarkus.
Hello, I have a question more from your experience and your real project. Do you use native in production or in all environments, or you use the hotspot?
Yeah, in my case, I haven't. Oh, yeah. I had once, yes. Once in production, it was, in this case, we were using Quarkus to create a Kubernetes operator. And we were producing the native artifact in order to be deployed, and we were running it. It was running fine, no issues. But again, it all depends. So I've heard that in some cases, the native artifact produced by GraalVM, it could have some issues on the throughput. But I haven't experienced that. In that particular case, was not super important because it was simply a Kubernetes operator. But I don't know. Do I answer your question?
Yeah, thank you.
No more questions? OK, thank you and have a good afternoon. Oh, you have one? OK.
Once again, if you came for the session Cracking the Cold Start, unfortunately it's not going to happen because Wojtek could not make it to this conference, so we had to replace this talk by Alvaro Sanchez. Yes, I say it correctly. Yes, so once again, this talk, actually Alvaro going to make two talks about Micronauts. So this one is going to be like the first talk will be Micronaut about GraalVM, and the second talk will be as it is scheduled. So please consult with the JPrime website when you'll see the latest program. So once again, if you came for another talk, well, you will just have to stay here. Sorry. So next thing I should say that right after this talk on what was the time? 14:45. Oh, yes, exactly. 14:45. There will be a raffle for everybody who is registered for QualiFast. So if you have registered for QualiFast raffle, it's going to happen right after this talk. And if you are registered for Mentamate raffle, it will be right after the next talk. So in two talks. Yes. So once again, this is a replacement talk, and we are very grateful for Alvaro Sanchez for making it. And okay, I guess this is time to start. Please warm welcome our good friend, Alvaro Sanchez.
Thank you, everybody. Thanks for joining this session. As he said, there will be two sessions about Micronaut, so I hope you will enjoy them. Let me introduce myself first. My name is Alvaro Sanchez. I am working at Oracle Labs, or Oracle, wherever you like it. I'm coming from Madrid, as you can tell from my British accent. It's like perfect. I've been always working on the Java ecosystem, and currently I'm working on Oracle Labs, on Micronaut and GraalVM, or part of GraalVM. I've put some of the things that I work on the project, but it's mainly build tools, Kubernetes integration, integration with other clouds, etc. I'm also want to tell you something because as you can see on the slide, I've been working on Micron since the beginning. So we started this project in 2017. The team creating Micronaut is the team who was working on Grails. Anyone knows Grails? Raise your hand if you know that. Yeah. So we started in 2017. Originally, this wasn't called Micronaut. We had a code name which was Particle. But Particle, we couldn't choose that name because the domain name was chosen, so we had to find something else. So we ran a poll internally in the team to choose a new name for the framework. And I proposed an idea which wasn't selected. I still don't get why. I proposed the framework to be named Summer. And you will guess why, and it's because summer is better than spring. This is meant to be a joke. Winter is coming, winter is coming, winter is coming. That could be another option. All right. OK, so now I would like to know about you. So how many people is using Spring, or Spring Boot. Yeah, keep your hands raised. How many are using Quarkus? Okay, everybody can leave the room, please. No, I'm joking, I'm joking. Those are great frameworks, of course, but I'm presenting you something new. How many have ever heard or actually used Micronaut? Okay, very few. You're in the right place. So yeah, before we get further, I have the slides on speaker deck, so you can take a picture if you want. So let's talk about Micronaut. There's three ideas I would like you to get from this session. One is that Micronaut is a modern Java framework. As I said, we designed this from scratch in 2017, thinking on the type of applications that were created or are created nowadays. So that is microservices, serverless functions, message-driven applications like Kafka consumers or producer, etc. If you think about it, none of that was or existed in year 2000 when your popular Java framework was created, right? So we wanted to take a step back and to create something new, thinking on the type of applications that you could use now. The second idea is that you can use Micronaut for any kind of application. People typically use it for creating like microservices, REST servers, APIs, etc. But you can create command line applications. You can create, like I said, serverless function. You can create a Kafka consumer or producer with no server whatsoever, whatever you name it. And the third idea, performance. Performance is really important for us. It is highly optimized in terms of memory consumption and in terms of startup time. And the way we do that is with the Java facility that existed since a long time called Annotation Processing Tool, APT. So there is a technique called AOT, Ahead of Time Compilation. The idea is that all the things that the framework needs to do, if you think about, for example, when you, in Spring or Jakarta IE or wherever, when you use add AutoWire or add inject on a constructor or whatever, those frameworks, those traditional Java frameworks will typically, at runtime, generate a proxy using like a CGLib library or whatever, will generate a proxy class that will, subclass your actual class and will do all the wiring to pass you an instance of the dependency that you're looking for. And we'll do all of that at runtime. It will scan your class path at runtime. It will use reflection for some manipulations, like, for example, changing the visibility of private fields and whatnot. We'll do all of that at runtime, although it's true that they're moving some part of the workloads to do at compile time, but mostly everything happens at runtime. Reflection is really slow. And because reflection is slow, there are reflection metadata caches. But not only for example, for Spring, but also Hibernate has its reflection cache. So memory consumption grows and grows and grows and grows. The approach we took is different. The approach we took is hook into the compilation phase, right? So we process the source code at compilation phase and generate all the framework infrastructure at compile time. And we produce bytecode. We produce bytecode which sits along your classes. So at runtime, there's no reflection, there's no proxy generation, there's no dynamic class loading, no class path scanning, nothing. Another difference is that, for example, the stack traces. So how big is the stack trace in Spring? It's like a huge, right? Because you've got your classes and then a lot of things like proxy, blah, 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 right? With macro, that's not the case, right? Because there are 2-3 classes per bean, more or less, something like that, like a bean definition, a bean implementation, and that's about it. So it's much easier to debug. Like I said, it's a general purpose framework. You can use it with any built tool language. Well, not any language. It's Java, Groovy, and Kotlin supported. All major clouds, major technologies, etc. In terms of history, as I said, we started on 2017. On 2018, we released the first version, and today we are on version 3.9. We're about to release version 4 very soon. Quick overview of the features. Dependency injection is the core feature. So you can use JSR 3.0 annotations or even Spring ones. Regarding the Spring integration is actually nice because we have the ability to take a Spring application. If you take a Spring application, you add a Micronaut dependency, the Micronaut runtime dependency, and the Micronaut annotation processor to Spring application without changing the source code, we are able to run that application as a Micronaut application. And the way this happens is because we are able to map at compile time the Spring annotations into the Micronaut ones for those that are like a equivalency. For example, in Spring, you will see that later, but you can have get mapping, we name it get, right? So that's mostly the same. So there are like 80% of the annotations are the same. And for those cases, you could even do that. In terms of configuration, you can use different configuration formats. You can have type-safe configuration classes, validation, built-in validation into the configuration, etc. For validation, we have built-in validation module, annotation-based as well, but it is, again, our own implementation, reflection-free, way faster than Hibernate Validator, but it's not fully compliant with Beam Validation API, because that API, that specification is reflection-based for some part of it. So if you need the full Beam validation spec support, you can just add Beam validation API to your class path. There is an AOP framework that we use internally, and if you are developing libraries, you could use it as well. But again, the difference with others is that everything is compile time and reflection-free. This would be Hello World. So as you can see, the programming model is annotation-based. So people coming from Spring will feel at home. There is also an HTTP client integrated. So do you know Spring Cloud OpenFane? Yeah, the declarative clients. Yes, correct. So this would be similar. You add an annotation to an interface with Micronaut annotation mappings like get, post, etc. And we generate the client at compile time. So again, Fane or OpenFane will generate the client at runtime. The Micronaut implementation will generate the client at compile time. In terms of messaging, we have support for the major systems, for data access as well. There is a module called Micronaut Data, which uses the repository pattern. So you should be familiar with this if you've used the Spring Data before. But there are differences. Like, for example, again, this is going to be implemented at compile time, right? There's some nice features, like, for example, based on the method name, we will figure out which is the query that we need to generate, like you have in this find by example, right? But there's something even better, which is if you make a typo. So imagine suppose we have a user class, right? User entity class that is supposed to have a name property. If you make a typo on the property, it will not compile, right? As opposed to having a runtime exception with other frameworks, right? The same happens, for example, when you, in a controller, when you use a path variable, a path variable can, you need to refer the, in curly braces, you put a path variable, and that needs to match the name of the parameter in the method, right? If you were to make a typo there, it will not compile. So we will compile, time check those things for you. So you don't need to get until runtime to discover your issue. In terms of security, well, I wouldn't enter into much details, but essentially we got you covered, so all the major things are there. It's again annotation-based, but you can use configuration if you will. OpenAD Connect, WAS2, JWT, blah blah blah. There are more things: distributed tracing, distributed configuration, service discovery, GraphQL. There is a nice integration with test containers, which not only allows you to use test containers directly, but also we will enable you what is called test resources. And test resources is a way to, without any additional configuration, we will determine based on your dependencies and your configuration if we need to spin up a test container. For example, if you have, I don't know, the microdata JDBC and the MariaDB driver on the class path, and you have not provided the JDBC URL for that particular environment, we will spin up a test container automatically for you, and we will wire up those configuration properties into the application. And you can use that for development, so running the application. You run the application. Before running the application, we will start the test container. We can leave it running in the background if you will, so you can stop and start the server no matter how many times you want. And the same happens for tests. So you can write a test, and we will, you can run your test many times, but we will keep the container running all the time if you want to. So the integration with test containers is really nice. How you get started? So there is a website called Micronaut Launch, launch.micronaut.io. This is similar to Spring Start Spring.io. You select the features, Java version, etc., and we will generate a skeleton application for you. This is CLI if you're more like a terminal person, an IntelliJ IDEA Ultimate Wizard, or a Visual Studio Code extension. Some comments on what's coming in Micronaut 4. We're ramping the minimum, the baseline, the Java baseline to Java 17. So Micronaut 3 supports from Java 8 onwards. Micronaut 4 will only support Java 17. So upgrade if you haven't done so yet. This will allow us not only to use the modern features of the language ourselves in the internal code base, but also will have benefits for the end user. Like for example, you could use virtual threads if you want. There is a new lighter weight client implementation based on the new JDK HTTP client. And if you need to use any other version, you can use Micronaut 3. That will be supported for several years. The new version of Micronaut Data 4 will support Hibernate 6 and Hibernate Reactive. The Micronaut runtime is becoming smaller and lighter. So Hello World Micronaut 3 normally takes, in a modern hardware, like 300 milliseconds-ish, more or less, to start. With Micronaut 4, we're in the range of 200 milliseconds. That is close to raw netty. This is an amazing achievement because you can't imagine how much time we spend on shaving every millisecond we can from the startup time, right? Actually, one of the Micronaut committers is a netty committer. So you can imagine the net integration we have is really, really tight. And there are other features that you should be able to check once we do the release. There will be like a new compile time expression language, similar to Spring Spell, but again, compile time checked, so no typos. And something called control panel, micro control panel, that is going to be a development UI, where you can check what's going on in your application. You can check all the configuration properties, the property sources that have been loaded into your application, where are they coming from, what they have inside, what are their priorities. You can check all the bins that have been loaded for a particular package and their dependencies. You can interact with the login system, and live disable or enable login for particular packages. So that's about it. Now let's talk something about GraalVM. So how many of you have used GraalVM? OK, very few. Let me tell you what it is. So GraalVM is an OpenJDK distribution. You can use it for your local development. It's the JDK that I have on my machine, right? It's GraalVM. Instead of Eclipse mirroring, you can use GraalVM, and it's going to be the same because this is an official OpenJDK distribution. And on top of the regular Java JDK tools like Java, Java-C, etc., there is a new component called native image. So with GraalVM, you have two options, two choices, two different paths you can follow. One is like the regular one. So you compile your application and you run it with the just-in-time compiler. OK? The other option is use AOT compiler, an AOT compiler, to produce a native executable for your machine. The difference is that this native executable will start in fraction of the time than the regular JVM. You will see that later. So the goals are to start fast. It consumes much less memory. Minimize vulnerability because the native image, this executable I'm telling you, is a closed world version of your application. So the AOT compiler will traverse through your code and will drop from the image code that is not reachable, right? So it will optimize, essentially reducing the surface attack of your application. And we'll give you a single binary that you can distribute for that particular architecture. That means that, for example, if I produce a native image on Mac, it can only be run on Mac. In this case, ARM, or if it's an Intel, then on Intel, or whatever. The combination of Micronaut and GraalVM is special because GraalVM is supported by the 3 or 4 major Java frameworks, so Spring, Quarkus, Helidon. They all support Micronaut as well. Sorry, GraalVM. The integration from Micronaut is special. I'll tell you why, but you can get as low as 6 milliseconds startup time. So remember, 300 versus 6 for Hello World. You can see, like a non-trivial application, how much it takes. Memory consumption is, again, a fraction, like 10% of a regular Java application. So regular Java Micronaut application, Hello World, could be around, I don't know, 100 megabytes of heap. With GraalVM is like, I don't know, 15, 12, 20, something like that. And the throughput, on some cases, is even better because GraalVM has its own compiler that performs some optimizations on your code. And this combination of Micronaut and GraalVM is unique because they are both developed at Oracle Labs. So the teams are next to each other. Also because Micronaut has been ready for GraalVM native image since day one, right? It took others several years to get this support for GraalVM, because essentially for GraalVM, whenever you use reflection, or when you generate dynamic proxies on the fly, or for example, when you load a class dynamically, right? If you load a class dynamically, GraalVM needs to know, because it needs to put that class into the image at image building time, right? You cannot, at runtime, on GraalVM load any random class if it's not in the image, right? Same happens with reflection, right? Reflection needs to be properly configured. So, it's true that GraalVM has become better at detecting automatically reflection usages or, for example, proxy generation. Because, for example, generating a proxy, you could generate a proxy for an interface that is not on the class path, and that class will have to be put on the image as well. So it is a complex situation. But GraalVM more or less will detect all those cases. But essentially, since we don't do any of that, it's been simpler for us to have support for GraalVM. And finally, the extension pack for Visual Studio Code is maintained by Oracle as well. And that gives you support for both Micronaut and GraalVM in Visual Studio Code. There is one use case that I want to tell you about, and is Disney+. Disney+ is using Micronaut and GraalVM for the Lambda deployments. So if you think about the startup time, is not only the development experience that you will see that later, but also in a serverless or in a cloud in general, the less time you're actually running things on the cloud, the cheaper it is, right? So less time is less money, literally. And Disney Plus is saving a bunch of money just by using Micronaut and GraalVM for their functions. This is a comparison of the cold startup, right? The cold startup is the time that it takes for a function that hasn't been called before or in a period of time to become ready. Now, it's true that the bigger the Lambda is, so the more resources it has, the less time it takes to make it ready, right? So that's why you see on the right, like for example, a Lambda with 3 GB of memory will start faster than a Lambda with half a gigabyte. But still, you can see the numbers. So it's not even comparable, right? And you're built by the time your Lambda executes, right? So that's money. So let's do some coding. We'll have some time for questions after this, so save them for later. Can you see this reasonably well? Yeah? Bigger? Good question. Let me try, because I think there is a setting here that should help. So what I have here is an empty Micronaut application generated from Micronaut launch. The only things that I have added, because they are not relevant for the coding session, is a couple of flyway migrations, just to create one table and to insert a couple of rows into the database. That's all. But other than that is an empty main class and application YAML. This is all generated from Micronaut launch, so I didn't change anything. There's nothing else inside. So let's create some things. So the first thing I'm going to be creating is like a team entity. This is going to be a record. And we're going to put here at ID, at generated value. I'm using Jakarta Persistence API annotations, but I'm not using JPA. just the annotations, right? So this is using microdata JDBC. But you can see that at the source level, you can use the annotations of JPA, but we're not using Hibernate whatsoever. That's why I had to create the migrations and everything. Microdata JDBC is the lightweight version, and then you have microdata JPA, which uses Hibernate under the covers. Long ID, string name, and the stadium. And this is going to be at entity. And that's about it. Now, the next thing I'm going to create is an API contract. And you will understand that later. I'm going to call this team API. This is an interface. And I'm going to be declaring like a constant path, which is equals to /teams. And then a couple of endpoints. One is iterable of team list. And the other one is HTTP response of team get, and we receive the ID. And this is a get again, and this is the ID. Okay. So in a REST controller, depending on the return time, Micronaut will figure out how to render the response to the client. So in this case, is like a regular list or something that looks like a collection. So we will serialize that into JSON. By the way, there is another substitution for serialization called micro-serialization, which is a replacement for Jackson. Jackson is great, but it's heavily based on reflection. It will add, I don't know, 100 milliseconds of overhead to your startup. So by default, we ship with micro-serialization. But again, you can use Jackson annotations, and we will figure out how to read that and make this serialization ready. But by default, like for example, I have a record, I don't have to specify any annotation, right? Defaults will just work. Now let's implement first the controller. So this is going to be class team controller. Which implements team API. So let's implement the methods. I'm going to be declaring a constructor dependency. So this is private final. Before that, let's create the repository. Team repository interface, which is this is a JDBC repository because I'm using microdata JDBC. I need to specify the dialect because Micronaut data needs to know, for which database it needs to generate the queries at compile time. And this extends from CRUD repository, and the entity, it's going to be team, and the primary key, it's long. And that's it, because with the default queries, I'm all set. I don't need anything else. So then in my controller, I will add this constructor dependency, so private final team repository, and then constructor. So constructor-based injection, no need for @inject annotation. This is implicit. Micronaut will figure out, since there is no default constructor, this is the only way to create an instance of your controller, and it will give you an instance of the repository for you. The list operation is simply repository final. Like I said, if you return a collection or a POJO or something simple, Micron will render that as JSON, but you can wrap that content, that body, into an HTTP response in case you want to tweak, I don't know, something about the HTTP response, like status code or headers or whatever, right? So in this case, what I'm doing is repository, find by ID, and then we're going to convert this into HTTP response OK with the body enclosed, or else what? Not found, which is this. I think I'm done. So let's run this. Still 50 minutes. So let's run this and see how it looks like. There's different ways to run a Micronaut application. Most simple one is just go to the to the main class and run it from your IDE. That will just work if the demo gods are with me. I think they are. So yeah, that took a long. Yeah, don't laugh. That's unfair. It's probably something related to the network. OK, 672 milliseconds. OK, that's probably OK. And then I have, what do I have? Some requests. So we can request this last team's endpoint. Demo gods. Oh, yes. Good spots. Yeah. Very nice. Bonus point for you. So this is a controller, obviously. And we need to specify the path. And that's why I have the constant for. So let's run this again. And then if we go over here, why? Empty platform server. Let me disconnect the Wi-Fi. You never know. OK, let's do something else. Let's do something else, because in case this could happen, I got a solution project. So don't worry. This time, I'm going to be using a different way to run the application. So there is a Maven plugin or a Gradle plugin that you can use. And in this case, if you use mnrun, it will run the application in development mode. Running the application in development mode means that we will scan for changes in your source code. And whenever is a source code change on the application, we will restart the server. Not hot reload, but restart. The reason why we did this is because hot reloading an application is essentially a can of worms. So it's really difficult to get it working correctly for all these situations, because you have frameworks that do nasty things with class loaders and stuff like that. So we didn't want to mess with that. And since startup time is so fast, we thought it was enough to just restart the application. OK, so now if we go where? If we go here, oh, come on. It's failing. I don't know why. OK, trust me, I've done this several times. It should work. but for some reason is not. Let me check real quick. So 8080, everything was correct. Yes, migrations have been created. And it says it's listening. So okay, this makes sense because this is last teams. Oh, we have it. So IntelliJ was fooling me. Yeah. Okay, so we have this, and then we can get a team by ID. And if we get, I'll do that here. So if we curl a team minus I0, like, for example, an ID that doesn't exist, we get maybe it's localhost the problem. Wherever. So it's not found, right? Not found. Okay. The final thing that I want to show you, I have still some time to do that, is the GraalVM integration, right? Oh, before that, let's write a test. So should I write a test for it? Yeah? OK, let's do that. Let me make sure that we don't have. Actually, I will use the solution project. I will use the solution project. OK, this is how a test looks like. This is a JUnit 5 test. You can use JUnit 5, Spock, or code test if you're using Kotlin. The idea is that you annotate a class with microtest. This will spin up an instance of your application on a random port and will allow you to do dependency injection on your test. So you can, for example, grab a bin, invocate a method on a bin, and then make an assertion over the response, right? So now, how many of you use Mockito in your test? Like a lot of you, right? So one of the reasons why unit testing in general and the testing pyramid is like a lot of unit tests and then less integration tests and then very few functional tests is because normally functional testing is expensive, takes a lot of time, consumes, well, memory is irrelevant, but it's mostly about the time that it takes, right? So it's not feasible to wait, I don't know, 10 seconds for a single test to run. Right? So then you write a unit test, and then you need to mock things out, etc. Right? With a framework with the startup time like the one from Micronaut, you will reconsider this testing pyramid. Because, for example, I can run a single test. And again, if the demo gods are with me, it should pass. It took 400 milliseconds. This is including, obviously, speeding up the server, running the flywheel migrations, because it's the whole application, right? There's everything running. There's no mocking. There's no, it's like the real application running on your test, and it took 400 milliseconds. So the feedback cycle is amazing, as you can see, right? And now you would say, I don't believe you, because this is impossible that we're running like the server and having a client. There is another thing that I didn't show you that I will show you right now. You remember this Team API interface that I created? There's two children. One is the server, and another one is the client. So this is a nice thing to create a testing client for your application with a single contract. This is amazing, isn't it? Right? So you have an interface with all your server endpoints, and then you implement the same way on the controller and the client, right? Took me no code to implement it. As you can see, it's an interface, right? And I'm grabbing this client to make requests, right? I don't have to deal with the low-level HTTP client. There is one if you want to use it, but I don't have to deal with that. And you have full access to wherever the interface is returning. So, for example, this is returning a team. So I have, the response already serialized into an entity. Or in this get example, we have the response wrapper, so we can check the status code or make an insertion on the body, right? So let's run this one. This one was a bit faster, 367 milliseconds. This is absolutely amazing. Another thing I want to show you is, because I knew you would be suspicious and say, OK, this is going to be fake. This can be real. So let me show you, for example, the logback configuration file. So I've included trace level for the HTTP client to demonstrate you that we are running the application on a random port. We're making a request to that endpoint, and we're having a response. We're serializing that, and we're running everything in less than 400 milliseconds. How do you like this? Do you like this? Yeah? Final thing, native image. So let's do that. There's, Maven package will, generally speaking, package your application by default. Maven package will give you a jar file. We have custom packaging types via the Maven plugin. So, for example, if you specify that your packaging type is a native image, you will get the native image binary of your application. Nothing else is required. I have been doing this demo for quite a few years. Like 3 years ago, I couldn't generate the native image live on stage because it wouldn't finish, and it would blow up my laptop. But now is modern hardware and newer versions of GraalVM will do this in less than a minute. There's other packaging types, like for example, you can specify a Docker packaging, and then we will give you Docker image. We can push it to a registry if you will. Or you can specify Docker native, and what we will do is we will build the native image inside the Docker container and give you that Docker image, or push it if you will, right? And everything is done under the Maven package lifecycle phase. So this is about to finish. One minute, including Maven overhead. So this is target, team solution. Be ready to watch it, because if you blink it, you miss it. OK, this was unfair. Let me do it again. 37 milliseconds. And this is including flyway and blah, 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 migrations and everything. So this is absolutely amazing. So let's wrap this up. As you can see, this is a general purpose framework. You don't have to change your current framework if you don't have to. But I want you to think about things you saw here that would maybe reconsider if you think that this is a better developer experience. I personally think it is. So you get faster feedback while developing. because everything runs faster, feels like smaller. And you could argue, OK, this is a hello world, and you know, whenever you are working on a real application, this will get much worse. Now, the reality about that is not entirely true. In Spring or Jakarta EE, application have an impact proportionally to the startup time. It's proportional. The more beans you have, the slower your application is. But with Macronaut, it's not the case, right? It's obviously going to consume a bit more, but it's not going to be linear proportion, right? So in a real application, obviously, we wouldn't be talking about 37 milliseconds, but who cares if it's 100, right? So it's really fast. So now imagine the places where you can introduce Java or your application. Like, for example, serverless function that start really fast. Or, for example, if you're deploying into Kubernetes, you can have like a rolling deployment that can grow and shrink your application really quickly. So I want you to think about all those things and then potentially consider if you want to change to Macronaut. So we have some time for questions. Meanwhile, I have a small survey for you. It's a single question with a 1 to 5 rating. So I really appreciate if you can give me feedback about this presentation. I understand the demo gods were not with me today, or partially. The test passed. So at least the test passed. So I'm happy with that. But please, if you have time, I will appreciate your feedback about that. And at the same time, can someone make a question for me that I'm really happy to answer? There is one over there. I think you need a mic. OK. No, you can use reflection. What I said is that we don't use reflection internally in the framework, but you can use reflection, right? I think there's always a different way. So you can still use Mockito in your test. There's nothing preventing you from doing that. Do you have any other question? One over there. Well, I can come closer to you and hear you. Yes.
So, two questions. First one is about Hibernate validator. You say that Micronaut actually supports it.
Yes.
I understand how Micronaut can scan the source code and build those proxy during compile time. So,
yes.
Okay, but Hibernate validator is already compiled library that has a lot of reflections within it.
Yes.
So how do you work with it? So do you apply some byte or?
Right. So the question is how Hibernate validator works in a Micronaut application. The answer is similar to the previous one. So it's not the case that you can't use reflection in a Micronaut application, but obviously if you do, you're adding overhead to your application, right? So adding Hibernate validator to your class path will possibly duplicate your startup time and will skyrocket your memory consumption, right? You can still use it, and reflection will work, everything will work. So that's not the question, but
And the second one is about
yes.
grand VM thing and all.
Yes.
So Java has just-in-time compiler.
Correct.
And that's why it's so performable.
Correct.
On a
Yep.
basis. But as far as I'm concerned, when you create a native library, so
Yes.
there is no just-in-time compiler.
There's no just-in-time compiler.
Just make a binary and that's it. It's
Correct.
somehow.
Correct.
But if you deploy a regular Java application, so it will compile specific
Correct.
that for this node.
Yes.
And if it's possible that you make a binary that's not suitable for a node you have.
Yes. So the question is how essentially what is the difference between the JIT compiler of the JDK and the GraalVM compiler? So when you run an application for a long time, like you have a server running, the JIT compiler will kick in. After a few iterations, it will learn how your application is being executed, and it will perform some optimizations over your bytecode, for example, inlining methods or whatever, right? That's true. Now, what happens in GraalVM? So in GraalVM, it's true there's no JIT compiler, but there's a GraalVM compiler which has its own optimizations. It does those optimizations at compile time. And the benchmarks say that they're running benchmarks, for example, for mathematical operations and, I don't know, artificial intelligence libraries, things like that. They get better performance than the JIT compiler. So it's absolutely amazing the effort they have done to make. They even made a Java program doing mathematical operations faster than the C counterpart. It's absolutely amazing. So the throughput is incredible. It's incredible. There are obviously, depending on your application, this is not like a golden rule for all applications. So depending on your use case, it may be that for your use case, the JIT compiler is going to be better. But generally speaking, I can say it's really performant. Really, really performant. Yeah, you're welcome. Yeah, my pleasure.
Now, in your opinion, how difficult is to migrate from Spring Boot application to Micronaut? And have you done such a migration?
Yes.
What is the performance benefit that you?
Yes. The question is how difficult it is to migrate from Spring Boot to Micronaut. The answer is this is a political deal. It's not a technical issue. It's a political issue, right? If you are able to solve your political issue, then technically speaking, what it takes. There are several approaches you could take. So one is, for example, potentially use Open Rewrite. We have one of the maintainers here. Open Rewrite to write a migration for that. That will be one of the things. But we offer you different ways which we think are better. So one is using the Micronaut for Spring library. With this library, we can take a Spring application. You can keep the Spring source code, Spring annotations, but add a couple of dependencies, runtime dependency and a notation processor dependency, and we will run that as a Micronaut application, and everything will just work, but we will just not use the Spring application context whatsoever. But we will have your beans and your controllers and everything. Obviously, this is for the cases like we have, for example, most of the Spring MVC, Spring Security. There are many annotations supported that we map them at compile time. And with this approach, so the first application, the first Spring application in the world that was able to run on GraalVM a few years ago was thanks to Micronaut for Spring. So we have that success. So because they wouldn't have a Spring Native back then, it wouldn't work at all. But at the Micronaut for Spring, we were able to actually have a Spring source code compiled into a native image. So that is one thing that will obviously cover like a basic application, or not very basic, but depending on your application, on the libraries you use, normally everything else will just work, because if you have Jackson, it will work. If you use Hibernate, it will work, right? So more or less everything it will work. For other use cases, the recommended approach would be to use Micronaut Spring Starter dependency, right? But then you will have to switch from partially from Spring building blocks into Micronaut ones. That will require a bit more effort, right? And there's another way, like for example, you can have in Spring application, you can set the Micronaut application context to be the parent of the Spring application context. So with this approach, you can mix and match Spring beans and Micronaut beans in the same application. And this works because the Spring application context has a hierarchy. So essentially, when someone is requesting a bean of a particular type, it will, if the current application context doesn't have it, it will ask to its parent. So with this trick, you're able to mix and match beans from the two frameworks, and you can, while the application is still running, you can migrate them step by step.
What is the expected performance benefit?
I don't know. So hello world in Spring, what it is, 2 seconds, something like that. So 2 seconds versus 300, right? So it's 10%, is 10% less, not 10%, 90% less, right? So, and like I said, the bigger the application is, so there is a linear dependency between the lines of code and the number of beans your application has. Because Spring will actually scan your class path, your entire class path at runtime. It will look for annotations. They are removing some parts of that, for example, with this annotation index. So they're like moving some things to the compile phase, but still, it will take a lot, right? So with a big application, the bigger the application is, the more benefit you will face. And again, some will argue, OK, but I have my server running all the time in EC2 instance or whatever, so why do I need to start that fast? And the answer is because of you, not because of the server. So the server doesn't care, but you do, right? So you want something that you can play with really quickly, something you can dispose and restart and rerun again and run test and feel fast, right? So I think that's the key. Do you have any other question? Thank you very much. You've been a fantastic audience. There is another session about Kubernetes operators. So stay here or grab a coffee and come back. Thank you.
So how many of you like Micronaut now, even more than I do? Okay, lovely. So that's going to be a second talk by Alvaro. Alvaro is our official hero of this edition of JPrime. He's doing 2 in a sequence. Applause for Alvaro. Bravo. Yes. Thank you so much. Yes, thank you. So just to remind you, after this talk, there is another raffle by Mentimate. I'm not sure, is there anyone who wants something from Qualifast? Yes, no? Not in this hall. Okay, so you still have a chance to win something by Mentimate right after this talk. And once again, Alvaro is already on stage. Alvaro, please continue about wonderful Micronaut. Thank you so much.
Thank you. Before I begin, how many of you were on my previous presentation? Okay, less than a half. Okay. How are you? Are you having fun at this conference? Yeah. Okay. Thank you for joining again. This session, in this case, is about Kubernetes operators in Java. My name is Álvaro Sánchez. I work for Oracle Labs, working on Micronaut, which is an open source Java framework. Oracle Labs is a research and development organization inside Oracle, which is also the organization that maintains GraalVM, that you probably have heard of. Well, I will go quickly because some of you were already at the previous presentation. So you were, the first thing I want to tell you, please don't go. Remember this song? Please don't go. And the reason I'm telling this is because whenever we are into the Kubernetes ecosystem, it looks like everything has to be done with Go. And that's not the case. You could do it with Java, right? So please don't go. Please Java, or please Micronaut. The demo code is available on GitHub in case you want to check it. So I'll give you a minute to take a picture. I will go quickly over the Micronaut introduction because I haven't done it before. Then I will tell you about the Micronaut Kubernetes integration. And finally, I will do like a demo of everything working. So Micronaut, there's three things I want you to get from this presentation. One is that Micronaut is a modern Java framework. It was created from scratch in 2017, thinking on the type of applications that were created back then. So think about it. So microservices, serverless functions, CLIs, you name it, right? And this is not like the type of applications that were created in year 2000. So like WAR files, ER files, servlets, whatever. None of that is being done anymore, right? So we wanted to do something from scratch, thinking on the architecture of today. The second thing is a general purpose Java framework. It's open source. You can use it for whatever you like it. People typically use it for microservices, like REST APIs, but you can use it for whatever you want. And the third idea is that it's highly optimized. Performance is a key concern for the team. We focus on the startup time and the memory consumption of your applications. And we dramatically improve those things by moving all the workload, or most of them, to the compile phase. So we do that through something called AOT, ahead-of-time compilation. So the idea is that all the framework infrastructure is generated at compile time, as opposed to other Java frameworks, such as Spring or Jakarta EE, where everything is done at runtime, or most of the things are done at runtime. So we do that at compile time. So that at runtime, there's no proxy generation, no reflection, no dynamic class loading. We don't scan your class path whatsoever. So everything is faster. Faster in like 90% faster. It's a general purpose framework. You can use it with major technologies. Well, we're about to release version 4, so we are already some years down the road. There are some features I will skip these slides because it's not the main part of this presentation. This is like a hello world, so you can see it's annotation-based. So we, on purpose, designed the framework with an annotation programming model so that those coming from Spring could feel like at home. There is an HTTP client, an HTTP server, messaging support. There is a module called Micronaut Data, similar to Spring Data, where you can define your repositories, support for security, similar to Spring Security, and then many other things, like, for example, something comparable to Spring Cloud, I don't know, test containers, you name it. There's different ways to create a Micronaut application. There is a website, launch.micronaut.io. There is a CLI, an IntelliJ IDEA wizard, and a Visual Studio Code extension. I will skip what's new in Micronaut 4 and get directly into Kubernetes support. So how many of you are running Kubernetes in production today? Raise your hands. Not many. OK. That's good, because looks like everything has to be done on Kubernetes. It's not the case, right? So Kubernetes is one option. So this session is obviously about Kubernetes operators. So who knows what is an operator in Kubernetes? OK, I will have to explain that. No worries. I will do that. So that's one takeaway you will have from this session. You will learn what is an operator. Now, I want you to think on Micronaut application. It could be a Spring application or whatever. So think about an application that is running that you want to deploy on Kubernetes, and how that application interacts with the things that are surrounding, right? Or what things that application could do that would be impossible in a different environment. So imagine about service discovery. The idea of service discovery is that you have, I don't know, the shopping cart microservice that needs to talk with the orders microservice, and they communicate with an HTTP client, right? So there is this question of how is one microservice able to know how to make a request to the other microservice, right? This is service discovery. Service discovery is the ability to auto-configure that. So to have HTTP clients that are aware of the different services of the systems. So you don't care about the actual IP or port or node that is running each particular instance. There are different ways to achieve service discovery. Outside of Kubernetes, you can use Consul. You can use, well, Consul would be like the most popular choice. But inside Kubernetes, Kubernetes has native support for service discovery. Now, how would you use that in a Micronaut application, right? So imagine you don't use the Micronaut Kubernetes integration. So you just deploy your application, and I have one client that needs to talk to different service. So as you can see, I will have to specify the URL, like the host and the port directly. And this will map to the name of the service. This works because inside Kubernetes, there is a DNS component that will resolve this host to the pod where the application is running. So this you can save like IP resolution, right? But still, you have to deal with the port and the HTTP schema. So it's suboptimal. It is much better to use the integration, and to simply specify the service ID. And in this case, Micronaut will figure out via the Kubernetes API which are the endpoints where the my service is listening, right? And it will run robin through them. You don't have to care about that. You don't have to care about ports or HTTPS, anything, right? It will just work. So far, so good? Yeah? Blink if you agree, because I can see many feedback. So like I said, service discovery, this ability will allow your Micronaut application to easily reach out other services. And by easily is literally like this, using the service ID. Nothing else required. Well, obviously, dependency, configuration line, but that's all. The second thing is distributed configuration. So again, you can achieve that with console. Anyone using console here? Only 1, 2, 3, OK. The idea of distributed configuration is enabling one application to read configuration from an external source, right? So typically, when you package an application like a YAR file, you ship configuration file inside, right? Like application YAML, application properties, whatever. But a Micronaut application, as well as a Spring application or Quarkus application, whatever, all those frameworks are able to read configuration files from other sources. Like you can pass system properties. They will read environment variables, right? So those are like coming by default on all of them. Now, if you're on Kubernetes, there is an additional option, which is to use config maps and secrets at sources for configuration. So the idea is that your application is not only able to read values from application YAML or properties. By the way, this file could be packaged into the YAR file, or it could be like an external file that will work as well, right? But in addition to that, in addition to the system properties, in addition to the environment variables, you can read values from a config map. Which is the benefit of this? The benefit of this is that you can separate the configuration part of your application from the runtime part, right? So your application is now able to read configuration values from a config map that you can create on the fly, that you can change on the fly, that you can delete on the fly while your application is running. Because Micronaut applications are refreshable. And refreshable means that there is a refresh scope that whenever there is a refresh event, and for example, if you have this integration enabled and you're watching for changes in a config map, whenever a config map changes, we will trigger the refresh event, and your beans that are marked as refreshable will refresh on the fly without needing to restart. I will show that in the demo. So in this case, we have a simple config map with a couple of values. Username and password. Well, this is sort of a secret, but works the same, right? Username and password, and we map them to those attributes via the add value annotation, right? In Spring, it's the same. It's add value. Works the same. So now that username property is going to be resolved from the config map, right? You still follow me? Yeah? OK. This has like different options that you can choose. For example, if you don't want to grant access to your application to the Kubernetes API for whatever reason, in the Kubernetes airbag model, you can mount those config maps and secrets as volumes, and we will read those files and enable them into the property sources. Another thing that the Micronaut integration will give you is health checks. So in Spring, there is the Spring actuators. In Micronaut, it's called Micronaut management endpoints. And one of the management endpoints is the health endpoint that is really is crucial when you run into production because the health endpoint will allow other elements in your architecture to determine if your application is running or not, or if it's healthy or not. And then it needs to be, for example, it needs to be phased out of a proxy or whatever, right? So the health endpoint or the health checks are composable. We can check the health of an application based on different things, right? So, like by default, there is like a disk space health check, memory health check, and I think that's it. But if you enable the magnet integration with Kubernetes, you have a Kubernetes health check specifically that will prove communication with the Kubernetes API. And if you configure so, because it's disabled by default, but you can explicitly enable for development, you can get additional information about where is your application coming from. This is like number 2, like, for example, essentially the pod where your application is running. And also, if you're also using service discovery, you can like tell which services have been discovered, which are the IPs and ports that have been discovered for those services, etc. So we'll give you like more info when you're running on Kubernetes. Another thing is the ability to easily use the Kubernetes Java client. So if your application is running on Kubernetes and needs to interact with the Kubernetes API for whatever reason, there's essentially 2 Java clients that are popular for Kubernetes. One is the Fabricate Kubernetes client, which is really good. It's maintained by Red Hat, essentially, or actually Eclipse Foundation. And we'll give you like a rich API for working with the Kubernetes API. However, the Kubernetes project itself publishes its own client, which is called the official client, right? So this is the one we integrate with, because we thought this is a safer choice to integrate with the official client. We have the guarantee that it's going to be always up to date because they auto-generate the client from the OpenAPI spec of the Kubernetes API. So it's always up to date. Whenever they release a new Kubernetes API version, immediately there is well, not immediately, but short after, there is a new version of the Kubernetes Java client available working with that API. Now, you can use using that client is not straightforward because you need to actually instantiate a couple of clients and then configure an HTTP client. So with the Magnet integration, we do that for you. You can just inject via the dependency injection mechanism of Micronaut the Kubernetes client of your choice, which will have been initialized by us. It will have been configured automatically with the kubeconfig of your choice. It is all configurable if you want to change the defaults. But if you just want to interact with the Kubernetes API of the same cluster where your application is running, like the default, like talking locally to the Kubernetes cluster, it will just work with the defaults. Nothing else is required. And the last thing is the operator support. Now, what is an operator? An operator is a component that is running inside the cluster, inside the Kubernetes cluster, and that reacts to things that happens in the cluster. Like, for example, think about, for example, you have a config map, YAML, locally, a YAML file with a config map, and you use kubectl apply -f myconfigmap.yaml. What happens there? What happens there is that, obviously, you communicate through the Kubernetes API. That is what kubectl does. It will communicate with the API. And it will create the object but the object is just the YAML with probably more info, but just about it. But then there is one component inside the Kubernetes cluster that will react to that and will say, OK, there is a new config map being created, so I need to store this into the etcd key value configuration of the cluster. Same happens with a pod. You create a pod. It's a piece of a bunch of YAML, right? Nothing else. But who is actually starting the container? There's someone doing that, right? Which is essentially pod controller, right? Pod controller is a kind of operator. So operators is like the general term. There are different building blocks to create operators. Controllers is one. And a controller will react to that and will actually start the container when you create a pod. OK? You follow me? That's an operator. So now, obviously, this is not for everybody use cases, right? So I want you to think about whether this applies to your situation or not. But at least you now know what is an operator, right? And this is typically used with custom resource definitions. So for example, if we go back to this, this piece of YAML, you see this kind secret, API version v1. This is a core core resource from Kubernetes. It's coming like by default. But the Kubernetes API can be extended with different kinds of objects. We could create our own types. And this is normally used in combination with operators, because if we introduce a new custom resource definition, we can allow users to interact with the cluster via these custom resources. Now, the building blocks that Micronaut supports for you are informers, reconcilers, and leader election mechanism. The most basic one is an informer. An informer is a component that will have three lifecycle methods on the object type that you're interested into. So imagine you want to create something that it's notified when a config map is added, when a config map is updated, and when a config map is removed or deleted, right? So you essentially, well, doing this by hand is complex, right? But with Micronaut, it's really simple, because all you have to do is create a class, add the @informer annotation. You gotta tell us which is the type, the resource kind that you're interested in watching. There are further options to, for example, to filter based on labels, if you will. And then we will do all what it takes to call your methods when any of those events will happen. OK? So this is like a really simple building block that you can use in your applications. Now, the most advanced one is a reconciler. A reconciler works differently in the way that, for example, if you think about the pod example that I told you, right? You create a pod. Or don't think on a pod, think on a deployment, right? You create a deployment and you specify the number of replicas, right? So a reconciler works to constantly ensuring that the cluster state represents the configuration, right? So basically, when you create a deployment and you say you want 2 replicas, the controller will kick in. It's like an infinite loop, right? And we'll say, OK, how many replicas do I have? I have 0, so I need to create 2, right? And then we'll kick it again. Now I have 1. Well, there is 1 left. I have 2. I'm done. But I will keep watching. I will keep running until the cluster state matches the configuration. Now, if you remove that deployment, the same process will happen. And the controller will say, OK, there shouldn't be any replica or any instance of this deployment, but I have 1, so I need to remove it, right? You follow me? Yeah? How do you do that? Again, you can use the @operator annotation, and there is a single method that you want that you need to implement. It is the reconcile method, and this is the loop method where you're gonna check what do I have in my cluster, what is the configuration, and what do I need to do to make them match. Yeah. Let me skip this part. We'll save it for later. Now, I will show you a demo. How much time? 25 minutes? That's OK? I will show you a demo. But before showing the demo, I want you to understand what are we going to see. Imagine we have a new product. So I've created a new product, which is called ABCDB, which stands for a very cool database. Because I work for Oracle do the databases, so I'm pretty sure Larry will be proud of me. This is an imaginary product, right? But imagine we are a product company that we want this product to be distributed with a Kubernetes operator, right? When you are creating a product, you could do this as well with like a bespoke project that you do for a single customer. But I think it makes more sense when you have like multiple clients that needs to install something. So you can provide them, I don't know, a jar file. So you push the jar file on Maven Central, and they will figure out how to run that, how to configure that. That wouldn't be like really user-friendly, right? So another thing you could do is to provide them a Docker image. That's one thing that many people do. Many server companies do. You put the jar file inside the Docker image, you push your Docker image to a registry, and you tell the users how to run that image. That's another thing you could do. But then people will have to, if they want to run that into Kubernetes, will have to create the deployment manifests, all the Kubernetes YAML configuration for that particular image. So it's better than just the jar file, but not ideal. So another thing you could do is to create, for example, a Helm chart, right? You create a Helm chart, and then using Helm, people can install your product. But again, not everybody likes Helm, or uses Helm, or are willing to use Helm. So you're basically leaving many users behind. So what if we, on top of those options, we allow them to use an operator to install this product, right? So this is what the demo is about. So we have this ABCDB product, which is a fake database. It does nothing. It's an empty application. But it just exists with the purpose of being managed by an operator. It's a simple Micronaut application that we want our customers to install with an operator, right? And we are providing them with a custom resource definition so that they can install this product into the cluster, right? This particular product is packaged as a native executable compiled with GraalVM into Docker image. And is able to read configuration from a config map, and is refreshable. So let's see that. This is the single endpoint, the whole code of this application. So as you can see, it doesn't have many things inside. So there is an @value annotation. And we have one property, key, which is abcdb.message. And then after that, it comes the default value. The default value is for when there is no result value from any property source, then it will use the default value that you specify here. We're using this to be able to tell when this is configured or not, right? So if nobody is providing a value for this property key, we will have this value. And then it simply has like an endpoint that will output that message, but it's going to be appended with running in or outside Kubernetes, because your application is also aware, can be aware, if you will, if it's running inside Kubernetes or not via the environment. Right? That's all. That's everything it does. So far, so good? Yeah? OK. So we could run this. If the demo gods are with me, they weren't in my previous presentation, but I'm brave. So for example, this one is using Gradle, so we can do Gradle run, and this should run. Of course, it doesn't, because I switched off Wi-Fi. Gradle run. Nice. The network being slow. You know what? I have already this as a Docker image, so we'll run the Docker image instead. So let me use this terminal I have here. So this is Docker run. Right? That's the application. I'm a cool database. That's all it does. It runs. This Docker image has the native executable inside. And if we make a curl request to this guy here, let's try that. So this is curl 8080. Oh, this is failing again. Oh. For some reason, this worked on the browser. Not working. Never mind. Let's move on. So now this is the application, right? The second thing is the operator. Now, the operator is something that is already deployed on the cluster, right? So as you can see, well, it's a bit hard to see it, but this is the cluster boundary, right? This is the cluster boundary. We have the operator. It's already deployed. It's in a different application than the previous one. I have already packaged the application as a Docker image. I deployed on the cluster. It's running. It's already waiting for what? It's waiting for a custom resource of kind ABCDB that I will show you now how it looks like. So the way this works is that a user, your client, right, to install this database on their cluster will create this object with kubectl, right? We'll do kubectl apply. Actually, we will do that, right? Then the operator has a reconcile loop, as you saw before. And we'll do this algorithm that I told you that, OK, I have one instance, one ABCDB instance that needs to be there. Do I have a deployment for it? Do I have, because what it takes for this application to run, it needs a config map, it needs a deployment, and it needs a service, right? This is the thing that the operator is going to create for my application. And this deployment will actually create the pod, and your application will read the configuration from the config map, right? So we're saving the user from creating all those things. They don't have to care about the manifest. We control them, right? So let's see if this works. Now, on the top terminal, I have a watch of the ABCDB resources that we have on the cluster. As you can see, there's none, right? So this is like every 2 seconds making a request to the cluster to see if we have anything. What else? Let me show you what the user will create. So this is like this, right? There is a new kind being used. And this is really simple, so we only have one property in the specification, that is the message. And we want our application to read from that, right? And the rest are just labels, just to match. We will use those labels for the deployment and the service. So that is the operator job. If we see the actual code of the operator, which is this guy here, this is the reconcile loop. So essentially, this will run periodically. You can configure, this periodicity. So that if there is an instance of an ABCDB object detected, then we will see what is going on with that one. It could be that that instance is trying to be deleted. Now, object deletion is a complex, well, not complex, but how many of you knows what a finalizer is in Kubernetes? Yes, only one person, OK. This is an advanced topic, so you can ask me after this presentation. But essentially, deleting, when you want to delete something in Kubernetes, is not something that happens automatically, right? So there are some techniques that one has to do to make an object to be deleted, because you have to deal with corner cases. Like, for example, in this case, we have this ABCDB object kind, which is the owner of 3 other objects, right? One is the deployment. The deployment is the owner of a pod, and so on and so on. So there is a chain of objects. And this operator needs to ensure that when an object is being deleted, because actually when you say kubectl delete -f my file, the object is not immediately deleted, but it's marked to be deleted, right? So this is the way. This is essentially what the what is it? Is being deleted method is checking, right? So if the object is marked to be deleted, then we actually delete all the 3 children. We delete the config map, we delete the service, and we delete the deployment. OK? Yes? Otherwise, we need to create those objects or update them, because it could be the case that the next iteration of this method, you get a new version of an existing object. For example, if the spec message has changed, then you will get like a new version. So this is what I told you. The operator needs to check to ensure that the cluster state matches what the user has configured, right? So it will check, OK, do I have the deployments? Do I have the config map? No, then I have to create them. For example, do I have the config map? Yes. Is the content of the config map the same as it was specified on the spec.message? Yes, no. If it's no, then I have to add the config map, blah, blah, blah. You still follow me? Yeah? There's another thing I don't think I told you. This controller is refreshable. Yeah? So in this case, I'm using field configuration injection. This is a bad practice, so don't do that. It is much better to to do this via, for example, constructor injection, right? But I wanted to do like this because we can tell exactly if this has been refreshed or not. So as you can tell, this is a private field that is going to be initialized when the bean is created, right? So how do we update the content of that message field? There's no setter or anything like that, right? So I didn't implement that. So this will happen essentially via a refresh event, right? This application is configured to watch for, well, it's having the integration with Kubernetes, so by default it will watch for config map changes. By default, we'll use the same labels as the pods, so it wouldn't watch for the whole thing, but only for those objects that matches the labels of the pod where the application is running. And then if the config map contents change, this bean will be refreshed. It will be disposed and will be recreated, and the field will be initialized with a new value. Yeah? So far, so good? So that's about it. And the actual methods implementation are using the official Kubernetes API to create the objects. So this is not really relevant. It is on GitHub if you're curious, but it's not the point I want to make, right? Now, let's go back to the terminal and see if we can create this. OK, so we don't have anything here, so let's apply. So this is key, OK, apply. I'm going to create this custom resource that I showed you before. And now you can see it was like instant, right? I think the default is every second. The reconcile loop, it can be configured. So we have a few things here. We have, this is the ABCDB object with the message, right? This is the message that I have in the YAML file, yeah? The config map, the deployment, the service, and the pod with the application. So my database has been installed. So far, so good? Yeah? Now, I think I won't be able to curl this. Oh, I can now. OK. This is great. So we have this message, hello from a CRD running in a Kubernetes cluster, which means that so the application is aware that it's running inside Kubernetes, and this is the message coming from the config map. It's not the default value. Remember that? Not the default value. So it's reading that from the config map. Now, let's refresh this. So k minus n. We are going to edit with kubectl this. I'm not going to edit the config map directly. I could do that, right? But I don't want to do that because my operator doesn't work with the config map directly. The config map is just one of the pieces that it will manage, right? What I need to edit is the custom kind, the custom resource definition, right? So let's do that. This is the live object that is deployed on Kubernetes. So you see different controllers will create some annotations and labels, sorry. My operator is actually using some annotations to tell, for example, this object has been reconciled already. It was reconciled at this time, right? So this is the control logic it uses to be able to tell, because otherwise you would be constantly, creating objects, right? And now if we go back to the spec, we're going to change this. Hello, JPrime. We're going to save this. And then we're going to call it. And we have hello, JPrime. What do we have here? Let me run it again. So this is the custom resource. It's got the new message, right? The operator kicked in when this object changed. It knew that the object was already reconciled, so then it went to check the state of the 3 objects it's going to manage. And when it checked the state of the config map, it realized that it needed to change the content of the config map. It changed the content of the config map, and then the Micronaut application, this fake database, reacted to that and refreshed only that bin while the application was running. So you can see there's 0 restarts. There's no application restart. It's only refreshing that particular bin. So we have some time for questions. Before we get that, I have a QR code with a simple survey. There's only one question with rating 1 to 5, and then an open-ended field. I would really appreciate if you could give me some feedback about this presentation. It will help me to improve future editions. And then, does anyone have any question for me? There's one there.
Actually, just have one question. So, do you think that what you did in the demo now that can be the same achieved by using influencer instead of the reconciler? Because the config map can react.
By using what?
So the same thing we did in the demo.
Yes.
But instead of reconciler, because we used that.
With an informer.
Yes. Oh, informer. Yeah.
Informer. Yes. I think potentially yes, but an informer is meant to be different because an informer it will never check that an informer is more like, for example, imagine that when you do like that change, you want to send an email, right? That doesn't have to do with the cluster state. Then you do that with an informer. You use that callback method to send a notification, whatever you have to do. But it doesn't have to deal with the cluster state. If it has to do with the cluster state, I think it's more correct to use a reconciler. Yeah, a pleasure. Any other question? No? OK. Thanks again. You've been a fantastic audience. I hope you enjoyed this conference, and see you over here.
Okie dokie. So, 2 more talks to go. And then you can go home and then you can go to work, finally go to work. Yes, and now actually I'm so much excited that, well, you actually have seen this wonderful lady already in another hall. But since I'm the host of this hall, I'm really happy to see Grace. Yes, Grace Janssen, but not only just because Grace Janssen, because she's going to talk about something like really hard to read. Effective observability for the cloud native application. Oh my God, what is this? I mean, it's complicated. And that's why the most complicated talks are always at the end. But Grace can do amazing, and she will talk to you about this complicated stuff in a very easy way. She's just amazing. Please welcome.
Very much. No pressure on my talk then. Thank you so much for having me. It's lovely to be here in Hall A. Thank you to everyone who came to my previous talk and has come to this one. Nice to see friendly faces again. So yeah, my name is Grace Janssen. If you can't tell from my accent, I'm not from Bulgaria. I'm afraid I speak no Bulgarian, and I'm from England. So I work at IBM over in our developer lab over there. I'm a developer advocate. Before I was a developer advocate, I did a biology degree. So an obvious transition from fish to Java. So if you fancy chatting about that later, happy to chat about that. But now I do lots of different things around I make tutorials, demos, I do presenting like this in my developer advocacy role around cloud native technologies, Java, and Open Liberty. So today I'm going to be taking a look at through the looking glass effective observability for cloud-native applications. So really digging into how we can effectively utilize tools to be able to understand how our applications are behaving in real time in the wild. So why this name, through the looking glass? So some of you guys might be familiar with this phrase. It originally comes from the book Alice Through the Looking Glass, which is the follow-on to Alice in Wonderland, which many of you might have read the book or seen the movie. But it was essentially a phrase that was coined by the author Lewis Carroll. And really, it's a way of expressing, passing through something. So it's a metaphor for a world that seems unfamiliar that suddenly appears. In the book, Alice steps through a mirror to be able to enter back into Wonderland. And this kind of theme and this metaphor isn't only used in Alice in Wonderland, it's also used in some other media as well. So if you're not familiar with this film, you might be familiar with this film. Anyone know it? Yeah, I got a few nods. The Matrix. So actually, it's really interesting. In The Matrix, there are lots of references to Alice in Wonderland. So for those of you who are Matrix fans, you're probably already aware. But if we think about it, right to the beginning of the movie, Neo gets woken up by his computer, sending him a direct message instructing him to follow the white rabbit. And obviously, the lady has a white rabbit tattoo. There's one reference. Another one is when he's offered the red or the blue pill, the guy who offers it to him basically says, if you take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. If you take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. So this is sort of a metaphor that's used time and time again in different media to really express this whole being able to see with new eyes, being able to see a world that you weren't able to understand before. And this is the kind of thing we're trying to achieve when it comes to enabling observability into our cloud-native applications. Whereas previously, it might have been a bit easier for us to understand how our applications were behaving when we were running on local servers, when we could access that application all the time, when it wasn't distributed. When it comes to distributed cloud-native applications running on remote servers, this can be a little bit more difficult. So really, the question I'm asking here is, OK, what looking glass do we need to be using? So in this presentation today, I'm going to be covering these main topics. So the why, the what, the how, and then diving into some of the technologies that can enable this that are open source. So I'm afraid there are no excuses, because this is free, and you should be able to use it. So yeah, taking a look at that, obviously got a demo, because we're developers, and we like to see how it works, and then just some summary and resources. So hopefully that gives you a clearer idea of sort of how we're going to structure this session today. OK, so starting with the why. Why do we need observability in the first place? why are you sat in this room? So if we take a look at sort of how we've arrived at where we are today, evolution of both our infrastructure and our applications has played a key role in this. In terms of our infrastructure, we've moved from sort of what used to be using things like single core. We can now take advantage of multi-threading, multiple cores, utilizing virtualization, containerization, having this inherent distributed nature in the cloud to be able to get sort of immediate response from our apps. But all of this has sort of our underlying infrastructure has evolved to be able to utilize these technologies and tools. And as a result, our applications have also evolved alongside our infrastructure. So what used to be a often very large monolithic application often is now broken down into remote microservices or even macroservices or serverless, depending on how you're architecturing your application. But really, now, the key part here is that this is kind of becoming a bit more complex, both for infrastructure and for our applications. So why do we do it? Why do we move to the cloud if it's harder and it's more complex? And I think the answer is in this. Okay, hopefully you've seen Toy Story. I had a few giggles. If you've not, go and watch that movie. It's amazing. So it's this excitement we get as developers, this, ooh, the cloud. We get excited as developers because it offers us innovations and behaviors that we weren't able to achieve before. Flexibility, portability, dynamic scaling, for example, resiliency. All of these behaviors are enabled through this innovation in the infrastructure and our applications. So it's the reason that we want to move our applications to the cloud and that we put up with all of this complexity and have to deal with it. However, it doesn't always feel like this when we're actually moving our applications to the cloud. It can often feel a bit more like this. It's just a bit frustrating. It doesn't work half the time. You can't see what's going on in your applications. Trying to actually understand what's happening in real time to your real app for real customers can be quite hard. And so that's why we're here in this talk. That's the why, because we want to move to the cloud and we want to do it effectively and not get this feeling. So to do that, often we look towards sort of methodologies to be able to guide us in terms of, OK, how do we effectively develop for the cloud? And one popular methodology that I quite like is the 15-factor app methodology. Some of you guys might have come across the 12-factor application methodology. This is just an extension of it to expand it to 15 factors. And I've made your job super easy because I've highlighted the new factors. So it should be super easy to see them. We've added API first, authentication and authorization, and importantly here, telemetry. If you are interested to find out more about the factors that I'm not mentioning here, so everything other than telemetry, I've got an article at the bottom here, which is 15 factors, and it takes you through the additional factors that are in there if you want to learn more. But importantly here is this addition of telemetry that I want to focus on in terms of it's now recognized as an important critical step towards building effective cloud-native apps. You might look at this list and say, yeah, but we already had logs. Like, why do I need telemetry? And while logs were a really great starting point, especially for sort of local development and understanding how our apps are behaving as we develop, they're not necessarily great insight into how our applications behave in the wild. It doesn't give us insight into, do we have enough resource allocation? What's the load like on our system? Are our microservices healthy or not? So gaining this additional telemetry data can really help in understanding not just our apps as we develop them, but our apps when we throw them into the wild and see how they behave. So this is, it's really emphasizing the importance here that it's been added to this methodology. And there are many other organizations that highlight its importance as well. This is from a website from Splunk. Splunk is, they offer an observability platform, so they're kind of experts within this area. They also helped to form and create OpenTelemetry, which we'll cover later. But you can see here that they clearly point out key sort of reasons of why it's important as well. Things like improving performance, centralizing your data, so having that central point of truth that you can understand what's going on in your application, being able to integrate with that data easily, and being able to troubleshoot faster. And all of these factors come back to those original reasons we want to do cloud native. Resiliency, speed, dynamic scaling, being able to actually achieve those utilizing observability. So that's kind of my why, hopefully, you guys are in the room. So hopefully I've covered all your reasons and some more. So we're onto the what now. Now that we know that we need effective observability, what do I actually mean by this? Because it's a term that can be used for, I would say, multiple different things, so I'm trying to make it clear as to what I mean by this term. So I've got a general understanding here, a general definition. So generally, observability is the extent to which you can understand the internal state or condition of a complex system based on your knowledge of external outputs. So it's all about turning whatever's transmitted out of that system into valuable insights to understand what's going in that system, what's going on inside. The more observable a system, the more quickly and accurately we can then navigate to an identified problem, solve it, and understand its root cause so without needing to do additional testing or coding, etc. This term observability actually comes from control theory. This is an area of engineering concerned with automating the control of a dynamic system. So if you think, for example, of the flow of water through a pipe, or the speed of an automobile over inclines or declines, this is all based on feedback from a system. So this is kind of where this term comes from. So that's the general definition. But we're in tech. We like to be specific. We like to know how it relates to us. So how does it relate to us? This is a more sort of specific definition where we're really referring to software tools and practices, looking at aggregating and correlating and analyzing a steady stream of performance data from a distributed application. And that includes the hardware and the network that it's running on, as well as our application and microservices themselves, and being able to monitor, troubleshoot, and debug that. So getting a bit more specific here in terms of relating it to our jobs and to what we do as software developers. So this is what I mean by observability in terms of the term we're going to be using throughout this presentation. Now, some of you might think, OK, so this is all about understanding the internal state of a system. It's all about understanding, the performance metrics we're getting. How does that differ from monitoring? Because I've got monitoring tools, for example, already in my application. So I would say that monitoring and observability are two separate terms, but one can help the other. So monitoring, I would say, is it's all about using tools and techniques to highlight that an issue has occurred. It could raise a warning, for example, if your average response time gets too slow, or you've got a growing number of requests coming into a particular microservice, or maybe literally that your application has crashed. However, what I say with observability is that that's the ability to measure the internal state of a system by examining its outputs. So when you make an application observable, it provides detailed visibility into its behavior and allows you to identify the root cause. So observability and monitoring are different. Observability doesn't replace monitoring, it just enables better monitoring and better sort of application performance monitoring and network performance monitoring. So it's really it's more of a broader catch-all term that can include monitoring and help to make that more effective. So monitoring tools could be included in your observability sort of plan for your application or strategy. So hopefully I provided a bit of a sort of distinction between those two terms there and how they correlate and sort of intertwine together. OK, so that's the what. Now we're on to the how, because that's what we all want to know here, is how do we actually go about achieving this? So there are generally 3 steps in terms of actually implementing observability. When it comes to implementing it, it's actually fairly simple in terms of the concept itself. To enable observability, you need to firstly instrument your systems and applications to collect the relevant data. If we've got no data, there ain't no point. So we need to be building that into our application so that we can actually do something with that data. So that's the first step, instrumentation. Second step, we need to be able to send this data to a separate external system that can then store and analyze it. It's all well and good getting data out of your system. If you're not doing anything with it, again, there's not really much point. And the third part is providing visualizations and insights into systems as a whole. So utilizing that stored data and that analysis to be able to actually visualize what's going on in our system. Because we could be the cleverest people in the room, we could be super into numbers, but reading a graph is a lot easier and a lot simpler to be able to understand trends and issues within your systems rather than just looking at a database of numbers. So that's a really key step, is providing that visualization and understanding of that insight so you can actually do something about it. So we're going to be focusing mostly on the first step in this presentation. I do have a couple of slides on step 2 and 3, but we're mostly focusing on step 1. So how do we instrument that data? And then we'll look at how we can sort of plug into other tools that can enable 2 and 3. OK, so for step one, how do we make a system observable? Well, it's all about instrumentation. And what do we mean by this? It's mostly about these three key pillars. What often is referred to as the pillars of observability, hence my lovely Greek temple, I guess you'd call it. So the three key pillars are logs, metrics, and distributed traces. So really, our code should be emitting all of these. And I say there's three pillars. There is hopes that eventually these pillars will expand. So there's already discussions going on at the moment into 2 more additional pillars in observability that may be added to projects like OpenTelemetry. That includes things like end-user monitoring and profiling. So end-user monitoring is really about gaining real-time visibility into how our users are experiencing our application. So it can be video recordings of them using our application, tracking how their path moves through our application, for example. So understanding end-user experience. And then profiling offers us a way to understand sort of where our code spends its time on which hardware resources, primarily things like memory and CPU, right down to the individual line number, so understanding which lines in our code take up the most time and take up the most resources. So it's hoped that eventually these will be included and sort of incorporated into that. But at the moment, it's mostly the 3 core pillars that are focused on. So that's what we're going to focus on today and how we can go about achieving that. So the first is logs, which many of you are probably already using. It was mentioned in the 15 factor as a separate factor. And this is really, they're found almost everywhere in software and have been heavily relied upon by developers and operators to really understand system behavior. Unfortunately, the sort of downfall of logs is that they aren't extremely useful when it comes to tracking code execution. They typically lack contextual information, such as where they were called from, for example. And so they become far more useful when they're actually used within something that can provide that contextual information. In this case, when they're used within traces. So they are really helpful in terms of understanding specific information, like an error or a warning. Typically, you'll be storing them in log files. But the awkward part is that we don't really know what caused them. So that's why this isn't the single sole source of observability. This is why it just integrates in. You can use, obviously, different logging tools. Most runtimes will have logging inbuilt that you can make use of, so it should be fairly easy to be able to implement this. I won't go into that in too much detail, because you're probably already doing it. OK, metrics. This was the other one. Metrics are much more malleable to sort of mathematical and probabilistic and statistical transformations. So being able to sample, being able to aggregate, summarize, and find correlation across those metrics. So they're a lot more useful when it comes to understanding the behavior of an application over time, not just like a log in a particular moment in time. So it really gives us that insight over time as to how our application is behaving. It can include things like, for example, system error rates, CPU utilization, request rates. Really, there's a whole plethora of different metrics that you can create and collect for your application. Metrics are also better suited to things like trigger alerts, like running queries against an in-memory or time series database is far more efficient, not to mention more reliable. The only thing is that this doesn't cover all, which we'll get onto in a minute. The way that you can implement metrics, a really great tool that you can utilize is MicroProfile. Who's come across MicroProfile in the room? Hands? I'm going to see if you're awake here. Seriously, no hands? Yeah, I get a wave. Thank you. Oh my goodness, there's hardly anyone else. I'm going to look this way. No? OK, so I'm glad I got an intro slide. Welcome to MicroProfile. This is a community-driven specification, which is really designed to help anyone using Java or Jakarta EE applications, building those applications, to make them effective for the cloud. So it offers all of these sort of add-on APIs and specifications, I guess, to your application. We kind of categorize them into these 3 categories. So we've got at the bottom here, we've got the core APIs. Then we've got the APIs that are to do with sort of integration. And then on top, we've got the observability APIs. A lot of these APIs are actually shared in common, especially the core ones, with Jakarta EE. So you might see some commonalities there, some shared APIs, like, for example, JAX-RS, JSON-B, JSON-P. They are shared with Jakarta EE. So the 2 communities work quite closely together. And a lot of the committers are committers to the other project as well. Emily Zhang, a colleague of mine, she did a talk earlier today. yesterday, time has flown by, yesterday on MicroProfile. So if you do want to go into more detail, check out that recording. Or otherwise, we've got lots of resources, and you can go to microprofile.io, which shows you all about it. The key part here is that this is a specification. So you will need an implementation to actually make use of it. And there are lots of different implementations out there. So this is a list of some of the compatible implementations you can use. And this is the nice thing about using MicroProfile, is that it's not locked in to one vendor. There are lots of different vendors who support it and who implement it. And that means that if you need to change your runtime at any point, you can just switch over to another compatible implementation. So you could switch from Quarkus to Payara to Liberty to whatever you want to use. So it's quite nice having that sort of flexibility that we talked about that we want from cloud-native applications. One of the APIs that MicroProfile offers is metrics. This specification was designed to be able to provide a unified way for different MicroProfile servers to export the monitoring data that we want to be able to access to different management agents and also to the Java API. So this is basically how we can make use of metrics. And it's nice because by default, MicroProfile metrics can be used in a Prometheus format, for example, to be able to use it with things like the Prometheus monitoring tool as well. So this is metrics. It can provide us with a greater insight into data over time, basically how our application is behaving over a period of time. However, it doesn't give us insight into how our microservices are integrating together. So if we have a request that goes through multiple microservices, how do we know where the root cause is if it were to go wrong at any point? How do we know that our application microservices are working well together in this distributed environment? And this is where traces can be really helpful, specifically in this case, distributed traces, because we have a distributed environment. So distributed traces is a monitoring technique that really links the operations and requests that occur between multiple services. So it allows us to be able to trace, hence the name, the path of an end-to-end request as it moves from one service to the other, letting us pinpoint errors to a particular bottleneck in individual services, for example, that might be negatively affecting the overall system. So really understanding where in our system things are going wrong in what is a very interconnected and interdependent system. Without tracing, it can be really difficult to actually pinpoint the cause of performance problems in a distributed system. So it really helps us to be able to improve the visibility of our application health and enables us to debug effectively. Now, when it comes to tracing, there are some key concepts that you need to be aware of and be able to understand how you can actually implement it in your system. So I'm just going to cover some of those key concepts now. One is, what is a trace? I kind of just explained that one. A trace just represents multiple requests, and it consists of multiple spans. This is what I mean by there's a lot of terminology. Spans are representative of single operations within a request. So a span usually contains things like a name, a time-related data, log messages, and metadata to be able to give us insight into what's occurring within that transaction. So you can see in my diagram here, the individual spans are shown in like reddy pink, and then we've got the trace that goes over multiple spans right at the bottom in orange here. So that gives us more information about that. So this gives us an insight into how this is going across multiple microservices. Then we have on top of this context, and this is where traces really come into their element in providing this context. Context is an immutable object that is contained within the span, so within that span data. And it's essentially, it allows us to identify the unique request that essentially each span is a part of. So this data is required to be able to move trace information across service boundaries. So normally it consists of two parts. You've got the trace ID and you've got the parent ID. The trace ID allows us to understand, okay, these three spans are all part of the same trace. They all happen with the same request. The parent ID allows us to understand, okay, where did this request originate from? What was the microservice before this? So that we can understand where it went wrong and why, which particular microservice is the bottleneck. So this context is really what allows us to be able to gain insight into where in our distributed system things are going wrong. So really gaining visibility and observability at a very low level. So this sort of context is very important. So those are the key parts behind distributed traces. So we've got logs, metrics, and distributed traces. Now that we know what they are, why they're important, why we need them, how do we actually enable them? And this is where projects like OpenTelemetry can be really helpful. Has anyone come across OpenTelemetry before? A few hands, couple hands, awesome. Okay, there's a couple of people. Bear with me if you've come across it. I'm just going to give a general intro just to give everyone else up to speed, and then we'll go into the deep dive of how we use it. So in the past, in the way in which code was instrumented would really vary because each observability backend would require you to have, it has its own implementation libraries and agents for emitting data to the tools. It basically meant there was no standardized data format for sending data to an observability backend. As well as this, if a company chose to switch observability backends, it meant they had to re-instrument all of their code and configure new agents just to be able to emit telemetry data. So it was a lot of hassle, a lot of work, a lot of effort. So there was work done to be able to essentially make a standard so that we didn't have these issues going forward. And this is where OpenTelemetry came in. It was really built around this smart idea of, every Java project uses a lot of standards and open source components, things like JDBC, servlets, you might be using Apache Tomcat, Hibernate, whatever it is. What if we could manipulate the bytecode of such libraries to be able to inject telemetry data? So this is kind of where this originates. The important part here is to consider that this project is designed to be a standard. It's a collection of different tools, APIs, and SDKs to be able to allow you to instrument, generate, collect, and export that telemetry data. Now, one note here is that OpenTelemetry is not a complete observability backend. So you will still need to plug it in to backends like, for example, Jaeger or Prometheus. It doesn't replace those tools. What it allows us to do is to be able to have this pluggable architecture that enables you to add different technology formats and protocols, et cetera, and they're all supported in the open source. And you can use metrics formats like Prometheus, for example, like we did before. So it's a really handy way of having that single standard. It originated from other standards that we had. So previously, we had things like open census and open tracing. Anyone come across those? Less people. Cool. Well, good, because they're not supported anymore, so don't go near them. Stick with OpenTelemetry, please. This is essentially, open tracing was provided. It provided a vendor-neutral API for sending telemetry data to a backend, but the awkward part was it relied on developers to implement their own libraries to meet the specification. Whereas Open Census provided a set of language-specific libraries that developers could use to instrument their code and send it to any one of their supported backends. The issue with this is that that's still not one single standard. That was the issue. We still had multiple standards. It really wasn't very helpful because people were using different standards. So now all of this effort was put in place to be able to create this one single standard, which is now OpenTelemetry. This was merged in 2019. It's a CNCF incubating project, and it really was designed to take the best of both worlds from these projects. So please stick with OpenTelemetry. Don't start a new project with Open Census or Open Tracing. Stick with OpenTelemetry. The way that it works is a little bit like this. So this is kind of the architecture behind how OpenTelemetry works as a system. We love acronyms in tech, so I do try and explain every acronym. Here we have OTLP. This is short for the Open Telemetry Protocol, and this is a specification that basically describes the encoding, the transport, and the delivery mechanism of that telemetry data between different telemetry sources. That can be like intermediate nodes, for example, like collectors and telemetry backends. In the middle here is where we have the OTel collector. This is a vendor-agnostic implementation on how to receive, process, and export that telemetry data. It's usually a single binary that can be deployed as an agent or a gateway. Now, the nice thing is that this can implement with lots of different backend and sort of collecting data systems. So if we take a closer look into that OTel collector, the architecture looks a little bit like this. So as I said, it's a vendor-agnostic implementation of how we receive, process, and export that telemetry data. Basically, what it does is it removes the need to run and operate and maintain multiple agents and collectors. It gives us that one standard like I was talking about. It helps us with improved scalability, and it supports the open source observability data formats like Jaeger, Prometheus, FluentBit, whatever it is you might be using. And it allows us to be able to send to one or more open source or commercial backends. It's basically the default location to which instrumentation libraries export their telemetry data. It looks a little bit funny on the board. Can you guys see the background, or does it all just look like words on a white background? Words on a white background. OK, I apologize for that. My screen looks very different. So I can see boxes around these words with arrows. So I'll upload my slides afterwards, and hopefully you can see it a little bit clearer then. But essentially, what we have here is we have our different sort of sources. So these are the receivers, and that's how we get data into the OpenTelemetry collector. Generally, a receiver accepts data in a specified format. It then translates it into the collector's internal format and passes it to the processors and exporters defined in the application pipeline. So you can see here that we've got the receivers, you've got the label on the left-hand side, and the exporters on the right-hand side. And again, we can use lots of different formats. We can use OTLP, but we can also use Jaeger and Prometheus as well. You might be wondering, under what circumstances would you use a collector to send data as opposed to having just each service send data directly to the backend? For trying out and getting started with OpenTelemetry, sending your data directly to a backend is a great way to get value quickly. Don't get me wrong, like it's a valid method. However, in development or small-scale environment, you can get decent results without a collector. But in general, we recommend using a collector alongside your service because it allows you to offload data quickly, and the collector can take care of handling additional retries, batching, encryption, or even sensitive data filtering. So it basically takes care of all of that admin for you and allows you to have that single sort of source in which you're collecting. So we would recommend, if you are using this in enterprise, try and implement the collector. That would be our recommendation. OK, so that's OpenTelemetry. Again, this has kind of all been quite high level, though. Like, it's all been sort of theoretical. This is just a specification. How do we make use of it? Well, we can use implementations. So here we have microprofile telemetry. So this is another one of the APIs that you can make use of from the microprofile specification. This is a really new addition to the microprofile spec. It only came in the most recent version of microprofile, which was only released earlier this year. So it was introduced in microprofile 6, and it adopts OpenTelemetry tracing. One thing to note here is that OpenTelemetry enables logs, metrics, and distributed traces. At the moment, microprofile is only implementing the tracing part of that, not the logs and the metrics, because they already have microprofile metrics as a separate API, and there's work being done to try and sort of collaborate between the two open source communities to be able to enable that, but it's not yet happened. So it is just focused on tracing for just now. It offers a set of APIs and SDKs and tooling, like I mentioned, and it is specifically designed for the creation and management of that telemetry data, in this case, specifically traces. And you can see it added there in my diagram. This is the only new API that was added in microprofile 6. There are different ways that you can instrument microprofile telemetry. You can have either automatic, manual, or agent instrumentation. So for automatic, if you're already using things like Jakarta RESTful Web Services or microprofile REST client, then it's automatically enlisted in distributed tracing. So you can kind of already automatically enable it through that already. We've also got manual instrumentation. So for that, it can be added via annotations, so things like with span, or via CDI injection, so with @inject, for example, either tracer or span, depending on what you're injecting. And we can use programmatic lookup as well. With agent instrumentation, you can use OpenTelemetry Java instrumentation project to gather the telemetry data without any code modification. Now, in my demo today, I'm going to be showcasing the first and the second implementation. So that's automatic and manual. I'm not going to be going over the agent instrumentation. That is a further step just because of time. So if you do want to check it out, please go and check it out from the links that I provide later. The way that it works is a little bit like this. So here we're showing two services that both have applications running on OpenLiberty, and we're utilizing microprofile telemetry, and we've got that installed. So the requests and the responses generate spans, and the path between the services are monitored using their context. Like I explained with those traces, the context is the key part there. The spans are then exported to a dedicated backend service. So in this case, we're utilizing any of these, whether it's Jaeger, Zipkin, etc. And that leads me on to the second step that we had earlier. So now that we've done the instrumentation, we need to make sure that we're exporting, and I'll showcase exporting in the demo. So we can export data that microprofile collects to Jaeger or Zipkin. Really, the choice is yours. OpenTelemetry also provides a very simple logging exporter, so you can check whether spans are created by viewing that data in your console. This can be quite helpful for debugging. But as I said, I'm not going into this too much because these tools already exist. And then visualization, again, this is important to understand the insights we're gaining from this data. There are loads of different visualization tools you can use. For example, Grafana, you might be using Kibana, for example, or Prometheus, although it's not really intended as a dashboarding solution, but you might be making use of that to visualize. We've got some blogs here. So for example, a friend of mine, Sebastian Daschner, he's created this blog on how to utilize OpenLiberty with telemetry data for Prometheus and Grafana. So check that out if you're interested. It looks a little bit like this. So when we're collecting data, it is important that we're able to visualize it in useful formats. So depending on what you're collecting will depend on what tool you want to actually utilize. We've got the Liberty Grafana dashboard here. There's also Prometheus, which we're showing some metrics at the top there. And then we've also got Kibana on your right-hand side here. So just to give you an idea of the fact that you might want to use a different tool depending on the data you're collecting and what you're trying to visualize. OK, demo time, because we all love a demo. So for this demo, I'm using OpenLiberty. Anyone heard of OpenLiberty? I'm not going to count you because you're my friend. Anyone else? Yes, a good hand. Thank you for waving. Lovely to meet you. If you've not, oh, hand over there. Thank you. All the way. So OpenLiberty it's on my T-shirt, wearing proudly. It is an open source cloud native runtime. So I'm going to ask a different question. Who's come across WebSphere? Still no hands? I mean, yeah, same people. Yep. Few more hands over here. OK. So WebSphere was sort of the legacy application server that was developed by IBM. In 2014, they kind of realized that it was a bit clunky, a bit big, a bit bulky, a bit difficult for developers to use. So we created Liberty, which is a really modular, cloud-native runtime that enables you to be able to pick and choose the APIs that you need so that you can make your memory and throughput more efficient. In 2017, that was then open-sourced to OpenLiberty. And that's the product I'm essentially talking about here. So the whole point was it really focuses on code. It enables us to make really fast and iterative changes using things like dev mode. So has anyone heard of Quarkus hot reload? No, says the guy talking on Quarkus. If you've heard of Quarkus hot reload, it's a really similar function. Dev mode allows us to be able to essentially automatically pick up changes that occur in our code and automatically sort of redeploy those classes so we don't have to tear down our whole application and get it started again. So we can see those changes iteratively. Ready for containers and enables things like true to production testing. So it's a really cool tool. Check it out. Follow us on social media if you want, because I run it and I'll say hi. So please do. And these are some of the things, if you want to take a closer look at this is some of the things we offer as sort of integrations with OpenLiberty. But for this demo today, we're going to be using OpenLiberty with microprofile telemetry. This is open source, so if you do want to check it out, it's all on GitHub. Go and check it out on there. We're also developing a guide at the moment, so that should hopefully be released imminently, because it's finished. It's just waiting review, as most things in code. So yeah, hopefully that's coming out soon, and it will enable you to be able to try this out for yourself in our cloud-hosted environment. So I'll show you that later on. But essentially, here is the demo. So we're using Visual Studio Code for this, and we're essentially using Jaeger and Zipkin. If you want to use Zipkin, you can, but in this demo, we're using Jaeger. So to do that, we've got to get the backend started first. So we're using the Jaeger getting started instructions for that, but you can use the Zipkin quick start if you really want to use that instead. So here, we're just cloning the repo that we have. Again, as I said, it's open source, so feel free to go and have a look at it yourself. But essentially, we're just cloning this down, and then we're going to cd into the directory. Cool. Perfect. We're just going to open up in Visual Studio Code. So what you'll see here is we're actually using the same system here, the same application that we have in each of our guides. So it's a really basic application because it's not designed to represent a full enterprise system. It's deliberately simple so that you don't have to worry about understanding everything that's going on in this code. You can just focus on learning the technology that you're learning. So in this, we have two microservices, system and inventory. The system microservice just scrapes data every 15 minutes on your system. The inventory microservice then receives data from the system microservice and has a list of all your systems and all of that most recent data that's been sent. We can then access that inventory list through a REST endpoint. So pretty simple, just 2 microservices, but it gives you an idea of sort of communication between the two and how we can enable different tools. Oh, I've restarted, sorry. Let's skip. OK. So as I said, I'm just going to be showcasing the manual and the automatic instrumentation today. So this is for the manual. Oh, did my mic just go? OK. Oh. Sorry. I feel like I just woke everyone up there. I apologize for that. I was so ready to shout. OK, so what we're doing here, I'm going to pause this just to catch up with where I was there. So essentially, what we're doing here is really enabling. The first thing we need to do is make sure that we've got the prerequisites in place that are required for this. So third-party APIs have to be made visible to our app in the server.xml. And the OTel API and OTel instrumentation annotations need to be provided as dependencies in our build path. So in this case, we've got them in the pom.xml. So let's keep going. Oh, it's a video, so I don't know if I can. I'm trying to figure. How's this? Better? Better? Perfect. Thank you. All right. Now can I play? Yes, perfect. OK. So that was in our server.xml. We were just adding those dependencies in. And here is the dependency that I was mentioning, that microprofile API and instrumentation annotations that I need to add into my pom.xml. So if we head into the pom.xml here, you can see several of our dependencies here, for example, and we're just going to add them in to this section. We've got 2 dependencies there that we're using. So now that we've added those in, we've got our prerequisites, we're now ready to be able to instrument our code manually to create traces. So we're going to head into our inventory resource class, where we're going to inject a tracer and a span object, which will be used to create the spans. So we're going to head into that class now, so into Java, and then into inventory resource.java class. And in that, yep, we're in there. Perfect. So we're just going to inject our tracer and span, like I was mentioning. In this case, we're creating a span called getting properties, which adds an event before the system service is called. We're just basically uncommenting the code there because we already had it in there. We can also create new spans by annotating in any Jakarta CDI beans using the with span annotation as well. So in this, this is the getting properties. So here we are, we're just uncommenting that. And save. So you can see we're using annotations. If you're familiar with microprofile, it pretty much all works with annotations. So the next thing we're going to do is utilize that annotating method with any Jakarta CDI bean that I mentioned. We can use the annotation with span for this. So that's what we've got in our code here, that with span. At the moment, we're not really doing much with it. We've just got a void. But we're just going to add that in for the time being. In this case, we're creating another span, and we're giving it the name list. So let's just add that in. Again, we've already got it in there, so we're just uncommenting for the time being, just because we had it in our original repository. So this is the public void. Yeah, we've got the @span attribute that we're making use of, that other annotation. Cool. So we'll first check again that we can successfully access the endpoint to be able to ensure our microservice is actually working. So here we've got a second one. This is the one with list. So add that in. I'm a little bit ahead, sorry. Cool. So adding in that list annotation. And now that we've got that, we can now make sure that it's all working. So the first thing we need to do is make sure that we've got our application up and running so that we can actually access that endpoint. So we're just going to use the terminal here. We could use dev mode, but for this, we're just literally doing a Maven run just to make it simple. So here we're just doing Maven Liberty run. Get that up and running. You should see the Liberty message, which basically says it's ready for a smarter world, which shows that it's up and running and ready to go. Now we're just going to CD into the inventory. And again, we're going to get that up and running as well, because we need both up and running for this particular part. Cool, and now we're going to go back to the local host and check that we can still access that to ensure that our microservice is still up and running. So you can see, yep, we can still access that, and we can still we're utilizing the Jaeger UI here to be able to sort of see the different endpoints and sort of the different metrics that we're collecting. So going back to the Jaeger UI, again, you can use Zipkin if you really want to. We're just using Jaeger in this instance. Just head to that local URL, get that up and running. Hopefully, yeah, I think it's all within this corner So let me know if anything goes off screen. We're going to go to the inventory, and then here we go. What you can see is we've created a span there with some traces that you can see in the bottom here, and we've done that using the manual implementation. And then we can get more information on it just by sort of heading into that UI to find out more information. I've realized that as I was doing this demo, I switched between 2 demos, so I apologize for that. This was the manual implementation. You can also have the automatic implementation as well, which was the previous demo that I skipped. But in the interest of time, I'm just going to keep going. So if you do want to try it yourself, then do visit the GitHub URL that I mentioned, which takes you to the GitHub repo where you can follow the steps. We've got instructions. If you want to find out about our guides, follow us on social media. We post whenever we produce new guides, so that guide will be coming out soon. OK, so despite the hiccup with the demo, which I apologize for, hopefully what I've shown you is that we're entering this world of increased complexity, and that because we're becoming more complex, both our infrastructure and our architecture and our applications, it is really critical for us to have effective observability to be able to monitor and understand how our applications are behaving and performing in this complex environment. And the nice thing is that you're not alone in this. We're not expecting you to create your own implementations. There are lots of open source tools available to be able to help you with this. So take a look at things like the standards like OpenTelemetry and like the implementations like microprofile telemetry to be able to make use of this in your own applications. As if I haven't given you enough links already, there are more links, because we love to research and do homework. So if you did want to find out more, these are some useful links to be able to follow. A recap of what observability really means. We've got a blog there, around an article around how to use OpenTelemetry with microprofile, and then one at the bottom there for tracing with microprofile using OpenLiberty, which takes you through the steps that I was doing wrong, in that demo. As I mentioned, we've got some guides. These are some observability guides we already have. So if you're interested in utilizing things like Zipkin, Prometheus, Jaeger, whatever it might be, we've already got guides up there that you can follow if you really want to have a go. And as I said, OpenTelemetry is coming soon. The nice thing is that you don't necessarily have to do them on your local machine. So if you've got a restricted machine, for example, and it's difficult for you to try out new technologies, then you can use our IDE in our browser. So we've basically got a cloud-hosted environment that you can try this all out in. It's based loosely on Thea, and it provides all the instructions, the terminal, and the IDE within one environment. So all you need is a browser, which hopefully everyone has on their machines. As I said, please do connect with us to find out about when these guides are coming out, to give us your feedback, your comments. I promise I'll say hi if you say hi. I'd love to have more people to talk to on social media. So do follow us if you have a chance. And with that, I'm going to say thanks very much. I'm sorry the demo didn't work to plan, but hopefully it was helpful, and I'll be around for the rest of the day. I appreciate you guys staying with me throughout that whole presentation and staying till the end of the second day. I know it's been a long couple of days, a lot of learning, so thank you very much. I appreciate it. Thanks.
Нет, у меня нет, но если у тебя свой есть. Ну, ты тогда так, да. Имеется в виду, что мы кликеры не даваем. Ну, в целом, обычно у нас типа со своим оборудованием приезжает народ, да. Если тебе нужен кликер, можешь такого попросить. Ты уверен? Ну, в смысле, чуть раньше бы сказал, мы все нашли, без проблем. Ты привык к другим стандартам. У нас Европа. В Европе тебе никто кликеры не даст, да. Просто привыкай, да.
Okay. Yes, people are still coming. This is okay. This is nice. And we are going to make our last session in this hall for today. I said not last. The last session is going to be ours for closing. Yes, but last session, which has something reasonable to tell you. And, well, really happy to see that this session has so many interesting words like E2E, CI, Spring Boot, of course. Yes, without Spring Boot, it won't go. And, of course, test containers. So I think it's going to be really awesome. So please welcome Simeon. Now, the stage is yours. Thank you.
So, добрый вечер, Bulgaria, Sofia. Like Mitya said, I have collected all feature words in my title, so I expected a lot of people to come and see my talk. You know, it's also an additional responsibility when your talk is closing the conference, and I hope you like what I'm going to tell you right now. So the topic is E2E testing in CI environment with test containers usage. And first, a few words about myself. My name is Semyon. I am Java developer and Java team lead at MTS Digital of Big Data department. For those of you who don't know, MTS is one of the biggest telecommunication company in Russia. And also, I write technical articles on Dev2. You can go to this link after my talk and see what I write here, mostly about Spring Boot, testing, and Java. Also, you can find my links down there, LinkedIn, Twitter, Telegram, and so on. By the way, there will be a lot of links during this talk. You don't have to memorize all this stuff because the last slide contains QR code. You can scan it, download slides, and see whatever you like later. So what's the plan of the talk? Firstly, I'm going to quickly explain to you the difference between unit integration and E2E tests, their purpose and differences. Also, why do we need E2E tests in general in the first place? What are the automation strategies to run E2E tests? And, of course, there will be a lot of code examples, tests themselves, plus tuned GitHub Actions pipeline. And also, the entire code is available by this link. You can check it out later and see how it works in real life. Part 1, unit, integration, and E2E test. So what are these cases? But firstly, let's quickly discuss the system I'm going to explain you through the entire talk. It's not that complicated, so the whole idea, we have some REST API and API service that accepts a request, HTTP request, and then API service pushes messages to some message broker. A small disclaimer, I'm not advocating for any specific technologies during this talk. It could be RabbitMQ, Kafka, Apache Pulsar, doesn't matter. It's just some message broker. Then there is a GAIN service that consumes messages from RabbitMQ. And then, depending on the content of a retrieved message, there are several options. We can either update gaining data in Redis for future enhancements, or we can just get some data by key and enhance the message and push it back to RabbitMQ. So I think this is more or less clear, not so complicated design, 2 microservices, a message broker, and a cache. So that's basically it. Unit testing can be described like this. So look at these purple and green ovals. They cover only services themselves. By the way, I'm asking the first row, what are the benefits of unit testing, do you think? What can you name? What are the benefits? Well, yeah, unit tests in general. So, well, I think they're easy to write. Easy to write, easy to implement, easy to run in parallel. And if you hire, for example, a junior developer, then most likely they're aware what is unit test. You don't have to explain all this scenario from scratch. And well, unit testing have a lot of advantages. But the main disadvantage of unit test is that we don't check the actual interaction. Because if you deploy something, no matter what environment it is, development, stage, in production, you do not deploy it and assuming, oh, there will be no RabbitMQ, no database, just some stuff. No, it's not happening in real life. And we need to validate those behaviors somehow, and that's why we have integration tests as well. Thankfully, test containers made integration tests easy like a pie, and you see those ovals have become bigger. So now we have the service itself and its direct dependencies. So API service with RabbitMQ and gain service RabbitMQ and Redis. Seems like that's enough. So we have unit tests, we have integration tests. What else do we need to check that the entire system is working? Actually, if you have only integration tests, there are still some anomalies that can occur in your system. For example, I will name it validating backward compatibility. Producer sent message with the wrong format and consumer could not deserialize it. So that's a very common problem in distributed environments because you send something and the consumer could not deserialize it, your whole system doesn't work, even if both consumer and producer have integration tests. I know that there are some approaches to overcome this issue. You can put your schemas in separate repository, you can version them, you can test them, but still, this situation happens. Sometimes you have to deal with them somehow. A client sends request to an existing REST endpoint. Well, for example, there are two separate teams, and one developed some REST endpoint, and you just call it. You are another team. And another team has decided, OK, this REST endpoint is deprecated, so we can just eliminate this one. We wait for like a month, and that's OK. On the contrary, your team lead has gone to vacation, or he or she just forgotten that this endpoint has been invoked somewhere, and again, your entire system doesn't work. So you may have seen these funny pictures on the internet, so many unit tests, no integration tests. I think when we are talking about this distributed system, this could be altered a bit. So you have many integration tests and no E2E tests at all, because each part of your system is working indistinct, but when you combine together, well, boom, boom, nothing works fine. So E2E testing is just assuming that the entire application is just a black box. You don't care how many microservices are there, how do they interact with each other. There is a single input, then some magic happens, and single output. You check the entire business case. What are the benefits? What are the pros of E2E testing, which I referred to? Well, first one is checking the entire business case. Those tests are loved by stakeholders and money people, because if someone asks you, how do you know your entire system works as expected? Oh, OK, here, 100 of unit tests, another 100 of integration tests. I assure you everything is working just fine. He or she will not get it, because I want to see the real scenario. I want to purchase an item, and I want to check that the credit card balance has been withdrawn. Also, you can validate the crucial cases before deploying to production. If you are working on some system, there might be situations when a stakeholder told you, OK, there is some case that bring us the major revenue. You cannot break it, whatever happens. You can introduce new microservices. You can introduce new databases. Do whatever you want, but this case should work every time you do any change to production environment. And E2E tests under these circumstances are very useful. You can set them and run every time you try to make any change to production. What are the disadvantages? What are the cons of E2E testing? Well, it's complex configuration, obviously. Even with test containers, you will see later, it's not that easy to implement. And if you have only junior or even middle-level QA engineers, and you tell them, OK, here we have 10 microservices, just go on, write some in E2E test. We believe in you. Okay, I'll be waiting. He or she won't succeed, I think. High entry barrier. So it's actually as the first point, because not only you have to write those E2E tests, you have to maintain them. It's also a problem. Alone bootstrap and working time. Well, you'll get why alone bootstrap is also a problem later, but working time, I think it's more or less obvious. If you have many microservices, then most probably your tests are asynchronous. You send some requests, and then you wait for some time until the assertions succeed, and it will take a while. Parallel launching is tricky. Again, I'm not saying that it's entirely impossible to start E2E tests in parallel. Of course, there are some approaches, and some of them I'm going to discuss with you later. But anyway, some E2E tests may contradict with each other. For example, one assumes that the Redis cache should be empty at all, and another one assumes that there must be one particular record present. Well, obviously, you cannot run those tests in parallel because they contradict each other, and the result won't be deterministic. And I think that not deterministic test is a really bad thing. If you have this, fix that as soon as possible. Test logs are not enough. You have to examine services logs as well. If your A2E test has failed, well, what you can get from it? The assertion has failed. That's basically it. But I had 5 or 6 microservices. And what did actually go wrong? I don't know. I need logs of the services. I need metrics. I need tracing, like we discussed in the previous section. So all of these things have to be automated somehow, and it's also a big issue. Part 2, what are the automation strategies? How can we run E2E tests on a basis? Well, the first one I called night builds of dev branch. How does it work? There is a developer. He or she creates a pull request from some feature branch and targets it to dev or develop branch. During this pull request, unit tests are being run, integration tests, maybe some static code analysis, etc. If everything passes, then we can merge it to dev branch and take the next issue to develop. Separately, there is E2E testing server that on some schedule clones the repository, checks out the develop branch, and runs up the whole infrastructure, runs the E2E test, and then you can get the result. If everything is fine, you can create a new pull request from develop to the master or to the main branch. Who of you guys actually apply such a similar strategy in their project? Raise your hands. Not so many people, actually. I thought there would be more. And now another question for those who raised hands. Who of you actually likes this approach in their project? Only one hand I see. So you'll get why I said this soon. What are the pros of this approach? What are the advantages? I have to name them as well. Well, firstly, it's easy to implement. There are a lot of complex things in software development, and if there is something that does not require many effort, then I think it's a huge benefit. And also, it's a well-known strategy for majority of developers. If a new developer is in your team, then you don't have to explain this complex scenario that you have built for your E2E test because, well, dev branch, staging branch, testing branch, so everything is more or less clear. But there are a lot of disadvantages as well, and I think one cannot ignore them because, in my opinion, they are crucial. The first one is long response time between feature implementation and E2E tests. When I create a pull request, and if it's being merged, I'm not completely sure whether it's correct, because E2E tests will be run like on the next day or in a few hours, so I have to wait. And this indecisiveness, it really, I don't know about you, but it really irritates me all the time. Bug fixing might be complicated due to code layering. What do I call code layering in this case? Suppose there are 2 features, feature 1 and feature 2. You picked up feature 1, you have developed it, you made a pull request, you merged it, everything is fine. Then you picked feature 2, developed it, merged, and then after you have merged feature 2, E2E test started to work, and suddenly you discover that feature 1 contains some bug. But here's the trick. Feature 2 used the code that you have developed in feature 1. In that case, you have to fix the bug in that way that feature 1 is now working correct, but feature 2 is not broken either. That's a very simple scenario, but it could be even worse in some situation. And when I face it, I really doubt myself being a developer sometimes. CI pipeline does not prevent possible errors. What do I mean exactly by these cases? Feature branch checkouting from the wrong base. For example, there could be dev, staging, testing, master, whatever branch, and you just check out the feature branch from the wrong base. I know this may sound ridiculous to some of you, but I actually seen such situations. There is a new developer coming to a team, there are 6 branches, and he or she being told, okay, pick up your task, make a feature branch, make a pull request, we'll see it later. What branch should I choose? Maybe it's staging, maybe it's testing, maybe it's dev slash 0.1 or 0.0.1, I don't know. Well, he or she creates a pull request, everything is fine, it's being merged, and suddenly, boom, it's being merged to the wrong branch, and it's being deployed to the wrong environment. And we need to do cherry pick and all the stuff we all love. You know, in Russian, there is an idiom for this. The pot, stop boiling, stop boiling, stop boiling, but the process has already been started. Merging dev branch to master branch before test completion. That's the real case, actually. I did not come up with this one. What happened? There was a developer in our company. There was 2 branches, dev and master branch. He created a pull request from dev branch. He merged it, and then E2E test started to work after merging of pull request. And he thought, well, I didn't change much code. Everything should be fine. I didn't have to wait until E2E test completion. I'll just make another pull request from dev to master. No one will notice, so okay, that's fine. And guess what? The production went down because there was a bug, and he didn't notice it. And afterwards, I had a conversation with the tech lead of that project, and he complained to me, oh, this guy, he's so incompetent, we need to do something about it. And I was asking myself, what's the problem with that guy? He did exactly what the repository allowed him to do. He made a pull request, he made another pull request, you approved it, so why do you blame him? Blame yourself, because you set it up, the pipeline, in so particular way that it could be easily broken. So that's my opinion. Maybe you think that I'm wrong, but we can discuss it later. What do I propose instead? So if dev and master branch is not that good, what do I propose instead? There is developer, he or she creates a new feature branch, but here's the thing, we have only one branch in the repository, it's master branch. So master or main, that doesn't matter. Unit tests are being run during pull request, build integration test, and E2E test. So the main idea, when I create a pull request and all checks have passed successfully, E2E tests are also being run for this particular feature branch. So if I make a changes, so I create a service with these changes and I test it with the latest version of all other services. When I merge a pull request to the master branch, I publish Docker image. So each time I merge a pull request, a new Docker image is being created. You can assign a Git hash tag, for example. And I push it to Docker Hub, and it gives me an ability to deploy every pull request that has been merged to the master branch to any environment. So it could be dev, it could be staging, testing, it doesn't matter. I can just click one button in CI pipeline, and that's basically it. So what are the benefits of this approach? It's a quick response before feature implementation and E2E test, because if something goes wrong, the pull request doesn't build, and I see it right now. Incorrect code are not being merged and deployed to any environment in comparison to the previous approach. CI pipeline, in this case, prevent possible errors because, well, you cannot, there are not so many options to make a feature branch. You have only one main, so create a feature branch from this base. The main disadvantage is, how would you do it then, you may ask? Well, it all sounds so fascinating and believing, but how can I actually implement it in my project? And this problem is not a problem, because I'm here right now, and I'm going to tell you, finally, how you can do it in your project. I think you'll be waiting for this moment a lot during my talk. Okay, part 3, implementation of E2E tests. What is the tech stack that I'm going to use? It's Java 17 for tests, JUnit 5 plus Spring Boot test. And again, I'm not advocating for using Spring Boot tests in general. You can use regular JUnit 5 or Spoke or whatever you like. So it's just for convenience. And test containers, obviously, because it's also part of the talk. Here is the suite. It's the base class for all tests that we're going to write later. So how does it work? Firstly, there is a Spring Boot test annotation, nothing complicated here, just to run the whole Spring context. Also, there are 3 additional bins. They're used to send HTTP requests to access Rabbit and access Redis. So I'm not showing you the source code of these facades because they're rather simple. Really, they are nothing complicated there. But if you're interested, you can check out the repository later. Then comes the declaration of container themselves. And you see, there is a small detail. Usually, when we work with test containers, we run, databases, caches, queues, and all this stuff. Here we have Redis and Rabbit, but also API service and gain service. So the business services that are part of the system that we are working on right now are also part of E2E tests as well, and part of test containers environment that we are going to configure right now. Then context configuration is also a Spring annotation. It's used as a callback. So this initializer is a callback that is being invoked right before Spring context creation. So it will give us a chance to get some properties dynamically and override some properties also dynamically. And finally, network. So the network requires some additional explanations. You see, there are 4 containers in our cases. So API service, Rabbit, Redis, and gain service. They need to interact with each other somehow, on the one hand. On the other hand, E2E scenario itself also needs to have an access to those containers because firstly, we want to send HTTP messages to API service. That's the entry point of our system. We want to consume messages from RabbitMQ because that's the output of our system. Besides, we need to have an access to Redis because we want to set up some test data before tests. And one way to achieve this is, firstly, you apply the same Docker network to all containers so they can access each other. And also, you expose their ports to the outside world. So the exposed ports are accessed by E2E scenario, and the local ports are accessed as usually within containers. So it's like Docker Compose, something similar to that. Here comes the code itself. It's going to be a bit complicated, so pay good attention to green rectangle. Firstly, here comes environment. Environment is just a Spring bin to access properties that you can put in application properties or application YAML. Then we create Redis and Rabbit container. Let's have a look at Redis container first. I apply here a generic container because currently test containers does not support a dedicated container for Redis, so just generic container and the required image. Then I expose port 6379 because that's the default port for Redis. Then shared network, so the one thing I just explained to you, and network alias. This one is crucial. Network alias is like a host name for container within this network. It means that other containers may access Redis by the name Redis, so or anyone you choose. Log consumer. Previously, I've told you that logs are also important because if something goes wrong, we need logs of service to understand, well, maybe there are some exceptions or warnings. And test containers provide a convenient API for this. You just provide a log consumer, and then you can pass a regular SL4J Java logger. So and underneath there could be logback, log4j, whatever you like. Direct those logs to console, to file, to logstash. Choose whatever you prefer. So easy like a pie. Then comes RabbitMQ container. It's quite similar to the previous one, but here we have a dedicated RabbitMQ container. Thank you, test containers team, for that. Shared network and network alias, just like before, I'm not stopping here, and with queue. With queue parameters means that these RabbitMQ queues will be created on container start. Why is that? Because when we deploy API service or gain service, then we usually expect that some queues are already present. Usually we do not create them programmatically. So in this case, I'm just creating them right after container is being started, and log consumer as well. Well, finally, we have tuned Redis, we have tuned Rabbit, and then we should start them. So deep start method accepts var args of containers and returns completable future. So I'm calling join to wait until they are started. Why do I do that here? Because when we start API service and gain service, we expect that Redis and Rabbit are already in work. So that's why I start Redis and Rabbit in advance. I'll make a small notice here. Test containers support depends on clause. Just like in Docker Compose, you can set up, so this container depends on that one. You can do the same thing in test containers, but this makes code less readable. So I'm not applying this technique here, but just to tell you, it's also possible. Then here comes API exposed port. So this is the statically assigned port where API service is being exposed to the outside world. You may ask, why do I set this port statically? Because test containers can actually choose this port dynamically. Well, I'll get to this point soon, but just to make it clear. Then comes API service and gain service. Firstly, let's say API service. So this is kind of huge. So I tried to shrink it. So pay, please, good attention to this one. Firstly, we read API service image from the environment. Why do we do it? Because most probably tests code won't change as frequently as business services code. And we want to run the same tests for different versions of our service. For example, I made a new pull request, and it means the new version of service is being created. I need to test those things. That's why I pass API service just like a regular property. Then comes generic container, obviously, because it's some custom service. And then comes environment variables. Just to make it clear, those environment variables does not correspond with test containers at all. It's just a configuration of the service itself. By the way, who of you guys pack their application within Docker image? Raise your hand. Why there are so less people? I thought there would be more. OK, and another question for those who raise their hand. Who of you tune your application with environment variables? I expected everybody to raise their hand. Well, you see, environment variable is the most straightforward way to tune your Docker container, because you don't have to deal with volumes, with external files. You just expose an environment variable, and that's it. So if you don't use it for some reason, I strongly recommend you to reconsider your current situation. Anyways, let's go forward. Then we expose port 8080, because this service is written in Spring Boot, and 8080 is the default HTTP port. Shared network, OK. Network alias, OK. And here comes the magic. You see, my first attempt was doing only those three statements. So I expose port, I set network alias, and everything doesn't work. So I just got I/O error, and that's it. I came up to Stack Overflow with this situation. Then there was a guy who suggested me that I should assign the exposing port statically. And finally, I managed to fix this, but still I don't know why is that. So I tried to dig in, and I have failed. So if you know why is it happening for HTTP requests specifically, then I'll be glad to discuss it. But anyway, let's move forward. Waiting for. Test container need to know when the container is actually ready to accept requests. And here is a nice API for it. So you just say, when /actuator/health endpoint returns code 200, then it means that the container is ready to accept requests. Pull policy. This one is very, very crucial, and it cost me a lot of pain in one place. You see, by default, test container look for images locally. If it's present, OK, I don't need to go to the remote. That's logical. But images also may have latest tag. And as you may know, latest tag can be updated in the remote. And in that case, you will have an outdated version of latest tag locally. So I think you see where I'm going. I have faced a situation, then my tests were not right because they were tested on the wrong images. And the easiest way to fix that, you just tell test containers, always pull. No matter what, I want you to always pull the relevant image from the remote. That's not the best option, and I'll tell you why later, but for now, let's stick with it. And log consumer, okay, that's obvious, not stopping here. Gain service. This one is actually the same as the API service, as you may guess, so I'm not stopping right here because, well, I don't want to repeat the same text over and over again, but if you are interested, you can check out the source code later. Let's move forward. Okay, we have tuned API service and gain service, and now we start them right here the same way. Set properties for connections. You see, when we started Redis Rabbit, we exposed some ports to the outside world, but these ports are assigned dynamically, and we don't know them for now. But we need them because we have to access those containers from tests. Well, we could theoretically assign those values to some static variables that, it's not that elegant way, it's not Spring way. So instead, we're gonna override the properties, and those properties are accessible with a regular value annotation. So that's basically it. How does it work? You click environment, get property source at first because these properties has the highest priority. Test containers, it's just a name. It could be anything, it doesn't matter. And map of the properties. So RabbitMQ address, Redis URL, and API host. Some of you may think, why do I need to assign API host? Because the port is statically bind, as we previously learned. And host should be always local host, isn't it? Well, actually, no, because test containers allows to run containers on a remote host. And in this case, it won't be local host, it will be something different. Besides, there is also test containers cloud, so please don't assign local host statically. You will have an unpleasant experience with that. Always check out the actual host. Test itself, finally, and test is rather simple in comparison to the previous code snippets. So a regular class extends E2E suite, and then GUnit5 test. What do? Firstly, we send some message to a/API/message endpoint. There are some cookie value and MSISDN. For those who don't know, MSISDN is a phone number, actually. And then we wait for 5 seconds until this message is being transferred to RabbitMQ by gain service. Okay, if that succeeds as well, then we send another message. And notice, here is the same cookie value, but MSISDN is missing. Because I assume, as a QA engineer in this case, that the previous binding of cookie and MSISDN were saved. And if I provide just cookie, then it should be enriched. In that case, I expect that MSISDN would be the same. And this test, and one important thing, you have to clear data somehow between tests because you want them to run deterministically. So the easiest way is just clean the whole Redis and reset all messages that you have already consumed in your test. Again, this is not the best approach because in that case, it's kind of hard to run your test in parallel. But anyway, it works for sequential runs perfectly. And if you run this on your laptop, everything is OK. So you may ask me, OK, you've shown us some pretty code snippets. We can run this in our IntelliJ, see a nice report. But how do we actually apply it within a CI/CD workflow? And here comes the final part. Now we are setting up GitHub Actions pipeline and make those tests run on each new pull request. Technical stack is GitHub Actions and monorepository. So this approach works for monorepositories and polar repositories as well. Because in our team, we are working with polar repositories. But I'm choosing monorepository because I don't want to provide you several links. And it's easier for me to get my point. What are the pipeline stages? There are 4 of them. The first one is build. We just run unit, integration tests of API service and gain service and build the artifacts. So nothing special or complicated here. Then comes build dev images. So what we're doing here, from the artifacts that were built on the previous job, we create Docker images and push them to remote Docker registry. The thing is, the tag of those images should be unique on each new pull request change, because we're going to use those tags on the next job. So we create some images, and then we run E2E test with the provided images. And finally comes creating images for production. So it's actually the same as dev images. So the only difference is that you run those jobs only when you merge pull request to master, because it's not so good to push anything under tag latest when you just create a pull request. E2E test, as you have seen, is just a regular Java application, so it's quite convenient also to pack it within a Docker image. GitHub Actions. Firstly comes build rules. They are trivial. You run it every time you merge a pull request and every time you create a pull request to master. Then comes the first step, build. So the name of the job, Ubuntu or anything else, doesn't matter. Then there is a checkout step, so you clone the repository, you set up JDK 17 and run the Gradle command. Honestly, you don't actually need to write this one by yourself because GitHub Actions can generate it. So you just click some buttons in the UI in the browser and it will generate something similar to you. You just copy and paste it. Then comes build def images. This one is rather complicated. I didn't manage to put it within one slide, so please pay good attention to this one. Firstly comes build def images. I set up that it depends on the previous one because I don't want it to run if my unit tests have failed, then why do I need to create any Docker images at all? And then comes outputs. You see, if you exposed an environment variable in def images job, it won't be available on E2E test job. Well, that's by design of GitHub Actions because those jobs theoretically may be run on different nodes. And even now, you can find some strange implementations to overcome this issue on GitHub Actions market. For example, there is a GitHub action that creates a file on some FTP server, and then you download this file in the next job. So it's a brilliant approach, of course, but now you don't have to do all this strange stuff because you can actually expose a variable like this, and it will be available on the next E2E test job. Then comes the step of the current def images job. We check out the repository, we set up Docker, we log into Docker Hub. Of course, you need to provide secrets in your repository, and then define an image tags. Firstly, I define def tag for my Docker images that I'm going to deploy soon. And then comes this strange piece of code. You see, if you expose a variable within one of these steps, it won't be available in the next step. So the isolation is not only between jobs, but within a step in a single job. But I need this variable because I'm going to push Docker images later. So GitHub Actions has also an approach for this. There is a special file called github-env. You just add a new line here, and suddenly your environment variable is available in the next step. And this scary row is to expose this tag to the E2E test job. So this set output name, I just copied from somewhere on the internet. Don't ask me why the syntax is so obscure. The second part of the def images, it's quite easy. All we need to do is just to build a Docker image and push it to Docker Hub. You see here I reference the image tag I declared previously. And I have a Docker file for E2E test, API service, and gain service as well. You may ask, why do I need to update E2E tests? Well, it's obvious why I don't need to update API service and gain service, but why tests? Well, as long as all these modules are placed within a single repository, I don't know what exactly have been changed when I create a pull request. Maybe I change API service and gain service and test as well. Well, theoretically, you can determine this with Git index by scanning it, but actually, that's a topic for another talk. Finally comes E2E test job, and on the contrary, it's quite easy. So, okay, the name of the job, it depends on the previous one. This code snippet means that we are inside the container. So the steps that you see below are run inside the E2E test container. And this container contains tests themselves. We can just run them with change directory, run test, and that's it. Volumes. You see, when you start E2E tests, they also start containers, and they require Docker. But E2E tests themselves are also Docker image. So it means that you require Docker inside Docker. Test containers provide a nice solution for this problem. You just need to assign a volume of Docker socket inside the container. So in that case, test containers will be able to run it on the host. So No complications here. And finally, steps. I remind you that these steps are run inside the Docker, inside the E2E test. So what I do here, I just change directory to app and run E2E test. That's basically it. Build prod images. It's absolutely the same as build dev images. Really, there are some differences, like you push always with latest tag, but anyway, it's completely the same. So I'm not showing you the code, but here is the important part. We run it only during master branch building because we don't want to push anything under latest tag during pull request. Maybe it's wrong, so why would we do that? If you create a pull request in this repository, you see those steps are being invoked. So the last one is skipped because it's just a pull request. But if I merge this, build prod images are also being executed. If one of these fails, so I cannot merge my pull request at all. What is the potential problem for this solution? Long execution time, obviously, because if I run E2E test each time I create a pull request, and there are many E2E tests, they run slowly, then the whole pull request is run slowly as well. What can we do about this? Well, firstly, containers usually container starting takes more time than test execution does. In that case, we know the containers start only once before testing process. That means that we need to make containers to start quicker somehow. How to make containers start quicker? Well, the first rule, independent containers should be always started in parallel. Please pay really good attention to this one. If you have many containers that you have to start in parallel as much as you can. If you start them sequentially, your tests will run very slow. Trust me about this. Also, beware of pull policy. Like I mentioned before, I set up an easy example when you just pull every time a new image from the Docker registry. It's not efficient at all. Imagine that your Docker image size is 500 megabytes, and you pull it every time you invoke your E2E test. And if there are several containers, of course, it will take a lot of time. So one of the approaches is to push a new image if it's a latest tag. Otherwise, you can just look out in the local registry, and if it's present, that's OK. Also, test containers support option with reuse. How does it work? Usually, when you start containers with test containers, when you test complete, containers are being destroyed and all its volumes. But if you apply with reuse option, container will continue to work even when tests are complete. And when you start new tests, they will connect to the existing containers. So, of course, this will help you to increase the speed of your test tremendously. But be careful with this option. It has some drawbacks. I put a link. You can check it out later. How to make tests run quicker? Suppose that we have done everything to make our containers run fast, but still our tests themselves run not that quick. What can we do about this? Well, firstly, put timeouts accordingly and use awaitility. Well, I hope everyone knows what is awaitility. I'm not describing you the whole benefits of this library. I'm just giving you a small example. Suppose I want to wait for 5 seconds until gain service push some message to RabbitMQ, and then I check that this message is present. Here is an example with thread slip. Here is another example, almost identical, but now I'm using awaitility. I wait at most for 5 seconds until this lambda succeeds successfully. In this case, I will wait for 5 seconds no matter what. Even if gain service pushes the message within milliseconds, I will wait for 5 seconds because there is thread slip. But in this case, I will wait from 0 to 5 seconds. Why? Because notice this until function. It's lambda, and its lambda is being invoked periodically. If it succeeds, then awaitility assumes, OK, it's fine, I don't need to check it, so I just quit. If you have thread slip calls in your test code base, so please replace all of this stuff with awaitility, and the speed of your test will increase much. OK, what else can we do? We replaced all thread slip with awaitility, but still it's not that quick as it could be. So the last resort is actual parallel running. you can run your tests in parallel. In that case, of course, they will also run quicker. What are the approaches? Well, the first approach is you mark each message that are produced in your test with some unique ID. And then you assert only messages with the specified ID. If you receive any other message, you just keep it like it doesn't exist. It works, but not for every case. Like I mentioned before, some tests may possess contradictory requirements. For example, one test assumes that the cache is empty, another one assumes that there is one specific row. You cannot run them in parallel because one test will always fail. Or not always, but usually. So the last resort is actually setting up parallel infrastructure. How does it work? Suppose you have 100 E2E tests. You just split them into two parts, 50 tests in each one. And then you run two processes, one with 50 tests, another one with another 50 tests. It means that each process possesses its own containers and do not interact with each other at all. If you have 5 containers and you split by 2, then you have 10 containers. So it requires a lot of resources, but still it's useful and it's easy. How can you do that? Well, if you're a JUnit and Gradle user, so you can apply JUnit tags for this one. So firstly, you configure Gradle like this. So you say that you can include some tag specifically to run your test, and then you just start a separate process for each JUnit tag. JUnit tag is just a notation. You put it on your test class, and that's it. So that's one way, but there are others we can discuss later if you want to. Conclusion. What have we learned today about this topic? Well, firstly, we have tuned an automatic E2E test running on each new change in a pull request. If you run E2E test during pull request build, then incorrect change won't be merged and deployed to any environment, dev, staging, testing, whatever. The approach is applicable to monorepos and polyrepos as well. And E2E tests are not so complicated as it may seem for you now. Okay, as I promised, here is the QR code with the links to the slide. Thank you very much, and if you have any questions, I'm ready to answer them. No questions, or I just don't see hands? Well, I guess no questions, so thank you very much again, and have a nice evening.
Чач, що не умее да кара. Опуснали са ми микрофона. Чач, що не умее да кара. Не умееш да караш. Нямаш лиценз.
Найден го бил скъсал този от въпроси.
Еми да, той Найден прави така, че приключването да стане малко по-бавно. Мерси.
Не бе, долу. В другата зала нещо...
Найден!
Чакаме, да. Чакаме да дойде. Говори нещо с Сашо.
Чакаме Найден. Айде. Аз ще позирам. Да. Чакай. Найден иска само въпрос в другата зала. Иска да приключвам. Де не го знам къде е. Нека има музика. Аз това плейлист трябва да го сваля. Трябва да се... А? И аз пред интернета на тази зала. Айде, айде. Три минути, това ще рече, мисля, че още... Би трябвало да е 20, не 10 минути трябва да е. Какво става?
Това стримваме ли?
Това ще го стримваме ли? Стримваме го това.
Това ще го стримаме ли?
Вижте, ако може, може, ако не...
Давай, давай.
Как се излагаме, а?
То сега ще излезе, после ще го махне.
Да. Да, бе. Само виж, що се заболее и всичко. Ти дай назад и то се разболя. Само да кажа, че чакаме Найден.
Да, сам да презентираш.
Това вече действа. Само да кажа, че понеже чакаме Найден, а той изкъса от въпроси предишния лектор в другата зала, ще се наложи още да почакаме, защото той все още има въпроси. Да скъса лектора.
Иван чака.
Ти дойде.
Чакаме Иван и Мишо.
Добре, Найден се появи. Пуснете пак музиката, моля. Никаква идея. Само да кажа, че има още 4 слайда да довършиме. Нали, още малко съвсем. Сега Найден дойде и ще довърши слайдовете. Вижте, Найден не разбира от Linux. Може ли музиката? Да, значи Найден по някакъв начин влезе в много секюр компютър на Мишо.
Незаключен компютър.
Да, значи понеже това е Linux, той не успя да направи нищо с него.
Не можахме да пуснем.
Добре, значи още някакво.
Това май не е първия слайд, бе.
Какво да си... Кой къде да си сложа микрофона?
Чакай да спамна тогава представление. Не, друго ще спамвам. Да знаете сайта... къде има презентация? Така, сайта на Джуга, ако някой не го знае, jug.bg.
Да, много е зле.
И е WordPress. И тук има евенти. Може да гледате какви евенти предстоят, ако имате интернет.
Предстоят... Чакай, не кажете, че не предстоят в момента.
Добре, бе, има някакви евенти. Включително има и някакви Java бири. Отделно има java.beer, нищо, че няма
продуктово позициониране.
HTTPS и пише not secure. Не е нужда да е secure. Където също може да видите какви са следващите Java бири. Java бири са само пиянски евенти. Никой няма да ви говори презентации. Пиете и си ходите. Така, следващия е на 13 юни, между другото, в София, в Витамин Б. Всеки път има спонсор, в случая OnToText, но може да видите какви преди това е имало и какво сте изпуснали.
The Bulgarian speaking people can understand what you want.
So what I'm trying to say is you can check the JPrime website and the JavaBeer website for more local events that are smaller. And also I will just spam that in 29th, right?
Yeah, 29th
of August. In Maimunarnica there will be a summit JavaBeer, which usually means we drink a lot of beer with French fries. We are not sure. There will be French fries this year.
Bulgarian fries.
It depends on how more expensive the beers have become since the last year. The last year we actually drink beers for 7,000 leva.
And we have, by the way, if you are decision makers in your company, we have just one sponsor so far for JavaBeer Summit.
No, that's not true. We have 3. Anyway, but yeah.
So we are looking for sponsors, not for speakers.
And we have a beautiful and bootless. So with a boot and without a boot. Anyway, the important thing is if you can come to the stage and there is again no agenda. You can speak whatever you want. So you can get drunk and go to the stage and say,
it's our Hyde Park. If you know what Hyde Park is,
Чакай, спри малко.
it's our Hyde Park.
Хора там, що се стоите там?
Давайте, вижте колко място има.
Има място, има там. Не те
блокира. Има много места от дясно хора. Не знам, защо всички са бут отляво. Кое има отляво?
Защото тази отворени вратите.
Добре, някой да отвори врата там, моля.
Okay, and I also changed this to be unconference. Huh?
Okay, can we start the slides? I'm here.
Yes.
I'm not sure where
we
they are.
We will try to close this conference.
Yeah. Okay, so let me start because I'm a bit, For everybody that doesn't speak Bulgarian, you won't understand any word on the slides.
Although it's
not because they are in Cyrillic alphabet, but because they are in Methodian alphabet. And whoever speaks Bulgarian knows what I mean. Okay, go on.
Шлёка. No. We have a tradition. Metodievitsa, yes.
Even the Bulgarian-speaking people will not understand them because Misha wrote them.
And it was not Leiden who wrote the slides.
Yes.
Otherwise, I would understand why they are
Somebody try
like
to
this.
speak next slide, please.
Okay, that's the closing. Thank you. Thank you for coming and thank you for staying for so late.
Yay!
And,
Yay!
Here's how
developers.
here's how we saw this event.
Yeah, this is the conclusion of the conference, basically. So these slides are more like.
So they are not ordered slides, just to let you know. Yeah. Yes, this time Shatra did work. Okay, Shatra is always a big challenge for us. Previously, it was very sunny. Now it was very rainy. So at the next time, we're gonna fight the sun and the rain. This time, it did not like collapse. So, so the speaker, where is the speaker? Yes, he's not here, but well, it did not collapse, and because of the rain, it was very sleepy atmosphere. Yes, we will next time it will be not so sleepy.
Yeah. If you work for a company that's going to be a speaker, ask them to give umbrellas. This way, we are sure it will not gonna rain.
Yes, it's also
right?
called for sponsors.
So make sure to have an umbrellas for every year going forward.
Yeah,
yes, and if you're on booth, please provide umbrellas, not just games.
Also find out why this guy is sleeping.
Please shut up. You. Okay, so next time we're now something serious. We know that the screen was not really bright. So next time we are maybe trying for something LED, and Peshu, very special Peshu Velikov, he's going to show you how to put sunglasses if the screen is too bright. Yeah, in 2017 he did it. So yeah.
Yeah, but still, just in case, always use white background, right?
Yeah.
This is we will add some guidelines for all the speakers.
101, come on.
There was a lot of black background stuff, and it was unseeable.
Advanced. Okay, we were not 1,200. We were only 1,100 because this guy is very.
There's a special slide for this guy, but yeah.
Yes, this guy told us we were not exactly 1,200, but it's just because of him we wrote this slide. We were 1,200, and it was awesome. Yes, it was awesome. Yes, yes, yes.
Yeah, I'm really happy about this slide because I know a lot of conferences, they say, we were 5,000 people in Sofia, come on.
No, I have seen, we were 3,000 people at Interexpo Center. How the fuck?
Anyway. Yeah.
Yes, or even, yes. By the way, now this slide, I think that, speak with your telephone.
So please, all the speakers, please stand up. Please stand up.
Speakers, please stand up.
And everybody, please,
big applause. Yes. Thank you. Thank you.
Thank you very much.
Those were the only speakers which survived JPrime. Yes. Yes, really, we did, now seriously, we did a really great job for like, not exactly recruiting speakers, but we talked to many speakers. We invited them because, once again, as I told in the beginning, we want to bring you the best knowledge from the best people, and here they are. And I hope that you really liked it. Thank you.
Thank you. Yeah.
Yes, now.
Now.
Please.
Lucin.
No, just a second. Just, you know, this moment, this is the changer of everything. This device there and the other device nearby. It has saved our asses. Yes, asses. Yes, this guy deserves special applauses for making our registration the best one in the world. Yes, please, applause, more, even more.
Yeah, I can tell you some history. Can bring you some history about this. So, not sure how many of you went to Devox, but Devox and not just Devox, but at Devox they have this automatic registration process there. We were traveling in the tram together with Dochin this last autumn actually, and he told me, why don't we have the same registration as Devox?
Because it's complicated.
Who will implement it, man? Come on. I will implement it. Okay. And he did it.
He implemented it himself.
First, I asked my great friend Roberto Cortes from J Nation Conference from Portugal in Coimbra, asked him, how do you do it? And he told me that JBCN and all conferences use some paid software.
Yes. Hold my beer.
We are Bulgarians. We never give money for software.
Yes.
Yeah, and he did it.
So everything we use is pirated or written by ourselves?
by the way, the software
yes, it's open source, so you can see it in the Begejuk GitHub repo. You can check it, see how it works.
So John, maybe there's no more need to pay the price. Yeah.
Yes.
For
so we
now
we care for budget of other conferences too. Yes, and you see, it's written in Swing, by the way. Who else could write Swing? This guy is awesome.
Yeah, it works on Windows, by the way. I have to bring my Windows
Swing.
machine.
So it works on Linux. I don't have Mac, so I wasn't able to test it, but it works on Linux also.
But it started right away on my computer. Without him, you have to tweak a little bit the printer. Anyway.
Yes, anyway, once again, big applause for this guy.
I didn't commit a suicide.
Yes, you see, Java is usually
really
beer.
close. It was really close. I mean, if you look at your badges, you see at the end beer and networking is just the networking part.
Is it over? No more beer?
Yes.
Really?
You have to drive to Plovdiv. Why do you care?
No, I just wonder how much beer we should get next year.
Yes.
More than this. Okay. And the water is
Now back to reality.
twice.
We know about the issue with the water. We don't know how we actually drank 4,000 waters, but we didn't actually count it how much we got. So
Last year we ordered 4,000 waters. It was hot last year.
It was more than enough?
And it was more than enough, exactly. Yeah. Now they finished after the lunch, and then we went twice to buy some more. So 4,400 waters. Could you please go back to the previous slide?
Why do you drink so much?
And
stop with this water.
And 2,100 beers. So you have to take care the next year more.
You see, none coffee, just beers and water. What's wrong with you, man? Yes.
Big thanks to the sponsors.
Yeah. So every year, let me take this. Every year I tell the sponsors, please do not put flyers in the baggage in your gifts. Every year we got tons of flyers. This year there was just, I think, 1 or 2 flyers, and they were for some games where you scan the code and you play in a game. So the sponsors this year were really inventive, and they did a great job on the entertainment zone, those of them that could do it, and in the package. So yeah, big shout out to them. Thank you.
Thanks. Yes.
Yeah, we have an issue that kind of the tickets are always sold out, and then some people start calling, oh, can I buy 10 more tickets and blah, blah, blah. So next year, actually, it is not confirmed, but we will have a late ticket price or whatever. So the last week before the conference, the price of the ticket will be like double price. So if your HRs are doing nothing, like most HRs, they will basically,
What does an HR do after they
die? After they die.
They retire. After they retire.
Again, nothing, right?
Nothing again.
Yes. So once again, there's another option. Now, as we have this unique registration systems, we can handle, new registration just minutes before.
But
just give me a second.
Okay.
So if you want to support us more, buy the last minute, please.
Just one thing. Imagine, so I'm not sure how many of you have seen what happens here on the day before the conference. So all the people in the blue t-shirts we are here and doing some stuff, and people are calling me on the phone. Okay, I'm bringing a little bit. I'm coming a little bit late with the presents, and everything's bad. And an HR, a random HR, sends me an email. We have to change a person that he can't come, and she will go in his place. And the HR expects me to read this, to check my email. Come on.
Yeah. But still, again, to be clear, we never check the actual names, so you can be, I don't know, Penka if you want to, or just have a ticket. And yeah, we also, if you can also share the ticket for the next day with a colleague that will go for day 2 because you are very busy or lazy or whatever.
Yes,
Skrunza or whatever. So yeah, there is no need for such changes.
Heinz.
Heinz, I have stolen your
I can
photo.
understand this, the first word.
Okay, just one thing. This is a copyright by Hans Kabutz.
Yeah. So should we? So the first line says that Heinz says that this is actually what the summary of the conference.
The essence of the conference.
He's saying that there is no way this to happen in Europe. So we wonder where are we then? But yeah, and also to be clear, Heinz is the speaker, not the ketchup. Okay, so. Yeah, and also yesterday he was saying, I think to Misho, that he needs to write the newsletter, Java Specialists, because it's the last days of the month. But he said, you're very cool, so I will just come, I will just stay to talks and drink, and yeah. So he actually sent it today, so maybe it was a bit late. But yeah, and we hope to invite the Bulgarian Juke delegation to JCrit, which is the best conference I have ever been.
Unconference.
Because it's not actually a conference. And some people speak about Java, but you can ignore them and just enjoy the other stuff.
All the things we said, he will never invite us there.
Yeah, so we can just come without invite.
Yeah. Okay. Workshop. Finally, on the workshops, you were able to breathe. Yes, there was enough oxygen. Yes, now, well, there's some issues again with this projector, because I don't know, somebody built a wall. Not a wall, like a door. I don't know why they built a door where the projector should be. But it was barely not visible, but maybe someday, if you sponsor us enough, please, we will get an LED. But otherwise, maybe there will be another door. It depends.
Yeah. but it was an improvement. Yeah, you can see anything on the projector, but maybe because we ordered it while we were on the beach, and yeah, and Michel was saying, is this projector fine? Yeah, order it. So it was not the greatest projector, I guess.
Yes, and you see, we don't like windows, we like doors. Go ahead. I don't know who will tell about
this. This doesn't mean personal computer, but what was it? PC?
Politically correct.
Politically correct. Yeah, we were asked why last year we were not politically correct. Why everything was whatever. Why all of us, the 6, are just guys? And I don't know. Maybe because women have better things to do. I don't know. But in any case, yeah.
Yeah,
we have a slide for that.
Shout out to all lady lecturers,
speakers,
and
yes, for all lady speakers.
All
Thanks
the ladies.
for coming.
Yeah, and also I was told that in Bulgaria, I think the female developers is like the highest among Europe. So again, that's actually great. Yeah, please come and speak. Please do conferences.
And I want to add that I got a comment from some of our foreign guests here that they've never seen so big attendance of women on a technical conference anywhere in Europe. So thank you again for all the women to being here with us.
The politically correct thing. Okay. Anyway.
Now,
so the biggest thank you is for the volunteers. Come on.
Come on, volunteers.
Come on. Come to the
stage.
Please, come on.
Volunteers, come to the stage. Everybody. Come to the stage. to the stage. Don't stop applauding. Don't stop applauding. More noise. More applause.
It's kind of nice to, instead of me going to buy beer or water to Metro, to tell to one of them and go buy power cords or go buy water, and that's what happened today. So thank you.
Thank you so much. These people work for free.
Yeah, and also if someone wants to be a volunteer, you can drop an email to Ivan, and next year you can basically come and join the registration and all the craziness.
And the day before, no, for the day before, Riccardo promised to give us a robot to do the stuff, right?
And the conference will be free.
So once again, those are the people who made this conference. Thanks so much.
Yeah, and this is a big thank for everyone that is here and everyone that stayed and everyone that joined the conference, because without actually the people to actually come and listen to these talks, there would be no conference. And I think every year we are around 100 people more than the previous year. So it's a big improvement. We were only 350 people for the first year. So, yeah.
Thank you.
Thank you so much. That was it from us.
Andiamo a birra.
I really hope that you like it.
Thank you. And see you next year.
I think the most important thing here is we have your emails, so we will spam you. Don't leave your companies or use your personal emails. Anyway.
Thank you so much.
Thank you.
That was it. Bye-bye.